When you live in a society, it's really important to have conventions that everybody follows. An example of one such convention is that in the UK, we all drive on the left. If everybody chose their own side of the road to drive on, it would be absolute chaos and people would be crashing into each other. In our mathematical society, we have algebraic conventions that we follow. Here are 3 of the algebraic conventions that we follow. We tend to use lowercase letters to represent unknown numbers. In print, such as in textbooks, we have italics for those letters. When we're handwriting them, we use a very special type of X. It looks like this, and that's so that we can tell it apart from a times sign. Another convention is that in maths we really like the letter X, and we use it an awful lot. The history behind this is fascinating. If you'd like to look it up, please do. I'm now going to show you some very important conventions that we use when simplifying algebra. Here we've got A plus another A. That gives us a total of 2A, and we write that like this. Notice that the number is at the front. Now this actually means 2 times A, but another convention is that we don't put the times sign in here. So here, where we've got 3 times A, we can just write it as 3A. For this one, it's really tempting to say A times 3 is A3, but the number always comes first, so this is 3A as well. If we have A divided by 2, we write it like this, A over 2. This line here actually means divide. Another way of writing this would be half A, because when you're dividing A by 2, you are actually halving it. Finally, when we've got 1A, we just write A, and you'll notice we had that up here. This A was actually 1A, and so was this one. Here are some questions for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. We're now going to look at a typical exam-style question where using algebraic conventions is really important to getting the right answer. I'm asked to write this using algebraic notation. It starts off saying, I think of a number. I can use any letter I want for an unknown number, but I've already said that in maths we really like using X, so I'm going to use that. Now I want to multiply it by 2. If I multiply this by 2, I get 2x. Then I want to add 4 to the result, so I get this result, and I add 4 to it. This is my final answer. For this one, I'm told to think of a number again. Now, although we love x, we don't have to use it, so this time I'm going to use n for the number. I want to divide it by 4. Divide it by 4 would look like this, and then I want to subtract 7. That can go on the end. Notice on this one I did it a slightly different way and got to the answer straight away. Here are some for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In all of mine, I've used the letter X. You can use any letter of the alphabet that you want to. Now, these questions look really similar, but they're actually slightly more difficult. We start again with I think of a number, so I'm going to use an X. I want to add 3, so I get X add 3. Now I want to multiply by 2. It's really important to multiply everything here by 2. The way to do that is to group everything together with a set of brackets and then multiply it by 2 by putting a 2 at the front. Now there is actually another way to do this question. We start with I think of a number, so that's an X. Add 3 to get X add 3. And when it says then multiply by 2, we can multiply everything here by 2. So multiplying X by 2 gives me 2X, and multiplying plus 3 by 2 gives me plus 6. This is also a right answer for this question, and these two answers here are actually equivalent. When two things are equivalent, we can show it using this symbol here. For this one, I start in the same way with my letter. Again, I'm going to use an x. I want to subtract 7, so I get -7 on the end. Then I want to divide by 4. Now, I've got to make sure I divide all of this by 4. The way I do that is by putting one long line underneath to divide all of it. This line actually acts as a bracket for the top, so I don't need to put brackets in. Remember, we're dividing by 4, so we put a 4 under here. The other way of doing this question is again to start with our letter, so let's have an x. Subtract 7, so we get x minus 7. When we want to divide by 4, we can divide both of these things by 4. So I would have x over 4 minus 7 over 4. This is also a correct answer, and again, these two separate answers are equivalent. When you do this type of question, you don't have to write down both, just pick which one you prefer. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is a set of axes. We've got our x-axis here and our y-axis here. This point here in the centre is called the origin, and we label it with an O. There are two things you need to be able to do. You need to be able to plot a point given a pair of coordinates, and you need to be able to write down the pair of coordinates for a point. Let's say I was asked to identify the coordinates of this point here. By convention, we always do the x-coordinate first, so I need to look how far I need to go along the x-axis until I'm level with the point. I can see that that's 3, so I write this down first of all. Then we do the y-coordinate. I go down this time, and I go down to -2. I always separate the two numbers with a comma and put them in brackets. This is a pair of coordinates that identifies this point here. If I was asked to plot the point 2, 4, then I would go across to 2 on the x-axis and then up to 4 on the y-axis. Remember, x always comes before y, so this point would be here. In primary school, you might have learnt this as going along the corridor and then up the stairs. Here are some questions for you. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more questions for you. You'll need to copy out a set of axes onto squared paper. Press pause and have a go. When you're ready, press play. Here are the answers. Here are some more questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. When we're asked to simplify an algebraic expression, that means we've got to write it in the most compact form possible. If I've got 3x add 2x, I know that that's 5x. 8x take away 5x would be 3x. Here, remember that this x on its own is actually 1x. So I've got 4x add 1x, and that's 5x. In this one, I've got 7x take away 6x, which is 1x. But convention says that when we've got 1x, we actually just write x. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Now these questions look more difficult, but they're actually not. For this first one, I've got 3 somethings plus 2 of the same thing. So I know I'm going to have 5 of them. So it's 5xy. Here, I've got 9 of these and 3 of exactly the same thing. So I've got 12 of them altogether. For this one, I've got 5 of these, take away 4 of them. So I've got 1 of them left, and I just write the letters. Here are some of those for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. When we come to this type of question, we need to remember that we can only add x's to x's and y's to y's. So the first one here, I've got 2x, add 3x, so that's 5x. And I've got plus 4y plus 8y, so that's plus 12y. This is the simplified version of this. For the second one, I've got 3x, add 4x, so that's 7x. And I've got add 2y, add 6y, so that's add 8y. Here, I've got 6x and minus x. Remember, this is really minus 1x, so that gives me 5x. And I have plus 5y minus 4y, which gives me plus 1y. Remember, we just write plus y. On the last one, I've got 2x plus 7x, that's 9x. And I've got minus 3y minus another 2y. So, using the number line at the bottom, we're starting at minus 3 and subtracting 2. We get minus 5, so we have minus 5y. Points to remember are that you can only add or subtract terms that have the same letter. If you have a letter on its own, that means that there's one of them. And when you write your answer, don't forget to include the linking sign here, whether it's a plus or a minus. Here's a final set of questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. When we multiply x by x, we can write the answer as x to the power of 2. We can also say this as x squared. When we multiply x by x by x, we can write the answer as x to the power of 3. And we can say this one x cubed. When we're multiplying 4 x's together, in the same way, we can write x to the power of 4. There isn't a special way of saying this one, you've just got to say x to the power of 4. So the power simply tells you how many x's you are multiplying together. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. When we're asked to simplify something like this, we need to remember that x squared is x times x, and x cubed is x times x times x. And we want to multiply these together, so the times sign goes in here. We can now see that we've got x to the power of 1, 2, 3, 4, 5. So we can write x to the power of 5. So for this one, we've got x to the power of 4 multiplied by x to the power of 6. And the multiplication sign goes here. We can see that we've got 10 x's altogether, so it's x to the power of 10. You might have spotted that there's actually a quick way to get these powers. Looking at this first one, 2 plus 3 gives me the 5, and on the second one, 4 plus 6 gives me the 10. So we don't need to write out all the x's every single time. For this last one, we need to remember that this x here is actually x to the power of 1. Now we have 1 plus 3, so that's 4, and the answer is x to the power of 4. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. We're now going to look at simplifying slightly more complicated expressions. We already know that x times x is x squared. So when I've got a question like this, I can do the 2 times the 3, which is 6, and then I know that x times x is x squared. So the answer is 6x squared. For this one here, 5 times 4 gives me 20. And when I'm multiplying these together, I remember to just add the powers. So I've got 2 plus 3, that's 5, so it's x to the power of 5. For this one, this x here, we already know is x to the power of 1, but it's also 1x to the power of 1. So I've got 1 times 5, which is 5, times 2, which is 10. Then I've got x to the power of 1, x squared, and x cubed. So that's x to the power of 6 altogether. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more complicated expressions now, where we might have more than one variable. We know that 5 times y is 5y. For this one, I've got 3 lots of 2y, which is 6y. If you want to do this quickly, you can just do 3 times 2, which is 6, and then put the y back on. For this one, x times y, we just write as xy. Here, we've got 2 times 3, which is 6, and x times y, which is xy. Now this one looks much more complicated, but we still tackle it in the same sort of way. We've got 6 times 2, which is 12, x to the power of 4 multiplied by x cubed, remember to add the powers, so we get x to the power of 7, and y cubed multiplied by y to the power of 5, we add the powers to give us y to the power of 8. In the same way, here we have 2 times 4, which is 8. This x here is x to the power of 1, so we've got x to the power of 1 times x squared, that's x cubed. We've got y cubed times y, which is really to the power of 1, so that's y to the power of 4. So to summarise, when I'm multiplying, obviously I multiply the numbers, but when I get to the powers, I can just add them. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. We're now going to look at a slightly different type of question. Here, I've got all of this in the brackets to the power of 3. So if I write that out, I've got x to the power of 4 times x to the power of 4 times x to the power of 4. I've got 3 of them, look, because there's a 3 here. Now, using my normal rule, I can add the powers. And 4 add 4 add 4 is 12. So I've got x to the power of 12. So for this one, I've got x squared to the power of 7, so I want to write x squared multiplied by itself 7 times. Remember, we can now add the powers together. That's going to give us x to the power of 14. Now obviously we don't want to be writing out all of this every single time, but fortunately there is a quick little trick. If we look at the first one, we've got 4 and 3. If we multiply these together, we get 12. On this one, 2 times 7 is going to give us the 14. So when faced with a question like this, you can just multiply the powers. The last one is a little bit different because I've got a 2 inside the bracket. So I need to write this out 4 times. So I've got 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. And then I can add the powers just like I usually do to give me x to the power of 12. If we look at the trick for this one, we can see that to get this 12, we can do the 3 times 4. But for this 16, I've got to do 2 to the power of 4 properly. So, looking at these two questions now, I'm just going to use the tricks. On this one, remember we multiply 5 by 6, so we get x to the power of 30. For this one, I've got 3 cubed first of all. 3 times 3 is 9, times 3 is 27. And then I can multiply the powers, so that gives me x to the power of 8 times 3, and 8 times 3 is 24. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Remember, when we were multiplying, we could add the powers. Division is the opposite of multiplication, so when we're dividing, we can subtract the powers. This x here is really x to the power of 1. So to get the answer, 5 take away 1 is 4, so it's x to the power of 4. So here, subtracting the powers, 6 take away 2 gives me 4, so that's x to the power of 4. And here, subtracting the powers, 9 take away 3 gives me 6, so that's x to the power of 6. Just out of interest, if you're wondering why this works, I'm going to show you with this question here. X to the power of 6 is 6 x's multiplied together. And I'm dividing this by x to the power of 2, which looks like this. I can now cancel out some of these x's, this one with this one, and this one with this one. This leaves me x to the power of 4. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. On this first one, we've got 7 take away 6, which is 1. Remember, we don't write x to the power of 1, we just write x. If you see questions like these, remember that this line here just means divide. So we've got x to the power of 5 divided by x to the power of 3. When we're dividing, we subtract the powers. 5 take away 3 is 2, so the answer is x squared. For this one, I'm going to do the top first. So I've got x to the power of 2 times x to the power of 6. Remember, when you're timesing, you add the powers, so that's x to the power of 8. I want to divide this by x to the power of 5. When we divide, we take away the powers, so that gives me x to the power of 3. So for this one, do the top first, that's x to the power of 7. Then the bottom, remember this is really x to the power of 1, so we've got x to the power of 5. Then we're dividing, so we take away the powers and we get x squared. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now these ones look really complicated, but if we stop and think for a minute, we can see that we've got x plus 3 in the bracket here to the power of 5, and we've got exactly the same thing in the bracket to the power of 2. So I can just subtract the powers because I'm dividing. 5 take away 2 is 3, so I've got the thing in the bracket, that's x plus 3, to the power of 3. So for this one, if I put a bracket on the bottom here, I can see that I've got x plus 1 squared divided by x plus 1, which is really to the power of 1. So we can subtract the powers. 2 take away 1 is 1. So I've got x plus 1 to the power of 1. Remember, we don't write that, so that is actually the answer. You can also write this without the bracket as x plus 1. Both of these answers would get you full marks on the exam. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. We're now looking at some more difficult division questions. So for this one, I've got 8 divided by 2 first of all, and that gives me 4. And then I can subtract the powers. That gives me x to the power of 3. On this one, remember that this line is telling you to divide, so start with 12 divided by 6, that's 2. Then you can subtract the powers, and you get x to the power of 6. For this one, I'm going to do the top first of all. I've got 4 times 2 on the top, so that's 8. And here, this x is really to the power of 1, and I'm going to add the powers to get x to the power of 6. I want to divide this by 8x squared. Now, 8 divided by 8 is 1, and x to the power of 6 divided by x squared, we subtract the powers to give us x to the power of 4. Now, convention dictates that when we've got 1 in front of something like this, we don't actually write it. So I'm going to change this to x to the power of 4. Some exam boards will actually take a mark off you if you put the 1 in, so it's much safer to write your answer like this. Here's your final set of questions to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. In this clip, we're going to be looking at function machines. This is a typical one. You can see it's got a sequence of 2 operations, and we have to do them in this order. We can put numbers in here, we sometimes call that the input, and we get numbers out here, sometimes called the output. I want to fill in this table here. It's asking me to start by putting in a 1. So I've got 1 times 2, that's 2, and then I want to add 3, which gives me 5. So I get a 5 out. So 1 goes in, 5 comes out. I want to know what happens if I put 5 in. So I start with 5, times by 2 to get 10, and add 3 to get 13. So 13 comes out when 5 goes in. Now I have a 0. So 0 goes in, 0 times 2 is still 0, and then I want to add 3. That gives me 3. So 3 comes out. Finally, I've got minus 4. So I put minus 4 in, and I want to times this by 2. Now we know that 4 times 2 is 8, so minus 4 times 2 is minus 8. Then I want to add on 3. Minus 8, add on 3, is minus 5. So minus 5 comes out when minus 4 goes in. So to summarise, a function machine will look something like this, and it will usually be a series of operations that you need to perform in a certain order. You'll often be given a table and you'll be asked to fill in inputs or outputs. Here's one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this one, I start off in my usual way. I've got a couple of inputs here and I need to work out the outputs. So 2 goes in, times 4 is 8, take away 6 is 2, so 2 comes out. 10 goes in, times 4 is 40, take away 6 is 34, so 34 comes out. Now when I get to this part of the table, I'm given the outputs and I've got to work out what the inputs were. Now I could do it by guessing a number, putting it through here and see if I get 6. But this might take me lots of goes, so I'm going to think of a way that's going to make it faster. And I can do that by reversing the function machine. So I'm going to reverse the direction and reverse the operation. So minus 6 will become plus 6 because that's the inverse. Reverse the direction and reverse the operation. So times 4 becomes divide by 4 because that's the inverse. So now I want to put 6 in here. 6 plus 6 is 12 and divide that by 4, I get 3. So 3 must have been the input. I can check this by putting it back into the original function machine. I've got 3 times 4 is 12, take away 6 is 6. So yep, that works. I also want to put the number 26 through my reversed function machine. So I put the 26 here. I need to add on 6 and that gives me 32. And then I want to divide by 4 and that gives me 8. So the input must have been 8. Let's check that. Put the 8 in here. Times by 4 I get 32. Take away 6 and I get 26. So that one's right as well. So to summarise, on this kind of question, where you're given outputs and you need to find the inputs, you need to reverse the flow of the function machine and reverse the operations. Here's one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now the question is slightly different. I still have my function machine, but I'm told that the number that goes in is an unknown number and we're calling it x. I need to work out what comes out. If x goes in, the thing that comes out is going to be a piece of algebra. So I've got x times 4, and that's 4x. And then I need to take away 6, so I get 4x minus 6. In this one, again, x goes in. So I've got x take away 6, I write that as x minus 6. And then I want to times all of this by 4. So to times all of it by 4, I need to put it in brackets and then put the 4 at the front. Just out of interest, at this stage, when I want to multiply by 4, I can do it by multiplying each individual thing by 4. So multiplying the x by 4 gives me 4x, and then multiplying the minus 6 by 4 gives me minus 24. These two answers are equivalent and they're both acceptable. Here are two for you. Press pause and have a go. When you're ready, press play. Here are the answers. On the second one, you can have either of these. You don't need to have both of them written down. Here's another question for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. In this clip, we're going to be looking at number sequences. A number sequence is defined by two things. The first term of the sequence, by this we mean the first number in the sequence, and the term-to-term rule of the sequence. By this we mean how we get from one number to the next number. So let's say the first term of a sequence is 3, and the term-to-term rule is add 2. From this, we can then work out all the numbers in the sequence. We start with 3, and we add on 2 every time. So adding 2 gives me 5, then 7, then 9, then 11, and so on. Obviously, in an exam situation, they won't ask you to find every single number in the sequence. It will usually just say, work out the first 5. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here are some more for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Now in this question, I want to describe the term-to-term rule for the sequence. So I need to look at the numbers carefully. It's starting at 6 and going to 10, so I can see that that's add 4. But I can't just take this for granted that that's the term-to-term rule. I need to check it. So let's see if it works here. If I add 4 from 10, do I get to 14? Yes, I do. Add on 4 again. Yes, I do get to 18. And add on 4 again. Yes, I do get to 22. So the term-to-term rule is definitely add 4. I want to find the term-to-term rule for this sequence as well. So if I look here, I've got a 1 and I've got to get to 3. So let's try add 2. If I add 2 onto 3 though, I get 5, not 9. So that can't be right. So I need to think of another way of getting from 1 to 3. I could times by 3. Let's see if this works. So if I times 3 by 3, I do get 9, so this one's looking good. If I times 9 by 3, I do get 27, so I think this is right. I can check it one more time if I want to. 27 times 3 does give me 81. So the term-to-term rule is multiply by 3. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. To expand this, everything inside the bracket needs to be multiplied by whatever is in front of the bracket. In this case, it's a 2. So I need to do 2 times 3x, which is 6x, and 2 times 4, which is 8, and in the middle, we've got a plus. For this one, I'm multiplying by 3, so I've got 3 times x, which is 3x, and 3 times 2, which is 6, and this one is a minus. For the last one, I've got to multiply everything inside the bracket by 2x, so I start with 2x times 4x. 2 times 4 is 8, and x times x is x squared. Now I have 2x multiplied by 3y. 2 times 3 is 6, and x times y is xy. And this one is a plus. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. In question D, when we multiplied x by 1, we got 1x, but we never write 1x, we just write x. Factorization is the opposite of expanding brackets. A typical expanding brackets question would look like this. Everything inside the bracket needs to be multiplied by 2. I would have 2 times x, that's 2x, and then 2 times 4, that's 8. Now factorization is the opposite process. So if I go from here to here, that's expanding the bracket, but if I go from here to here, that's factorization. So I need to say to myself, what's the biggest thing that goes into 2x and 8? And that's 2. I know that I'm going to have a set of brackets, and because there's a plus sign here, I know there's going to be a plus here. Now what do I multiply 2 by to get 2x? The answer's x, and that goes here. What do I multiply 2 by to get 8? That's 4, and that goes here. This is the answer. So for this second one, I need to find the biggest thing that goes into 6x and 9. That's 3. I have my brackets, and because there's a minus here, I have a minus here. Now what do I multiply 3 by to get 6x? The answer's 2x. And what do I multiply 3 by to get 9? The answer's 3. The biggest thing that goes into x squared and 5x is x. This time I have a plus, and I say, what do I multiply x by to get x squared? X. And what do I multiply x by to get 5x? 5. I can check this answer by saying that x times x is x squared, and x times 5 is 5x. For this one, the biggest thing that goes into 4x squared and 2x is 2x. I've got a minus this time. What do I multiply 2x by to get 4x squared? I know it's going to be 2x, because 2 times 2 is 4, and x times x is x squared. Now what do I multiply 2x by to get 2x? That's going to be 1. I can check this one as well. 2x times 2x is 4x squared, and 2x times 1 is 2x. For the last one, remember we're looking for the biggest thing which goes into both of them. This is going to be 4x squared. What do I multiply 4x squared by to get 8x cubed? That's 2x. 4 times 2 is 8, and x squared times x is x cubed. What do I multiply 4x squared by to get 12x squared? That's 3. 4x squared times 3 is 12x squared. Just out of interest, there is a common mistake that people make with these last two here. Instead of taking out the biggest possible thing they can, sometimes people just take out the 2. They would have 2x squared minus x inside the bracket. This isn't actually the right answer. When you're factorising, to factorise fully, you need to make sure you take out the biggest possible thing, so you would have to include the x as well. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. I'm being asked to find the value of 5x when x is equal to 7. The first thing I need to do is remember that there's an invisible time sign here because 5x really means 5 times x. So I've got 5 times x and x is 7. Now 5 times 7 is 35, so the value of 5x is 35. In this one, I want to find the value of 3x when x is minus 5. Again, we've got an invisible times sign, so I've got 3 times x. Now this time, x is a negative number. Negative numbers are a bit special, so we put them in brackets. 3 times minus 5 is minus 15. So the value of 3x when x is minus 5 is minus 15. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This time, I want to find the value of x squared when x equals 4. I need to remember that squaring a number means I'm multiplying it by itself. So x squared is actually x times x. Remember, x is 4, so I've got 4 times 4. And 4 times 4 is 16. Again, I want to do x squared, but this time x is a negative number. Remember, x squared means x times x. So I've got minus 3 times minus 3. Now minus 3 times minus 3 gives me 9. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I hope you realised that on this last one, you need to say 2 times 2 is 4, and we've got two numbers after the point, so the answer is 0.04. Now we come to a slightly more complicated question. To help us do this one, we need to use BODMAS. Remember, in this we have an invisible times sign here. So we've got 2 plus 4 times x, and x is 5. Now we use BODMAS to help us with this. There aren't any brackets, other things, or divisions, but there is a multiplication. That's the 4 times 5, and that is 20. So this is 2 plus 20, and 2 plus 20 is 22. In the same way for this one, we've got an invisible times sign here and an invisible times sign here. So we've got 3 times x squared, and x is 4, so that's 4 squared, plus 2 times y, and y is minus 3. So now we refer to BODMAS again. Brackets come first, but these brackets are just keeping the minus locked in with the 3. There's nothing actually to do in here. Other, that's things like squares and square roots, and we've got one of those. The 4 squared is 16. So we've got 3 times 16 plus 2 times the minus 3. There's no divisions, but there are 2 multiplications. 3 times 16 and 2 times minus 3. 3 times 16 is 48, and 2 times minus 3 is minus 6. Now we have 48 plus minus 6. Whenever we have a plus and a minus together like this, we can replace them with a minus. So we have 48 minus 6, and this is 42. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try doing with a calculator. Press pause and have a go. When you're ready, press play. Now, even though you're allowed a calculator for this one, you should still do some of the working out. Remember, there's an invisible times sign here and here. So we've got 2 times minus 4.5 plus 3 times minus 4.5 squared. When you're using a calculator, the brackets are absolutely essential so that you get the right answer. I can now type this into my calculator exactly as it appears here, and I get the answer 51.75. It's interesting to note that if you miss the brackets out, your calculator will actually give you the wrong answer. Here's an exam-style question for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here are 2 more questions for you. Press pause and have a go. When you're ready, press play. Here are the answers. Here's your final question. Press pause and have a go at this one. When you're ready, press play. Here's the answer. This is a typical exam-style question which is asking us to draw a graph. In order to be able to draw the graph, we first of all need to fill in this table here. I've got a straightforward equation without any powers, so I'm pretty sure that it's going to be a straight line. And I'm going to use this to fill in the table. Remember that 3x means 3 times x, so I've got an invisible times sign here. When I'm filling in the table, I'm going to start with the 0. So I've got 3 times 0, which is 0, plus 1, which is 1. Now I'm going to do the 1. 3 times 1 is 3, plus 1 is 4. Now I've got quite a few numbers in my table, and I can see that there's a pattern. It's going up by 3 every time, and if I go this way, it's going down by 3. So I can use that pattern to fill in the 2 ends. Going up by 3 gives me a 10 in here, and going down by 3 gives me a -5 in here. The next part of the question asks me to draw the graph, so I'm going to plot all of these points onto this set of axes. So my first point is -2, -5, which is here. Then I've got -1, -2, 0, 1, 1, 4, 2, 7, and 3, 10. To complete the graph and get all the marks, you must remember to join the points together with a straight line. So this is the finished graph. For the final part of the question, I'm asked to use the graph to find the value of y when x equals -1.5. So I need to find this value on the x-axis. -1.5 is here. I draw a line straight down until I reach my graph. From here, I then draw a line straight across to find the value of y on the y-axis. I now need to find the value that I've hit on the y-axis. I know that about here is -3, so this will be about -3.5. So my answer is that y equals -3.5. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is the same type of question, but this time they haven't given me any help because they haven't given me a table to fill in. So the first thing I need to do is draw my own table. Your table will always have x and y, and then you need some values for x. You get these from the x-axis here. It goes from -2 to 3, so the numbers along here must go from -2 to 3. Now that I've got my table, I can use the equation to fill it in. Remember, this is 2 times x, so there's an invisible times sign here. And we start at 0. So 2 times 0 is 0, -6 is -6. 2 times 1 is 2, -6 is -4. 2 times 2 is 4, -6 is -2. I can now see a number pattern. It's going up by 2 as I go this way, and down by 2 as I go this way. So this number here will be 0, this will be -8, and this will be -10. I can now plot all of these points on the graph. And remember, to get all the marks and finish off the question, you need to draw a straight line through all of the points. My finished graph looks like this. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Now we come to a slightly more difficult type of question. We have a different looking equation. First thing I need to do is to fill in the table. And remember, I start at 0. So for the first one, x is 0. So I've got 0 plus something makes 5. So I know that this something, the 2y, must be 5. So y must be 2.5. Moving on to the 1, I know that x is 1. So 1 plus something is 5. So the something, the 2y, must be 4. So y must be 2. And for this one, I've got 2 plus 2y equals 5. So the 2y must be 3. So the y is 1.5. Now I can see the number pattern. It's going down by a half this way and up by a half this way. So I get 1 here, 3 and 3.5. Now I can plot these points onto the set of axes. And I join up the points with a straight line. So my finished graph looks like this. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's your final very difficult exam question. This time you've hardly got any help at all. There's no table and there's also no set of axes. All you're given is a grid which is 22 squares high and 14 squares across to put your answer on. Press pause and have a go at it. When you're ready, press play. Here's my answer. When you're checking yours, your table should be exactly the same as this. But you do have some choice when it comes to the x-axis on the graph, so your graph might not look identical to this one. All you need to do is check that all the points here fit on your graph and that you have got a straight line. I'm being asked to find the gradient of this red line. First of all, we need to know what gradient actually means. Gradient is another word for steepness. So whenever we think about the gradient of a line, we're actually thinking how steep it is. Now, if I've got a flat horizontal line like this, we can see that it's got no gradient, because as we're travelling across, we're not travelling up at all. So the gradient of a flat line is 0. We need to work out a way of finding a numerical value for the gradient of a line like this. We do this by picking any point on the line. We then go horizontally to the right to any amount we want. And we work out this horizontal distance. Then we go vertically until we meet our sloping line again. And we work out the vertical distance. To calculate the gradient, we divide the vertical distance by the horizontal distance. So let's say that this horizontal distance was 2 and the vertical distance was 6. The gradient would be 6 divided by 2, so that's 3. So we would say that this line has a gradient of 3. It doesn't matter whereabouts on the line you choose to draw your triangle. You can see I've moved it up a bit now, but this would still be 6 and this would still be 2, so the gradient would still be 6 divided by 2, which is 3. In fact, it also doesn't matter how big you decide to draw your triangle. You can see now I've shrunk it down to half the size. This would be 3 and this would be 1. And the vertical distance 3 divided by the horizontal distance of 1 still gives me a gradient of 3. And you can see that if I do go horizontally just 1, then the gradient is actually the vertical distance. I'm going to use this idea of just going across 1 in some questions now. So I'm now being asked to find the gradients of these 3 lines. Before I do that, I'm going to look at the scales on the axes. I can see that here on the horizontal axis, it's going up 1 for every 1 square, so that scale is okay. But the vertical axis is a bit different. It's going up 2 for every 1 square, so I just need to be a bit careful when I'm working out the gradient here. To find the gradient of line A, the first thing I need to do is choose a point on the line. I'm going to choose this point here where the line crosses the y-axis. Now I want to go across to the right 1. I've got to double check my scale here. Remember, on this axis, it's 1 for every 1 square, so I can just go 1 square across. Now I go up until I meet the line again, and I need to work out how far up I've gone. This will be the gradient of the line. If I look, I can see that I've gone up half a square, but that's actually from 8 to 9 on the scale on the y-axis, so I've gone up by 1. So the gradient of line A is 1. Let's look at line B now. Again, I'm going to choose the point where it crosses the y-axis, and I'm going to go 1 to the right. Then I go up until I hit the line, and I need to work out what distance this is. I've gone from -2 to 2, so I've gone up by 4. So the gradient of this line is 4. Now line C is on a different set of axes, so I just need to review the scales. On the horizontal scale, I can see that it's 2 squares for every 1, and on the vertical scale, it's 1 square for every 2. So I find my convenient point. I'm going to go for this here where it crosses the y-axis again. I need to go across 1, so on this scale, that's actually 2 squares across. Now I go up until I hit the line, and I need to work out what distance I've gone up. I've gone up from 2 to 10, so I've gone up by 8. So the gradient of line C is 8. You'll notice that because I chose to go across by 1 unit every time, I didn't need to do any working, because the distance I travel upwards is the gradient. Here are 2 for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now I'm being asked to find the gradients of these 2 lines. You might notice that they look slightly different because they're sloping the other way. Let's see how this affects their gradients. I'm going to start in the same way by just checking the scale. I can see it's going 1 for 1 on the x-axis, but 1 square for 2 on the y-axis. I find the point where it crosses the y-axis, that's here, and I go across 1, so that's 1 square on the x-axis. Now, if I go up, I'll never meet the line, so instead I go down. Now, the distance I've gone down is going to be the gradient of the line, and I've gone down from 6 to 2, so I've gone down by 4. Now, how do I say this is a gradient? I say it's -4. We have a negative gradient because the line is sloping the other way. So the gradient of line A is -4. Let's have a look at line B. Again, checking the scale, I can see it's 2 squares for every 1 on the x-axis and 1 square for every 2 on the y-axis. Here's the point I'm going to start at, and I go across 1, which is 2 squares, remember. Now I need to go down till I meet the line. I've gone down from 2 to -2, so I've gone down by 4, so that's -4. So the gradient of line B is actually -4 as well. So to summarise, to find the gradient of any line at all, I always go 1 to the right. If I then go up, we've got a positive gradient, but if we go down to meet the line, we've got a negative gradient. Here are 2 for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now we're going to look at a question dealing with gradients in a context. I'm told that Chris had 5 litres of petrol in his motorbike, and after driving 100 kilometres, he had 3 litres left, and I've got a graph that illustrates the situation. The first thing I'm asked for is to find the gradient of the line. Now remember, when we find the gradient of a line, so far we've always gone across 1. But if I look at the scale here, it's going from 0 to 50. So going across 1 would be a tiny little bit, and it's really hard to see how far I've gone down. So instead, for this question where the scale is much bigger, I'm going to use my formula for gradient. So remember, the gradient of a line is given by the vertical distance divided by the horizontal distance. So I'm going to start by finding the point where the line crosses the y-axis, that's here, and I'm going to go across any distance I like and not really worry about it. But I can see on the bottom that the scale's got 100 on it, and that's a nice number to divide by, so I'm going to go across to 100. Now I go down until I meet my line. Now I went across 100, and I've gone down from 5 to 3, so I've gone down by 2, and I write that as minus 2. So the gradient is the vertical distance, that's minus 2, divided by the horizontal distance, that's 100. And minus 2 divided by 100 is minus 0.02. So this is the gradient of the line. Now in part B, I'm asked what the gradient actually tells us. To help me with this, I'm going to just look at the graph before I look at this number. I can see that the line on the graph is going downhill. That's telling me that as Chris travels further and further on the motorbike, he gets less and less petrol in his tank. And that makes sense because he's using up the petrol as he travels. The gradient is actually the rate of change of this line. So it's telling me that for every 1 kilometre he travels, he's losing, because it's a minus, 0.02 litres of petrol. So we can write that the gradient tells us that Chris uses 0.02 litres of petrol per kilometre. So when you're asked to explain what a gradient actually means in context, it's helpful to refer to this. The gradient is going to be the unit on the vertical axis, in our case litres, per, that's the divide bit, the unit on the horizontal axis, in our case kilometres. So here, his petrol consumption was in litres per kilometre. Here's a question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this question, I'm being asked to complete the table for this equation here, and then draw the graph. Because I can see this x squared here, I know that the graph is going to be a curved graph that looks like this. Notice that this is symmetrical. Because I know that the graph is going to be symmetrical, I might be able to use the symmetry to help me fill in the table. Before I fill in the table, I need to remember that there are invisible time signs here and here. Now this question could be on the non-calculator or the calculator paper, so I'm going to show you how to do it with and without a calculator. I'm going to start by showing you how to do it without a calculator. I start with the 0. I need to substitute the 0 wherever I see an x in this equation. So I've got 2 times 0 squared minus 4 times 0 minus 2. Now 2 times 0 squared is 0, 4 times 0 is 0, and I just have a minus 2. So the answer is negative 2. Now that I've put the minus 2 in the table, I have a quick look to see if there's any symmetry, and there isn't yet, so I move on to the next positive number that I need to do, and that's 2. I replace the x with a 2. So I've got 2 times 2 squared minus 4 times 2 minus 2. Now, because of BODMAS, I've got to do the 2 squared first, and that's 4, and 2 times 4 is 8. Now I've got minus 4 times 2, and that's minus 8, and I've got minus 2 on the end. So I've got 8 minus 8, which is 0, minus 2 gives me minus 2, and I can put this in the table here. I'm now going to look for symmetry. I can see I've got a minus 2 and a minus 2, so I've got a line of symmetry down here, which means that because that's 4, this will be 4 as well, so I can fill it in. So this is how I would fill in this table if I wasn't using a calculator. Now, if this question appeared on a calculator paper, I would still start in the same way with the x equals 0, and I would substitute this in to this equation. So I would have 2 times 0 squared minus 4 times 0 minus 2. And you can see that the working out looks exactly the same as it is here. The difference is that I would then type this into the calculator exactly as it is here, and I would get the answer minus 2 straight away. So I know that this is minus 2. Now I need to do the 2. Again, the working out will actually look the same. So I've got 2 times 2 squared minus 4 times 2 minus 2. Typing this into the calculator gives you minus 2, and this can go here. Again, I found the line of symmetry here, so I know that this one must be 4. Just out of interest, if you forgot to look for the symmetry, or maybe the symmetry wasn't there, and you had to do the minus 1, you would substitute it in like this. 2 times minus 1 in brackets. This is squared. Then I've got minus 4 times minus 1 in brackets, and then I've got minus 2 on the end. Typing this into the calculator with the brackets in will give you the right answer, and the right answer is 4. It's vital that you remember to put brackets around any negative numbers that you're substituting in. If you forget them, the calculator will actually give you an incorrect answer. So to summarise, whether you're using a calculator or not, the start is the same. If you're not using a calculator, you'll have a line of working out. If you are using one, then you can just type it straight in and get the answer immediately. Either way, remember to look for symmetry in the table because this can save you some time. I can now use the table to plot the graph. So when x is 3, y is 4, so that's here. I have 2 minus 2, so that's here. 1 minus 4, 0 minus 2, and minus 1, 4. I now need to join the points together with a smooth curve. Like this. So this is my graph. In part C, I'm asked to use my graph to find the value of y when x equals 1.5. So the first thing I want to do is on the graph draw the line x equals 1.5. To do this, I find the point 1.5 on the x-axis, and I need to draw a line that goes straight through this point. Like this. I now need to find where this line crosses my graph and read off the value on the y-axis. I get the value about minus 3.5. So my answer is y equals minus 3.5. Now, in an exam, because this is a hand-drawn curved graph, and everybody's hand drawing might be slightly different, they do give you a little bit of leeway here. You might have minus 3.4 or maybe minus 3.6, and these values would be accepted as well. For this part here, I want to use the graph again, but I want to find the values of x when y equals 2. Notice that the question says values, so I'm going to get more than one answer. I need to draw the line y equals 2 on my graph. So, on the y-axis, I find the 2, and I need to draw a line that goes straight through this. You can see that the line crosses the curve in 2 places, and this is where I get the 2 values from. I need to go down here and read off the value on the x-axis, and the same here. So here, I've got about minus 0.8, and here, it's about 2.8. Again, on the exam, there would be a bit of leeway here. Now, the last part of the question looks a little bit tricky, but if you're careful, you should spot that this equation here matches this one, which is the graph we've drawn. So I have this, equals 0. Now, because this matches this, I know that actually y must equal 0. So on the graph, I'm going to draw the line y equals 0 and find the values of x from it. Now remember, this line is y equals 2. So a line here would be y equals 1, and this line here would be y equals 0, which is really the x-axis. So my answers are here and here. So this one is about minus 0.4, and this one is about 2.4. Again, remember, on an exam, there would be a bit of leeway here, so you don't have to have these exact answers. Here's one for you to try doing without a calculator. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is the working out that you should have done to get the answers in your table. Notice that there's no working out here for the -1. That's because I spotted the symmetry and realised that it was going to be 4 to match this one. For part C, remember there's a bit of leeway, you don't have to have exactly 2.2. When you get to part D, notice that I've said that this equation is the same as this, but it's equal to 3, so I draw the line y equals 3. I've drawn that here and I've found the two values. Again, there's a bit of leeway, you don't have to have exactly these two values. Here's another one for you to try. This time you can use a calculator. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This time your working out for your table will look like this. Notice again that there's no working out for the -1 or the -2 because I used the symmetry to get these two answers. Notice as well that when you draw the graph, you need to have a nice curvy bottom here. Don't go flat in between these 2 points. And for part C, you should have noticed from this equation and this equation that y is equal to 0, and you don't need to draw this line because remember, it's the x-axis. So my 2 points are here, and you are allowed a bit of leeway with your answers. Here's another one for you to try without using a calculator. You'll need some graph paper this time. Press pause and have a go. When you're ready, press play. Here are the answers. Sometimes on a question like this, you might get a final difficult part. This is asking me to solve this equation. That means I've got to find values of x that make this true. The obvious thing to do is to compare this to my graph. Just like before, I'm going to write this equation underneath this one here, which is the graph I've drawn. So I've got x squared minus 2x minus 3 equals 1. I can see that this part and this part match. So what I want to do is rearrange this slightly to move the -3 so that it's just equal to something. So I add 3 to both sides, and that gives me x squared minus 2x equals 4. Now from this and this, I can see that y equals 4. So this is the line that I need to draw on my graph. So I get a value of x here of minus 1.25 and a value of x here of 3.25. Again, there would be a bit of leeway with these answers. So to summarise, whenever you get a question like this, compare it to the graph you've drawn. It needs to match. If it doesn't, you need to rearrange a little bit. You'll then get a line that you can draw and you can work out the values of x. Here's another one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers for parts A and B. For part C, remember we want to compare this to our graph. So we've got x squared minus 4x minus 3 equals 1. Now this part and this part match, but this here needs to be plus 2, not minus 3. So what I'm going to do is add 5 onto both sides. That will take the minus 3 up to plus 2. So I've got x squared minus 4x plus 2 equals, and remember I added 5, so I've got to add 5 here as well, so that is 6. So now y needs to be equal to 6. This is the line that I draw on the graph. And these are the two answers that you should get. Remember, as always, there's a bit of leeway here. Here's another one for you to try. This time, they haven't given you any axes on the graph paper, so you'll need to draw these yourself. Press pause and have a go. When you're ready, press play. Here's the answer. When you draw your own set of axes, remember to label them with x and y. You actually get a mark for doing this. This is the final type of question that we're going to look at. We want to find the coordinates of the point of intersection of a curve with a line. So we want to draw the curve and the line. To do this, I'm going to need some tables. The x-axis on the graph that I've been given tells me what numbers to use in my table. So I've set up two tables, one for the curve and one for the straight line. For the curve, I substitute 0 first of all. 0 squared plus 1 is 1. 1 squared plus 1 is 2. 2 squared plus 1 is 5. 3 squared plus 1 is 10. And 4 squared plus 1 is 17. I now plot all of these points and draw the curve like this. For this one, I start with the 0 again. I've got 2 times 0, which is 0, plus something makes 16, so that must be 16. 2 times 1 is 2, plus 14 would make 16. 2 times 2 is 4, plus 12 would make 16. 2 times 3 is 6, plus 10 to make 16. And 2 times 4 is 8, plus 8 to make 16. I can now plot these points and draw the straight line. Like this. I can now see that the coordinates of the point of intersection are here, 3, 10. This is my final answer. Here's your final question. Press pause and have a go. When you're ready for the answers, press play. Here's the answer. Again, you'll get some leeway with these, so you don't have to have exactly what I've got here. In this clip, we're going to be looking at sketching functions. To do this, we need to recognise some different types of graph by their equation. The equation of a straight line graph looks something like this. You'll see there's no x squareds or x cubeds or anything like that. Now you should actually know what this one looks like, But if you forget, you can always plot a couple of points to help you. This is telling you that the y-coordinate is the same as the x-coordinate. So if x equals 1, then y equals 1 as well, so it would be about here. If x equals 2, then y would equal 2 as well, and it would be about here, and so on, so the line would look like this. So this is a sketch of the graph of y equals x. Now y equals x plus 1 will be this same line, but moved up by 1. So my sketch would look like this. It's crossing the y-axis here at 1, and this is y equals x plus 1. Notice that the two lines are parallel, and that's because they have the same gradient, because they've both got 1x, so they have a gradient of 1. Now this would give us this same line again, but moved down by 2. So it would look like this. Now y equals minus x has a gradient of minus 1, so its graph will look like this. And finally, the graph of y equals minus x plus 2 will be the same line as this, but moved up by 2. So it looks like this. So to summarise, these are all straight line graphs. If I'm able to sketch the first one here, then I'm able to sketch all of the others by moving the line up or down or flipping its gradient. Now I want to use this, the line y equals x, which I have here, to help me sketch this. Remember here the gradient is 1 because there's only 1x. Here the gradient will be 2 because there's 2x. That means that the line is going to be steeper than this one. It's still, however, going to pass through the origin. So my sketch would look like this. Similarly, y equals 3x would be even steeper again. So it would look like this. And finally, y equals minus 5x would be even steeper, but it would have a negative gradient. So that one would look like this. So to summarise, as long as I can draw the first one, y equals x, then I can use that to help me draw the others by altering the gradient according to the number in front of the x. Just out of interest, if you were asked to sketch the graph of y equals a half x, where do you think it would go in relation to the line y equals x? This time we need a gradient of a half, so it's not as steep as y equals x, so it looks something like this. Here are some questions for you to try. You'll need to sketch the axes and the line y equals x and then answer the questions. Press pause and have a go. When you're ready, press play. So your line for A should look something like this. It needs to be steeper than this one and it needs to pass through the origin. Your line for B should be parallel to A but moved up. Your line for C should have the same gradient as this line here, y equals x, but it should be moved down by 2. And your line for D should have a gradient in between this one and A, but it should be going the other way because it's negative. So in this exam-style question, I'm being asked to sketch the graph of y equals 3x minus 2. I need to show clearly where the line crosses the y-axis. I know that if it just said y equals 3x, it would be a line that's relatively steep and that goes through the origin. Y equals 3x minus 2 will have the same gradient, but be moved down by 2. So my line looks like this, and I know that it crosses the y-axis at minus 2. I make sure I mark this on because I've been asked to in the question. Here's one for you to try. Press pause and have a go. When you're ready, press play. Your answer should look something like this. The most important point is that you've marked the 3 on the y-axis. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Important points are that your line should have a negative gradient and you need to mark on the 5. Now we're going to look at quadratic graphs. You need to be able to recognise these from their equations. They look something like this, and you'll notice that they've all got an x squared in them. You need to be able to sketch the graph of y equals x squared. It looks like this. Being able to reproduce this shape is the key for the quadratic graphs. Now, remembering how adding and subtracting affected our straight line graphs, I'd like you to try sketching these two. Press pause and have a go. When you're ready, press play. Here are the answers. To sketch this graph, you should have realised that you get this one and move it up by 1, so that gives you this. And for this one, you get this one and move it down by 2, which gives you this one here. Now see if you can use the graph of y equals x squared to help you sketch these two. Think carefully about what the minus will do to it. Press pause and have a go. When you're ready, press play. Now I bet when you did the first two, you were smiling, but when I asked you to try drawing the minus x squared curves, it made you frown, and you'll find that minus x squared does that to people. It does it to the curve too. What I mean is that y equals minus x squared is upside down. This one looks like a smile, and this one looks like a frown. And for y equals minus x squared plus 3, you should have this same graph, but moved up by 3. Here's your final question. You need to match each equation with its graph. Press pause and have a go. When you're ready, press play. Here are the answers. This clip is about solving equations, some of which can be quite difficult, using flowcharts. To do this, we need to look at this equation here and create a flowchart for it. So we always start with x, and we say, what's the first thing that's happened to x? Well, it's got a 2 in front of it, so it must have been multiplied by 2 to give 2x. Then we say, what's the next thing that happened to x? And that's the minus 3 here. Then we know that this gives us 17, so that can go here. I can check my flowchart now by seeing what effect it has on the x. So x times 2 gives me 2x, and you can see that matches this part here. And then take away 3 gives me 2x minus 3, which matches this, and that's equal to 17, which I've got here. So to solve my equation, in other words, to find the value of x that works for this, I reverse the direction and reverse the operations. So I'm going to start with the 17. I want to reverse minus 3, so that's plus 3, because this is the inverse of this. Reverse times by 2, that's divide by 2, because that's the inverse of this. And that will give me my answer. So 17 plus 3 is 20, and divide that by 2, I get 10. So 10 is the value of x, and I can write that down as x equals 10. If I want to check my work, I can put this 10 into the equation. So I've got 2 10s, that's 20. Take away 3 is 17, so I know that this is correct. Now this equation looks more difficult, but I can solve it using the same method. So I start off with the x, and I say, what's the first thing that's happened to that x? Well, it's been divided by 3, that's what this means here. Then, what's the next thing that's happened? Minus 2, so I put that in there. And that gives me 7. So I reverse the direction and reverse the operations. So I've got 7. Instead of minus 2, I add 2. Instead of divide by 3, I times by 3. And this will give me my answer. So 7 add 2 is 9, times by 3 is 27, so this is my value for x. I can check it by putting it into here. So I've got 27, I divide that by 3, that gives me 9, then take away 2, and I do get 7, so this is the right answer for this one. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. We're now going to look at some even more difficult looking questions. We can still solve these using our flowcharts. So for this one here, here's the x, and the first thing that's happened to it is it's been multiplied by 2 because it's got a 2 in front of it. Then the next thing is there's a takeaway 7, and then all of that has been multiplied by 5, so that must come last. And that makes 10. So I can reverse this now, start with the 10, and divide by 2. And this will give me the answer. 10 divided by 5 is 2, add 7 to that and I get 9, and then divide that by 2 and I get 4.5. So the answer for this is that x equals 4.5. Remember, I can check it by putting it back in. So 2 lots of 4.5 is 9, take away 7 is 2, and times that by 5 and you do get 10. So let's look at this one now. Here's x, it's been divided by 3, then we've added 1, and then it's been multiplied by 4, and this makes 12. So we can draw a flowchart for this. My flowchart looks like this. I now need to reverse it to get the answer. So this is my reversed flowchart. Starting with the 12, I divide by 4 and get 3, then take away 1, that's 2, and then times by 3 to get 6. So the answer is that x equals 6. This last one is a really difficult looking one, but I do it in exactly the same way. My flowchart will look like this, and my reversed flowchart will look like this. So 21 divided by 3 is 7, plus 1 is 8, times by 5 is 40, and divided by 4 gives me 10. So the answer for this really difficult looking one is that x equals 10. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this clip, we're going to be looking at changing the subject of a formula, and we're going to do this using flowcharts. At the moment, in this formula, f is the subject, because it's the letter that's on its own on one side of the equal sign. We want to make g the subject, so we want to get g on its own on one side of the equal sign. To do this, we look at what has happened to g. So we've got the g, it's been multiplied by 3 because it's got a 3 in front of it, and then 2 has been added on. And this gives us f. To rearrange it, we reverse the flow and reverse the operations. So we start with f. Instead of add 2, we subtract 2. Instead of times by 3, we divide by 3. And this will give us g. So we have f take away 2, that's f minus 2. Then we divide all of that by 3, so that's f minus 2, all divided by 3. I know that this is equal to g, so I can write g equals f minus 2 over 3, and g is now the subject of the formula. Here are 2 for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Now this is a really tricky looking one, but we're going to make it straightforward by using a flowchart. We want to make x the subject, so we find the x. We can see that it's been divided by r first of all. Then, added onto it, we've got a 2y. And that gives us w. So we reverse this, we get w minus 2y times r, and that's going to give us x. So we have w minus 2y, and we write that just as w minus 2y. And then we want to times all of that by r. So we need to put it into brackets and multiply it by r by putting the r at the front. So we now know that x is equal to r brackets w minus 2y. X is now the subject of the formula. Again, look how difficult this one looks, but we're going to do it with our flowchart. We want to make x the subject, so find the x. You can see the first thing is that it's had 2y added onto it. Then this has been multiplied by 3. Then we have a minus 5 on the end. And that's giving us w. So we reverse it. We have w minus 2y, and that's going to give us x. So w plus 5 is w plus 5. Divide that all by 3, so I put that over 3. And then minus 2y goes on the end. So we've got w plus 5 over 3 minus 2y. So we have x equals w plus 5 over 3 minus 2y. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Now let's have a look at this one. I want to make t the subject. So we start by finding the t, and we say what's the first thing that's happened to it? Well, we found the square root. Then 3 has been added on, and that's giving us w. So we reverse this now. We've got w. This bit's straightforward. We minus 3. And then for this bit, we need to know what the inverse of square root is. And the inverse of square root is square. And that's going to give us t. So we have w minus 3, and we square that by putting it in brackets and putting our little squared sign here. So we have that t equals w minus 3 squared. So t is now the subject of the formula. One thing to notice is how I actually squared the w minus 3. I just got that w minus 3, put it in brackets, and put the squared sign on it. I didn't try to do anything more difficult or more fancy. This is a perfect answer. You don't need to do anything else to it. This time I want to make x the subject. So we've got our x, and the first thing is that it's been squared. Then y has been added on, and that gives us w. Now we reverse. So this bit gives us minus y, and the reverse of square is square root. And this will give us x. So we've got w minus y, and we want the square root of all of that. So I write w minus y, and then put one square root sign over the top. So x is the square root of w minus y. Again, notice how I did the square root part. I just put one big square root symbol over the whole of w minus y. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. I'm told that the nth term of a number sequence is 5n plus 3, and I'm asked to write down the first 3 terms and the 10th term. So I want the first term, the second term, the third term, and the 10th term. So for the first term, we substitute the number 1 for the n. Remember that in this 5n, there's an invisible times sign. So I've got 5 times 1 plus 3. So 5 times 1 is 5, plus 3 is 8. So the first term is 8. For the second term, I substitute the number 2. So I've got 5 times 2 plus 3. That's 10 plus 3, so that's 13. For this one, I substitute the number 3. So that's 5 times 3 plus 3. That's 15 plus 3, so that's 18. And for the 10th term, I substitute the number 10. So that's 5 times 10 plus 3, which is 50 plus 3, 53. So my answers are 8, 13, 18, and 53. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's a slightly harder question. We still use the same technique. I want the second term and the 5th term. Again, there's an invisible times sign here. The reason this one's harder is because we've got an n squared, so we just need to be careful with this. So we substitute in a 2. We've got 2 times 2 squared plus 3. We need to use BODMAS or BIDMAS here. Remember, we do this part first, so we've got 2 times 4 plus 3. Then this part, that's 8 plus 3, so the answer is 11. For the 5th term, we've got 2 times 5 squared plus 3. Do this first, so that's 2 times 25 plus 3. Then this, that's 50 plus 3, so the answer is 53. So the second term is 11, and the 5th term is 53. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Finally, here's an exam-style question for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. I'm being asked to find the nth term of this sequence of numbers. Because I'm looking for the nth term, the first thing I do is write down the letter n. Then I need to look at what the pattern of numbers is going up by every time. I can see it's going up in 4s. So I write 4n. This tells me that the pattern is linked to the 4 times table. Now I just need to go back one step here and work out what number would come before the 3. That would be -1. I put this on the end. So the nth term of this number pattern is 4n minus 1. I always like to check that this is right using one of the terms in the number sequence that I was given. I always like to use the third term. So 4 times 3 for the third term is 12, take away 1 is 11, so I know that this is correct. Now Tim says that 120 is in this number sequence if we continue it. We want to know if Tim is right. If we look at the numbers that we've got so far, we can see that they're all odd numbers, but 120 is an even number, so it's not going to be in the number sequence. So to answer this part of the question fully, I need to say yes or no whether Tim is right, and then back up my answer with an explanation. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For this question, I would start in the same way by writing down the n. Now I say, what is this going up by? We're going from 17 to 12, so we're not actually going up, we're going down, and we need to put -5. So I put the -5 in front of the n to give me -5n. I now go back one term. The number I get here is 22. Now it's not -22, it's +22, so I put it on the end here as +22. This is one correct answer. Another way to write it would be to put the 22 at the start and have 22 minus 5n. Both of these are correct nth terms for this number pattern. I'm now able to check my answer. I like to use the third term to do this. So -5 times 3 is -15, add 22 does give me 7. And I can check this one as well. 22 minus 5 times 3 is 22 minus 15, and that's 7 too. So these are both definitely correct answers for the nth term of the sequence. You would only need to write one of them to get the mark. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Finally, here's a mixture of questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Notice that on the third one, the answer is just 5n. We don't write 5n plus 0. In this question, I'm given the first 5 terms of a number sequence, and I'm asked what's the term-to-term rule. That means how do I get from one number to the next number? Now, if I look at the first 2 numbers, it looks like it could be add 1. But if I then look here, that's not add 1, that's add 2, so that doesn't work. So instead, I'm going to look at multiplying. To get from 1 to 2, I can multiply by 2. Let's see if that works here. 2 to 4, yep, I can multiply by 2. 4 to 8, I can multiply by 2, and so on. So the term-to-term rule is multiply by 2. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready, press play. You've got 2 options for this answer. You could notice that you're dividing by 2 each time and write that the term-to-term rule is divide by 2. Or you might like to rephrase this as multiply by a half. These actually mean the same thing. In this question, I've got a different number pattern, which is made up of dots this time. I'm being asked to write down the number of dots in each pattern to create the number sequence. So here I've got 1 dot, then 4, then 9, and then 16. Then I'm being asked what's the special name given to these numbers. Now you might recognise them. They're called square numbers. You'll notice that each of the patterns of dots forms a square, and that to get 1, we do 1 times 1. To get 4, we do 2 times 2. To get 9, we do 3 times 3, and so on. So we are actually squaring the numbers. We're asked for the nth term of the number sequence. We've already said the number sequence is the square numbers, so the nth term will be n squared. Now here, I'm given the first 5 terms of the same number pattern that we've just looked at, the square numbers, and it asks me to use it to help me find the nth term of this number pattern here. Let's compare this number pattern with this one. So we've got 1 compared to 2, 4 compared to 5, 9 compared to 10, 16 compared to 17, and 25 compared to 26. You should notice that these numbers here are all 1 bigger than these numbers here. So the nth term is n squared for this number pattern plus 1, because I need to add 1 each time. Now try these ones in the same way. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another question for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. I hope you got this one right. In the same way as the square numbers form patterns of squares, we call these triangular numbers because the patterns are equilateral triangles. I'm now going to show you how to find the nth term of the pattern of triangular numbers. To do this, I'm just going to move my triangles around slightly. You can see I've got the same number of dots each time, but I've moved them to make a right-angled triangle. Now I'm going to double the number of dots in each pattern. And I do that like this. And now you can see that I've made a rectangle. Now let's have a look at this rectangle. The height of it is 4, and the pattern number is 4. So the height is just the pattern number. Remember, the pattern number we call n, so the height is n. Let's look at the width. The width here is 5 for pattern number 4, so it's n plus 1. Now, if I want to know how many dots are here, I multiply the height by the width. So I've got n multiplied by n plus 1. Now remember, the actual triangular number was just the black dots, which is half this number of dots. So I now divide by 2. This is the nth term of the pattern of triangular numbers. Now that I've got what I think the nth term is, let's check it by using pattern 3. So in pattern 3, n is equal to 3. So the nth term gives us 3 multiplied by 3 plus 1, which is 4, divided by 2. Now 3 times 4 is 12, so that's 12 divided by 2, which is 6. Let's have a look if I've got 6 black dots in the third pattern. 1, 2, 3, 4, 5, 6. Yes, that's correct, so that backs up my nth term. Here's a question for you to try. For this, you'll need to remember that the nth term for the triangular numbers is n multiplied by n plus 1 divided by 2. Press pause and have a go at the questions. When you're ready, press play. Here are the answers. I'm being asked to find the midpoint of A and B. I'm told the coordinates of A and the coordinates of B, and I've got a set of axes to help me. So I'm going to start by plotting A. It's minus 2, 1, so that's here. I'm also going to plot B, that's 3, 5, so that's here. I now join these together with a straight line. I need to find the midpoint of this line. I can see that to get from A to B, I've gone across 5 and up 4. So to find the midpoint, I need to go across half of 5, which is 2.5, and up half of 4, which is 2. So this point here is the midpoint. The coordinates of this are 0.5, 3. So this is the answer to the question. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. We've now seen how to answer questions like this using the graph to help us. We get this answer. Have you noticed, though, that if you add the x coordinates together and halve it, we get 2, and that's the x coordinate of the midpoint. And if we do the same for the y coordinates, add them together and halve it, we get 2.5, and that's the y coordinate of the midpoint. So this method can be used if you don't have a graph. So now I want to find the midpoint without using a graph. So I add the x coordinates together, that's 3 plus 4, and halve it. So that's 7 divided by 2, which is 3.5, and that will be the x coordinate of the midpoint. And then I do the same with the y coordinates. So I've got minus 7 plus 15 divided by 2. Minus 7 plus 15 is 8. Divide that by 2 and I get 4. So the midpoint is 3.54. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. This is a slightly different question. This time, I'm told the midpoint of the line AB, and I'm told the coordinates of the one end, A. I want to find the coordinates of the other end, B. Before I begin, I'm going to call the coordinates of B x, y. Now we know that to find the x coordinate of the midpoint, I get the x coordinate of A, add on the x coordinate of B, and then halve it. So I've got 6 plus x halved, and I know that that gives me 3. I can do the same thing for the y coordinates. Now to find the value of x, I know that something divided by 2 must be 3. So the something here must be 6. From this line, it's simple to see that x must be equal to 0, because 6 plus 0 is 6. In the same way here, I have something divided by 2 is equal to 5, so the something, minus 3 plus y, must be 10. From this line, I can see that y must be 13. So the coordinates of B must be 0, 13. And this is the answer to the question. Finally, here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. For this type of question, I've got to expand first and then simplify. Everything inside this bracket needs to be multiplied by 2, and everything inside this bracket needs to be multiplied by positive 3. So we start with 2 times x, which is 2x, and 2 times plus 3, which is plus 6. We've then got plus 3 times 2x, which is plus 6x, and plus 3 times plus 5, which is plus 15. I've now expanded, I just need to simplify. If I put the x's together, I get 8x, and then I've got plus 6 plus 15, which is plus 21. This is the final answer. For this one, I have 3 times 4x, which is 12x, and 3 times plus 3, which is plus 9. I've got plus 5 times 3x, which is plus 15x, and I've got plus 5 times plus 1, which is plus 5. Now I need to simplify. Putting the x's together gives me 27x, and then I've got plus 9 and plus 5, which gives me plus 14. This is the final answer. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now, I'm afraid I've lulled you into a false sense of security, and you think that these questions are really easy. But there's a bit of a complication here because we've got some minuses. We're going to take our time and we'll be fine. So we've got 2 times x, which is 2x, and 2 times plus 4, which is plus 8. We've got plus 3 times 2x, which is plus 6x, and we've got plus 3 times minus 5, which is minus 15. I've done the expanding bit, now I need to simplify. I've got 2x plus 6x, so that's 8x. And I've got plus 8 minus 15. I can use the number line for this. Plus 8 minus 15 means I will start at the 8 and subtract 15. I get minus 7, so I've got minus 7 here. This is the final answer. For this one, I've got 3 times x, which is 3x, and 3 times minus 2, which is minus 6. Then I've got plus 2 times 2x, which is plus 4x, and I've got plus 2 times minus 1, which is minus 2. Now I need to simplify. I've got 3x plus 4x, which is 7x, and I've got minus 6 minus another 2. Again, I can use the number line. I'll start at the minus 6 and go down by 2. I get minus 8, so I've got minus 8 here. This is the final answer. Here I have 4 times 2x, which is 8x, and 4 times minus 1, which is minus 4. Then I've got minus 2 times 3x, which is minus 6x, and I've got minus 2 times minus 1. Now when we multiply a minus by a minus, we get a plus, and 2 times 1 is 2. Now simplifying gives me 8x minus 6x, which is 2x, and then minus 4 plus 2. Using the number line, I'm going to start at the minus 4 and go up 2. I get minus 2. This goes here. So the final answer for the last one is 2x minus 2. Here's your final set of questions to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. When we're asked to expand and simplify, everything in the second bracket has to be multiplied by everything in the first bracket. When I'm doing these questions, because these particular ones have only got pluses in them, I'm not going to make a big fuss about the signs. So I'm going to start with x times x, which is x squared. I've then got x times 2, which is 2x. Then I need to move on to the 3, and I've got 3 times x, which is 3x, and I've got 3 times 2, which is 6. Now we've finished the expansion bit. Remember at the start I said I wasn't going to make a fuss about the signs. That's because these are all positive, so these are all positive. We now need to move on to the simplification. When we simplify, we can put these two terms together. So we still have the x squared, but now we've got plus 2x plus 3x, so that's 5x, and we've got the plus 6 at the end. So this is the final answer. So for this one, I've got x times x, which is x squared, x times 1, which is 1x, 5 times x, which is 5x, and 5 times 1, which is 5. Simplifying this gives me x squared plus 1x plus 5x, which is 6x, plus 5. I wouldn't normally write the 1 in front of a 1x, but because it's part of the working out and it helps me get this answer here, it's fine to leave it in. This is the final answer for this question here. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now this type of question is slightly more difficult because we've got things like 2x here and 3x and 4x on this one. The signs are still positive, so I don't have to worry about those. I do them in the same way, so I've got 2x times x, which is 2x squared. I've got 2x times 2, which is 4x. I've got 1 times x, which is 1x. And I've got 1 times 2, which is 2. I've now got to simplify this. So I've got 2x squared plus 4x plus 1x, so that's plus 5x, and plus 2. This is the final answer for this one. In the same way here, I've got 3x times 4x. 3 times 4 is 12, so that's 12x squared. 3x times 5, so that's 15x. 2 times 4x, so that's 8x. And 2 times 5, which is 10. Simplifying gives me 12x squared. Put these two terms together to get 23x, and put the plus 10 at the end. This is the final answer for this one. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now in these questions, we've got to be much more careful because we've got minuses as well as pluses. We use the same pattern though. X times x is x squared. But then we've got x times minus 2, so that's minus 2x. We've got plus 4 times x, so that's plus 4x. And we've got plus 4 times minus 2. Plus times a minus is a minus, and 4 times 2 is 8. I've got to simplify this carefully as well. So I've got x squared, but then I've got minus 2x plus 4x. That's plus 2x. And I've still got the minus 8. So this is the final answer for this one. On this question, I've got x times x, which is x squared, x times plus 2, which is plus 2x, minus 3 times x, which is minus 3x, and minus 3 times plus 2, which is minus 6. Simplifying it gives me x squared plus 2x minus 3x is minus 1x, and because this is part of my final answer, I'm not going to write the 1, so I just put minus x, and then I've got minus 6. This is the answer for this one. Finally, on this one, I've got x times x, which is x squared, x times minus 5, which is minus 5x, minus 6 times x, which is minus 6x, and minus 6 times minus 5. Remember, when you multiply two minuses together, you get a plus, and 6 times 5 is 30. Now, simplifying this is where many students go wrong. We've got x squared, but then we've got minus 5x minus 6x. Let's just think about a number line for a moment. We're starting at minus 5x, which is here, minus 5, and we want to take away 6, so we need to go down by 6. It looks like this, and we get to minus 11. So we have minus 11x, and then on the end we've got the plus 30. This is the final answer for this question. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Here are some more questions for you to try. Be really careful on these because you've got minuses and you've also got things like 3x and 2x. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I hope you noticed that on this last one, the minus 10x and the plus 10x combine to give you 0x. But when you write your answer, you don't put the 0x in the middle. It should look exactly like this. These questions are a little trickier. In this first one, we're being asked to square this bracket. Remember, when you square something, you multiply it by itself. So what we're really doing is 3x plus 1 multiplied by 3x plus 1. When you're doing this kind of question, don't be lazy. You really do need to write it out like this unless you're a maths teacher. I've now got 3x times 3x, which is 9x squared, 3x times plus 1, which is plus 3x, 1 times 3x, which is plus 3x, and 1 times 1, which is 1. Simplifying this gives me 9x squared plus 6x plus 1. In the same way for this one, I write it out carefully first, and then we multiply these two brackets together. We get this, which we can then simplify to 16x squared minus 8x minus another 8x, so that's minus 16x, and plus 4. This is the answer for this question here. Here's your final set of questions. Remember not to be lazy and to write the bracket out twice before you begin. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. These are all equations. We can recognise an equation because it has an equal sign in it, and it will also have an unknown shown by a letter. If we're asked to solve an equation, we want to work out what the unknown is. In other words, I want to get the unknown by itself. These would be the answers to these equations. We can see that these are right because, for example, on the first one, 2 times 6 is 12. 3 times 3 is 9, take away 1 is 8. 5 times 2 is 10, plus 3 is 13, and if I double that, I get 26. 15 divided by 3 gives me 5. I'm now going to show you how to solve the 6 main types of equation. This one is in a different colour because it's the most common type of equation that you will get on an exam paper. I'm going to start with these 3 types here, which we solve by either adding or subtracting to both sides, dividing or multiplying both sides, or by using a combination of those two things. We're going to start just looking at the first type. So for this equation, the left-hand side, which is x add 3, equals the right-hand side, which is 7. So to get the unknown by itself, I want to subtract 3 from both sides. Like this. This side gives me x, and this side gives me the answer 4. The nice thing about equations is that you can always check your answer to make sure it's correct. I'm saying that the unknown value x is equal to 4. If I put this into here, I have 4, add 3, and that's definitely 7. So in this one, again, I want to get x by itself. Because I've got x minus 6, it makes sense to get rid of the minus 6 by adding 6 to both sides. So this side gives me x, and here I get 15. Remember, we can always check our answer. X is 15. If I put that into here, I have 15 minus 6, which is definitely 9. Here are some questions for you to try now. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. So we can now answer this type of question. We're going to look at the second type now. In this one, the unknown x has been multiplied by 2. So it makes sense to divide both sides by 2. This side gives me x, and this gives me 7. I can check my answer by saying 2 times 7 is 14. For this one, the unknown is divided by 5, so I'm going to multiply both sides by 5. This gives me x, and this gives me 15. A quick check, 15 divided by 5 is 3. In this question, the unknown has been multiplied by 2 and then divided by 5. So I've got to reverse this. First of all, I'm going to multiply both sides by 5. This side gives me 2x, and this gives me 20. I now need to divide both sides by 2. Now this side gives me x, and this gives me 10. Again, I can check my answer. 2 tens are 20, divided by 5 is definitely 4. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. We can now do questions with adding and subtracting, and questions with dividing and multiplying. We're now going to combine the two techniques to be able to answer the third type of equation question. Again, I'm trying to get x by itself, so it makes sense for this question to start by subtracting 4 from both sides. I get that 2x equals 7 minus 4, which is 3. We now want to divide both sides by 2. 2x divided by 2 gives me x, and 3 divided by 2 gives me 3 over 2, which we can also write as 1.5, or we could write 1.5. Any of these three answers would be accepted on the exam. For this one, I'm going to start by adding 9 onto both sides. I get 3x over 2 equals 6 plus 9, which is 15. Now I want to multiply both sides by 2. That will give me 3x equals 15 multiplied by 2, which is 30. I now want to divide both sides by 3. 3x divided by 3 gives me x, and 30 divided by 3 gives me 10. Remember, you can always check your answer to make sure that it's correct. We've got that x equals 10 on this one. 3 tens are 30, divided by 2 gives me 15, and if I take away 9, I do get 6. Here are some questions for you to try now. Remember that you can check your answers. Press pause and have a go. When you're ready, press play. Here are the answers. So we've now mastered these three types of equation. We're going to move on to more difficult questions now. We're going to tackle this type of question by changing it into a simpler equation. For this first one, On the left-hand side, I can see that I've got 3 multiplied by this bracket. On the right-hand side, I've got 36, which is a multiple of 3. So what I'm going to do first of all is divide both sides by 3. This gives me 4x plus 2 equals 36 divided by 3, which is 12. I now have a much simpler equation, which I already know how to solve. I'll take 2 from both sides to give me 4x equals 10. I now divide both sides by 4 to give me x equals 10 over 4, and I can cancel this down to x equals 5 over 2. Or I could write 2.5 or 2.5. Now on this question, I can see that this bracket here has been multiplied by 3, but 5 is not a multiple of 3. So what I'm going to do instead of dividing by 3 first of all, is to multiply out this bracket. So I've got 3 times 4x, that's 12x, and I've got 3 times minus 2, that's minus 6, and that's equal to 5. This is now a simpler equation which I can solve. I'm going to add 6 to both sides to give me 12x equals 11, and now I need to divide both sides by 12 to give me x equals 11 over 12. For this one, I can see that everything here has been divided by 2. So I want to multiply both sides by 2. I have 5x minus 1 equals 7 times 2, which is 14. This is now the simple style of equation that I know and love. I'm going to add 1 to both sides. So I've got 5x equals 15. I can now divide both sides by 5 to give me x equals 3. Now to quickly summarise, if the question looks like this, and this number here is a multiple of this number, I always divide first of all to get a simpler equation. If it looks like this, and this number here is not a multiple of this number, then I prefer to multiply out the brackets to get my simpler equation. And for this type of question, the part that's making it complicated is this divide by 2 here. So I like to start by multiplying both sides by 2 to make it into a simpler equation. Here are some questions for you to try now. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. We now come to the type of question which examiners really love, and it's the first time we've met questions where the unknown x is on both sides. Our technique is going to be to get rid of the x's from one side or the other. I start this question by looking at which side has the larger number of x's. That's the 5x here, so what I'm going to do is subtract 3x from both sides. It looks like this. I've got 5x minus 3x here, which is 2x, and I've also got a minus 3. On this side I've got 3x minus 3x, which is 0, and I've got a plus 11. Now this looks like the simple type of equation that I'm used to. So I add 3 to both sides to give me 2x equals 14. I now divide both sides by 2 to give me x equals 7. Remember, you can always check your answer. 5 sevens would be 35, take away 3 would be 32. 3 sevens is 21, plus 11 is also 32. 32 definitely equals 32, so I know that this is right. For this question, I'm going to start by multiplying everything in this bracket by 5. So I have x plus 2 equals 5x minus 10. I now say to myself, where's the larger number of x's? That's here. I've got 5x compared to 1x here. So what I want to do is take this 1x away from both sides. That looks like this. On this side, I've got x minus x, which is nothing, plus 2, which just gives me 2. On this side, I've got 5x minus x, which is 4x, and I've also got minus 10. I can now add 10 to both sides to give me 12 equals 4x, and divide both sides by 4 to give me 3 equals x. More often we write the answer as x equals 3. Here are some questions for you to try. Be careful with question H, it's really difficult. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For question H, I began by multiplying this bracket by 4 to give me 12x minus 8. On the other side, I have 44 minus 14x. I now need to say, where is the larger number of x's? And it's quite tempting to think that this 14 is bigger than this 12. But notice it's actually a minus 14, so it's smaller than 12. So I add 14x onto both sides to give me this line here. This is now a simple style of equation, and we can get the answer in a couple of steps. Now we come to the hardest type of equation in this clip. Again, we're going to change them into simpler equations. We do this by multiplying both sides by something. Let me show you how. Now the bit that's making this equation difficult is the divide by 2 here. So I'm going to start by multiplying both sides by 2. When I multiply this side by 2, the divide by 2 is going to disappear, so I get 5x minus 4. I've still got to multiply this side by 2, so I have 2 times x, that's 2x, and 2 times 3, that's 6. So now I'm at the previous type of equation that I've just done, where I have x's on both sides. I look for the larger number of x's, that's here, so I subtract the smaller number of x's, that's 2x, from both sides. That will give me 3x minus 4 equals 6. Now I add 4 to both sides to give me 3x equals 10, and I divide both sides by 3. I get x equals 10 over 3. Or I could also write 3 and 1/3. Looking at this one, I can see that the things that are making it difficult are the divide by 3 here and the divide by 4 here. So first of all, I'm going to get rid of the divide by 3 by multiplying both sides by 3. So this will be 2x plus 1, and this will be 3 times 3x, which is 9x, minus 3 times 4, which is 12, and that's over 4. Now I want to get rid of the divide by 4. I do that by multiplying both sides by 4. Multiplying by 4 here gives me 8x plus 4, and multiplying by 4 here simply gets rid of the divide by 4, so I have 9x minus 12. Now I take 8x away from both sides to give me 4 equals x minus 12, and I add 12 to both sides to give me 16 equals x. We write this more often as x equals 16. In an exam, this would be a really high-scoring question, so it's always worth checking your answer. So x is 16, 2 x's will be 32, plus 1 is 33, divided by 3 is 11. 3 x's would be 48, subtract 4 would be 44, and divided by 4 is 11. 11 is definitely equal to 11, so I know that 16 is the right answer. Here are 2 questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. When writing equations, any letter can be used for the unknown. Here's a range of different equations. Press pause and have a go. When you're ready for the answers, press play. And here are the answers. These are all equations. We can recognise an equation because it has an equal sign in it, and it will also have an unknown shown by a letter. If we're asked to solve an equation, we want to work out what the unknown is. In other words, I want to get the unknown by itself. These would be the answers to these equations. We can see that these are right because, for example, on the first one, 2 times 6 is 12. 3 times 3 is 9, take away 1 is 8. 5 times 2 is 10, plus 3 is 13, and if I double that, I get 26. 15 divided by 3 gives me 5. I'm now going to show you how to solve the 6 main types of equation. This one is in a different colour because it's the most common type of equation that you will get on an exam paper. To be able to solve these types of equations, we need to learn 2 techniques. They're called float and ping and escalator. I'm going to start by showing you how to use the float and ping technique. So we have this equation, x minus 6 equals 9. To get the x by itself, I want to get rid of the minus 6, so I draw a bubble around it. It floats over the equal sign, and as it goes over, ping, it changes into a plus 6. So when it lands on the other side, we've got 9 plus 6. From this, we can tell that x equals 15. I can quickly check my answer by putting this 15 back into the original equation. 15 minus 6 does give me 9. So on the second one, I want to get rid of the plus 3. It floats and pings. We have x equals 7, and this time it's pinged to a minus 3. We can work out that x equals 4, and we can check this. 4 plus 3 is definitely 7. The second technique is escalator, and we use this when the x has either been multiplied by a number or divided by a number. If the x has been multiplied by a number, then the number goes down the escalator, and we have x equals 14 over 2. This means 14 divided by 2, so we can work out that x equals 7. We can check the answer by saying 2 times 7 is definitely 14. If the number is below the x, in other words, the x has been divided by that number, then the number needs to go up the escalator. We have x equals 3 times by 5 now, and we can work out that x equals 15. This can be checked. 15 divided by 5 does give me 3. Once you get the hang of these 2 techniques, you'll find that they're all you need to solve all the different types of equations. For instance, if we look at these 3 types of equations, the first type can be solved using float and ping. The second type can be solved using escalator, and the third type can be solved using a combination of float and ping followed by escalator. So for this equation, I float and ping the plus 2. I get x equals 11 minus 2, and from this I can calculate that x equals 9. I can check this. 9 plus 2 is definitely 11. For this one, I float and ping the minus 5. I get x equals 3 plus 5. So x equals 8, and 8 take away 5 is definitely 3. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. On the last one, the trick is to remember that you're trying to get the x by itself, so you want to float and ping this 6. Because it doesn't have a minus in front of it, we know it must be a plus 6, and we float and ping it in the usual way. So now that we can use the float and ping technique, we need to master the escalator technique. Here, the x has been multiplied by 3, so the 3 is going to go down the escalator. We get x equals 15 over 3. Remember, this means we need to divide. X is 5, and we can check it. 3 multiplied by 5 is 15. On this one, the 4 needs to go up the escalator. We get x equals 7 times 4. So x is 28. 28 divided by 4 is 7. For this one, the 5 needs to go up the escalator and the 2 needs to go down the escalator. I'm going to start with the 5. So I get 2x equals 4 times 5, which is 20. Now the 2 can go down the escalator. I get x equals 20 divided by 2, which is 10. I can check this. 2 times 10 is 20, divided by 5 does give me 4. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. So now we can use float and ping and escalator. We need to know how to combine the two techniques to solve this kind of equation. I have to get x by itself, so it makes sense to float and ping the plus 4 first. I get 2x equals 7 minus 4, which is 3. Now the 2 can go down the escalator. I get x equals 3 over 2. This is an acceptable answer. You could also write 1.5 or 1.5. In this one, it makes sense to start by float and pinging the minus 9. So I have 3x over 2 equals 6 plus 9, which is 15. Now the 3 needs to go down the escalator and the 2 needs to go up the escalator. I'm going to start with the 2. So I have 3x equals 15 times 2, which is 30. Now the 3 can go down the escalator, and I get x equals 30 divided by 3, which is 10. I'm going to check this now. So 3 times 10 is 30, divided by 2 is 15, and take away 9 does give me 6. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. We've now mastered these 3 types of equation. We're going to move on to more difficult questions now. We're going to tackle this type of question by using the techniques of float and ping and escalator to change them into simpler equations. I can see that here I've got 3 multiplied by everything in this bracket, and 36 is a multiple of 3. So I'm going to start by taking the 3 down the escalator. I get 4x plus 2 equals 36 divided by 3, which is 12. I've now got a simpler equation. I float and ping the plus 2, which gives me 4x equals 12 minus 2, which is 10, and then I can take the 4 down the escalator to give me x equals 10 over 4, which is the same as 5 over 2. Or I could write 2.5 or 2.5. Now I could solve this equation in the same way, but because 5 is not a multiple of 3, when I take the 3 down the escalator, I get 5 over 3, which is a nasty fraction to have to deal with. So instead, I'm going to multiply out the brackets. 3 times 4x is 12x, and 3 times minus 2 is minus 6. This is equal to 5. I've now got a simple equation. I can float and ping the minus 6 to give me 12x equals 11, and I can take the 12 down the escalator to give me x equals 11 over 12. Just out of interest, when I started doing this question, I could have multiplied out the brackets instead of taking the 3 down the escalator, and it would have worked out. In this equation, the part that's making it difficult is the divide by 2. So I'm going to start by taking the 2 up the escalator. So I have 5x minus 1 equals 7 times 2, which is 14. This is now a simple equation. I float and ping the minus 1 to give me 5x equals 15, and I take the 5 down the escalator to give me x equals 15 divided by 5, which is 3. I can check my answer. 5 times 3 is 15, take away 1 is 14, and divide by 2 does give me 7. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. We now come to the type of question which examiners really love, and it's the first time we've met questions where the unknown x is on both sides. Our technique is going to be to get rid of the x's from one side or the other. So I start this question by saying to myself, which side has got the larger number of x's? That's here, the 5x, and it's on the left. So what I'm going to do is float and ping all of the x's to the left and all of the numbers to the right. So I have 5x minus 3x equals 11 plus 3. That's 2x equals 14. Now the 2 can go down the escalator, and I get x equals 14 divided by 2, which is 7. I can check this answer. 5 times 7 is 35, minus 3 is 32. 3 times 7 is 21, plus 11 is 32. Both sides gave me the same answer, so I know that it must be correct. Looking at this question, I could start by taking the 5 down the escalator, but then I'd get a difficult fraction on this side of the equation, so I'm not going to do that. So instead, I'm going to multiply out the bracket here. So that gives me x plus 2 equals 5x minus 10. Now I look for the larger number of x's, which is here on the right. So I'm going to float and ping the x's to the right and the numbers to the left. So I get 2 plus 10 equals 5x minus x. So that's 12 equals 4x. Now the 4 can go down the escalator, and I get 12 divided by 4, which is 3, equals x. More often we write this answer as x equals 3. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. We now come to the hardest type of equation in this clip. Again, we want to change them into simpler equations. We do this using our techniques of escalator and float and ping. The difficult part of this equation is the fact that I've got 5x minus 4 all divided by 2 on this side, so I'm going to start by taking the 2 up the escalator. So I get 5x minus 4, and then everything on this side needs to be multiplied by 2. So I get 2x plus 2 times 3, which is 6. Now I look for the larger number of x's. That's here on the left. So I float and ping the x's to the left and the numbers to the right. So I've got 5x minus 2x equals 6 plus 4. So that's 3x equals 10. Now the 3 goes down the escalator to give me x equals 10 over 3. You could also write this answer as 3 1/3. Here, this side has been divided by 3 and this side has been divided by 4. So I want to take both the 3 and the 4 up the escalator. So the 3 is going to go this way and the 4 is going to go this way. So I'm multiplying everything here by 4. That gives me 8x plus 4. And I'm multiplying everything here by 3. That gives me 9x minus 12. Now I look for the larger number of x's. That's here on the right-hand side. So I'm going to float and ping the x's to the right and the numbers to the left. So I have 4 plus 12 equals 9x minus 8x. So I've got 16 equals x. And this is my answer. I just need to write it more clearly the other way round. X equals 16. I can quickly check this one. 2 times 16 is 32, plus 1 is 33, divided by 3 is 11. 3 times 16 is 48, take away 4 is 44, divided by 4 is also 11. I get the same number on both sides, so I know that this is right. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. When writing equations, any letter can be used for the unknown. Here's a range of different equations. Press pause and have a go. When you're ready for the answers, press play. And here are the answers. In this question, I'm being asked to make A the subject of this formula. At the moment, V is the subject of this formula because it says V equals. So when we finish doing the question, we want it to say A equals. In order to rearrange this, I'm going to use the same techniques that I use for solving equations. Remember, I'm trying to get the A by itself. At the moment, it's with a T and it's also with a U. The first thing I want to do is get rid of the plus U. To do this, I'm going to subtract U from both sides. So I get V minus U equals AT. Now the A is just with a T, and it's actually A times T. So to get rid of the T, I want to divide. So I'm going to divide both sides by T, and I get V minus U over T equals A. Because the A is now by itself, it is the subject of the formula, but you might like to rewrite it as A equals V minus U over T. Both of these answers are perfectly correct and would get full marks in the exam. Just out of interest, these are not the only correct answers. I'm now going to give you a selection of other answers which are also correct. Here are 3 of them. Although they all look quite different, they're actually all equivalent answers. Now this looks like exactly the same question, but if we read it carefully, we'll see that this time we're being asked to make U the subject of the formula. So we want our final answer to say U equals. At the moment, the U is just with a plus AT. So this is the only thing I want to get rid of, and I can actually keep it together as an AT. So I'm going to take it away from both sides. I get V minus AT equals U. Now the U is by itself, so this is actually finished. We can rewrite it as u equals v minus at. Another correct equivalent answer would be this. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. There are other ways of writing each of these answers, but they'll all be variations of these. Now this is a much more difficult question. I want to make S the subject of this formula. The thing that's making it really difficult is the fact that the S is actually negative because it's part of this minus 5as. So the first thing I want to do is actually add this term to both sides so that I've got it as a positive term. So I would have v squared plus 5as, and that now just equals p squared. Now remember, we're focusing on the s. It's part of the 5as, but we've also got this v squared added onto it. So I'm going to take v squared away from both sides. So I've got 5as equals p squared minus v squared. I'm nearly there now. The s is now just part of this 5as, so it's been multiplied by the 5 and by the a. So I want to divide both sides by 5a. So I get s equals p squared minus v squared divided by 5a. S is now the subject of the formula. Some people might start this question in a slightly different way, by subtracting the p squared from both sides. That would give you this line, and you would then need to divide both sides by minus 5a. This is another correct answer. Here's a difficult question for you to try. Notice that this time you want the subject of the formula to be cos A. So you're trying to get the cos A by itself. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. I've shown you two different methods, but the final answers are equivalent. All of these involve using letters. Sometimes you need to know the difference between an expression, an identity, a formula, and an equation. I'm going to go through these now with you. An expression is easy to spot. There's never an equals sign in it. In an identity, the left-hand side will always be equal to the right-hand side, no matter what numbers are substituted for the letters. It's sometimes shown with this symbol here, but sometimes it will be an equal sign instead. A formula is something where you can work out the value of the left-hand side if you know the values of the variables on the right-hand side. An example would be the formula for the perimeter of a rectangle, which is what we've actually got here. An equation can be solved to find the value of the variable. Take a moment to read through these definitions and make sure that you understand the differences between them. Now here's a question for you to try. Press pause and have a go at it. When you're ready for the answers, press play. So this one is the equation because we can solve this to find the value of x. This one is an identity. It's easily spotted because of this symbol here. But remember, this could be an equal sign. If I expand this bracket, I have 2x minus 14, which is identical to 2x minus 14. This one's a formula because I would need to know the values of these variables here to be able to work out the value of this variable. You might even notice that this is the formula for the area of a triangle. And finally, this last one is an expression because there's no equals sign. In this question, I'm told that batteries are sold in packets and boxes. There are 4 batteries in a packet, and there are 10 batteries in a box. I'm told that Sarah buys a certain number of packets of batteries, which we're calling P, and a certain number of boxes of batteries, which we're calling B. The total number of batteries that she buys is going to be called T. I want to write down a formula for T in terms of P and B. Because I want to write down a formula for T, I've got to start with T equals. Now I know that there are 4 batteries in a packet. If I was to buy 5 packets of batteries, I would get 5 times 4, which is 20 batteries. If I was to buy 10 packets of batteries, I would get 10 times 4, which would be 40 batteries. So I know that I always multiply the number of packets of batteries, which remember I'm calling P, by 4. So that's 4P. This can now go into my formula over here. In the same way, I'm going to multiply the number of boxes of batteries that I buy, which is B, by 10. I get 10B, and I can put this into my formula as well. Because I want the formula for the total number of batteries, we've got to have 4P plus 10B. Don't forget to put the plus in. This is the finished formula for the total number of batteries that Sarah buys. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. We're now going to look at forming expressions and equations. I want to write down an expression for the perimeter of this triangle. I know that to get the perimeter, I've got to add all the sides together. So if I add these 3 terms together, I have x, x and x, that's 3x, plus 4 plus 2, so that's plus 6. This is my expression. Notice there's no equals sign in it. I'm now told that the perimeter is 21 centimetres and I want to write down an equation. So I can now turn my expression for the perimeter into an equation by putting the equals sign and the number I've been given. For the last part, I want to solve this equation to find x. So my equation is 3x plus 6 equals 21, and you need to solve this in your usual way. So we would have 3x equals 15, and the final answer would be that x equals 5. I can now check this answer by using the diagram. I know that x is 5, so this here is 5, this is 5 add 4, so that's 9, and this is 5 add 2, so that's 7. Adding these 3 numbers up gives me 21, which is what I was told that the perimeter would be. You don't get any extra marks for checking your work like this, but it does reassure you that your answer is correct. Here's one for you to try. Don't forget that when you're asked for perimeter, you need to add all 4 sides together. Once you've found the value of x, you can use it to find the length of the rectangle and the width of the rectangle, and you can then use these to work out the area. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one for you to try. Remember that the angles inside a triangle always add up to 180 degrees. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. I hope you realised that you needed to form an equation like this and then solve it to find the answer. Here's your final question. This one looks much more difficult than it is. You'll find that copying this diagram and labelling it correctly will help. Press pause and have a go. When you're ready, press play. Here's the answer. I want to represent this inequality on this number line. I can see that n is in between -2 and 5, so I draw a little circle at -2 and a little circle at 5. N can be anything in between -2 and 5, so I join the two circles together with a line. To show that n can be anything in between the -2 and the 5 on the number line. Now we have to look at these symbols. This one tells me that n is strictly greater than -2, so I leave this circle uncoloured. But this one tells me that n is less than or equal to 5. To show this, I colour in the circle. On this one, I can see that n is between -4 and 7, so I draw a circle at the -4 and a circle at the 7. I join the two circles together with a straight line. This tells me that n is greater than or equal to -4, so I colour in this circle. And this tells me that n is less than or equal to 7, so I also colour in this circle. I've now represented both of these inequalities on the two number lines. Here are two for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I now want to do the opposite. I'm given the diagram and I want to write down the inequality that is being shown. I know that the letter to use is n because it says it here. And n is in between 3 and 8. Now n is greater than or equal to 3 because this circle is coloured in, but n is strictly less than 8 because this circle is not coloured in. This is the inequality shown here. If you ever get confused with these symbols, just remember that they always point this way and that you need to put the equals part on if the circle is coloured in. So for this one, the letter is n. It's in between -3 and 6. The symbols look like this. And because this one is coloured in, I need the equal to part here. Here are two of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is another type of question on inequalities that you might get. And these questions become straightforward when you realise that integer means whole number. So n can be all the whole numbers in between -3 and 4. I'm going to start by writing down all of those numbers. So that's -3, -2, -1, 0, 1, 2, 3, and 4. Now I need to look at the symbols. N can be equal to -3, so I leave the -3 here. But n cannot be equal to 4. It is strictly less than 4, so I need to cross out the 4. These values are my answer. So for this one, I'm going to write down all the integers in between -1 and 6. So that's -1, 0, 1, 2, 3, 4, 5, and 6. Looking at this symbol, I can see that n is not allowed to be equal to -1, so I cross it out. And this one tells me it's not allowed to be equal to 6, so I cross this out too. These values are my answer. Here are two of those for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. To solve inequalities, we use the same techniques as when we're solving equations. So looking at this line, my first line of working would be 2x is less than or equal to 8, and then I would have that x is less than or equal to 4. The main difference between solving equations and solving inequalities is that when you write your answer on the exam, you have to write all of this down. You're not allowed to just write the 4. Also notice that I've kept my inequality symbol the same all the way through my working out. So for the second one, I would have x over 2 is greater than 7, and then I would have x is greater than 14. This whole thing is the answer. Here are 4 for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. For the last one, you can write any one of these 3 answers. I'm being asked to use the graphs to solve the simultaneous equations here. Simultaneous means at the same time. These graphs are at the same place at the same time, here, where they cross. And I can see that the value of x is here, that's 0.5, and the value of y is here, that's 6. So I write my answer as x equals 0.5 and y equals 6. So to summarise, if you have a question like this, you're looking for the coordinates of the point where the graphs cross. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Finally, here's a more difficult question for you to try. In the first part, you're being asked to draw the graph of this. Remember that to do this, you'll need to use a table to help you. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. I used this table to help me draw this line here, and then for the second part, I just needed to find where the 2 lines crossed. The Fibonacci sequence is quite a famous sequence of numbers in maths. It looks like this, or like this. To work out each term in the sequence, you add the preceding 2 numbers together. So, 1 and 1 makes 2, 1 and 2 makes 3, 2 and 3 makes 5, and so on. So if I wanted to work out the next number in this Fibonacci sequence, I would say 13 add 21, and that gives me 34. In the same way, the next number for this sequence down here is 34 as well. Here's a question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. To get this, I continued the sequence until I found a square number. 144 is 12 times 12, so this is the next square number. Now this is a more difficult looking question, but as soon as I explain to you what this part here means, you'll see that it's actually quite straightforward. x1 is 1. That's telling me that the first number in the pattern is 1. x2 is 1. That's telling me that the second number in the pattern is also 1. x3 is 2. That's telling me that the third number in the pattern is 2. Now I've got the start of a Fibonacci sequence, and I can continue it in the usual way. So to get the next number, 1 add 2 is 3, and for the next one, 2 add 3 is 5, and so on. Now the question is asking me to find the least value of n for which xn is greater than 300. What this means is I've got to continue the pattern until the number goes over 300, and then see which term in the sequence that is. Why don't you try this for yourself? Press pause and have a go. When you're ready, press play. Here's the answer. You should have got that n equals 14 because the pattern goes over 300 on the 14th number. This question looks even harder still, but we just need to remember that x1 means the first number is 1, this is the second number, that's 1 as well, and this is the third number, that's 2. I can carry on the pattern as I need to. Now what I'm looking for is where a term plus the next term makes 21. So I'm going to keep this number pattern going until I get to 21. So the next number is 3, then 2 plus 3 is 5, 3 and 5 makes 8, 5 and 8 makes 13, and 8 and 13 makes 21. So I found the number 21. Now xn must be this number here, and xn plus 1 is this one here. I'm actually looking for the value of n. So n must be 6, because this here is the 6th number in the pattern. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another question for you to try. This time you can use a calculator to help you, and you're going to need to work systematically. Press pause and have a go. When you're ready, press play. Here's the answer. These are two typical questions on expanding and simplifying. If I was asked to do these on an exam, I would get these answers here. Now in this clip, we're actually going to be looking at factorising, which is the opposite of expanding. So this question here, if you look carefully at it, you'll notice it's the answer here. So the answer when I factorise this must be x plus 1, x plus 3. In the same way here, you can see I've got this answer. So the answer for this when I factorise it is x plus 3, x plus 4. Now obviously you won't always have the answers on the page in front of you like I just did. We need to work out a method for factorising this. First of all, these are both quadratic equations, so we know that we're going to have two sets of brackets for them. We have an x squared here and here. That tells us we're going to have an x in each bracket, because x times x will give me the x squared. Now, the number I put here multiplied by the number I put here must give me 3. So I'm going to put plus 1 here and plus 3 here, because 1 times 3 is 3. Let me now check that this all works out to give me this. Simplifying gives me x squared plus 4x plus 3, which matches what I had here. Something else to notice is that from the 3 and the 1, I got a plus 3x and a plus 1x, and they added together to give me my plus 4x, which matches this here. So notice the 1 and the 3 here multiply to give me this 3, and they add to give me this 4. I'm going to use this as a method to help me find the numbers for this one. So to find the two numbers here, I want two numbers that multiply to give me 12. There are a few possibilities. I could have 1 times 12, 2 times 6, or 3 times 4. But I want the pair that will definitely give me 7. Looking here, 1 and 12 won't give me 7, 2 and 6 won't give me 7, but 3 and 4 will. So I can put the plus 3 in here and the plus 4 in here. If I want to check my answer, I can expand these brackets. And you can see that what I get matches this. So to summarise, whenever I'm factorising this type of quadratic, I get two sets of brackets with an x in each. Then these two numbers here must multiply to give me this and add to give me this. So for this question, it's a quadratic, so we know we've got two sets of brackets, and we know we've got an x in both of them. Now we want two numbers that multiply to give us 8, so we could have 1 and 8, or 2 and 4. We want the pair that will give us 6, and that's going to be the 2 and the 4. So we've got plus 2 and plus 4. This is the fully factorised quadratic equation. Now here are 3 for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Now you might have noticed that in all the questions we've done so far, all the signs have been positive. What happens if we've got negatives? Well, actually, we use the same method. So we start in the same way, with two sets of brackets because it's a quadratic, with an x in each. We then want two numbers that multiply together to make minus 3. Because it's negative, that tells us one of them will be a minus. So we could have 1 and minus 3, or minus 1 and 3. Now we want the pair that will add up to give us plus 2. If I add these up, I get minus 2. If I add these up, I get plus 2. So this is the pair I'm going to use. So in the first bracket, I'm going to put the minus 1, and in the second bracket, I'm going to put the plus 3. This is the factorised version of this quadratic equation. So let's try this one now. Again, we've got two brackets, and we know we've got an x in each. We want two numbers that will multiply together to make minus 12. Remember, one of them needs to be a minus. So we could have 1 and minus 12, or minus 1 and 12, 2 and minus 6, or minus 2 and 6, 3 and minus 4, or minus 3 and 4. Now, I want the pair from here that will add up to give me minus 1. A bit of common sense rules out all of these pairs and leaves me just with these. If I add these together, I get minus 1. So this is the pair I'm going to use. So in the first bracket, I'm going to put a plus 3, and in the second bracket, I have minus 4. This is the finished answer for this one. Here are some of those for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now this question looks similar to the ones that we've already done, but there is a slight complication with it which I'm going to show you now. It's a quadratic, so we start in the same way, two sets of brackets, and we know we've got an x in each. Now we're looking for two numbers that multiply together to give plus 8. So that could be 1 and 8, or 2 and 4. Now I want to find the pair that will give me minus 6. This pair definitely won't. If I add this pair together, I'll get plus 6, but I want minus 6. The only way I can make minus 6 using them is to make this a minus and this a minus as well. Now, does this still give me the plus 8 that I'm looking for? Well, yes, it does, because minus 2 times minus 4 is plus 8. So I've now got my pair of numbers. In the first bracket, I've got a minus 2, and in the second bracket, I've got a minus 4. Let's look at this one. Again, we've got two sets of brackets, and we have an x in each. Now we want two numbers that multiply to give us 12. So that could be 1 and 12, 2 and 6, or 3 and 4. They've got to add to give me minus 7. This won't work, and this won't work. But these two will add to give me plus 7. Remember, I want minus 7, so I'm going to make that minus and that minus as well. Now these definitely add to give me minus 7, and they definitely multiply to give me plus 12. So I've got minus 3 and minus 4. Here are some of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now here's a mixture of all the different types of questions we've looked at so far for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Just out of interest, if you're thinking that something like this is rather a lot of work, when you get more practiced at these, you'll be able to home in on the answer without writing out all the different options. This will make it quicker for you to answer the question. Here, I'm going to show you how to solve quadratic equations where the right-hand side is equal to 0. Before we do this, I need to show you one thing. If we have two things multiplied together and the result is 0, then we know that one of the two things must be 0. So in this example, either A is equal to 0 or B is equal to 0. In algebra, you might get something like this: x minus 3, x plus 1 equals 0. This is the same situation as this because we have this multiplied by this and we get 0. So we know that either x minus 3 equals 0 or x plus 1 equals 0. We can now find two solutions to this by solving these two little linear equations. Here I would get that x is equal to 3. And here, I would get that x is equal to minus 1. These would be my two solutions to this. So to apply what we've just looked at to these quadratic equations, the first thing we need to do is factorize them. So I've done this using my normal method. Now, I know here that either x minus 2 equals 0 or x minus 6 equals 0. And I can solve these to get my two solutions to the quadratic equation. From this one, I get that x is 2, and from this one, I get that x is 6. In the same way here, either x minus 3 is 0, or x plus 8 is 0. I can solve this, and I get that x equals 3, and solving this gives me that x equals minus 8. So these are my two solutions to this quadratic equation. Out of interest, if you want to check your answers, you can substitute 2 into this equation and you'll find that you do get 0, and you can also substitute 6 in and find again that you do get 0. And likewise, you can check 3 and minus 8 in here. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one that's slightly more difficult for you to try. Remember, you can only solve a quadratic using the method we've been doing when it's equal to 0. So you need to do something to this first before you begin. Press pause and have a go. When you're ready, press play. Here are the answers. The first thing I needed to do was make this equal to 0. I did that by subtracting 5 from both sides to give me this new equation. I then factorised this in the usual way and solved my two little linear equations to get my two answers. In this clip, we're going to be looking at something called the difference of two squares. To explain this, first of all, I'm going to expand and simplify this. So I've got x times x, which is x squared, x times minus 3, which is minus 3x, plus 3 times x, which is plus 3x, and plus 3 times minus 3, which is minus 9. If I simplify this, I get x squared minus 9. This is what we mean by the difference of two squares. This is a square number, so is this, and we have the difference. If we want to factorise this, we get this. Now I'm going to use this answer to help me do this one. I can see that when I multiplied this out, I ended up with x squared here, 3 squared here, which was 9, and a minus in between them. So for this one, which follows the same pattern, I'm going to get x squared minus 5 squared, which is 25. If you want to prove this to yourself, you can work it out the long way. X times x is x squared, x times plus 5 is plus 5x, minus 5 times x is minus 5x, and minus 5 times plus 5 is minus 25. Simplifying gives x squared minus 25, which matches what I originally put. Here's one for you to try now. Try to do it the quick way without writing out the full expansion. Press pause and have a go. When you're ready, press play. You should have got x squared minus 100. We refer to these as the difference of two squares. A more formal way of writing this result using algebra would be x plus a multiplied by x minus a gives me x squared minus a squared. We're now going to use what we've just learnt to factorise things like this. You need to spot that this is a square number and this is a square number, so this is a difference of two squares. It tells me that it's going to have two brackets with an x in each. One will be a plus and one will be a minus. Doesn't matter which way round you put them. And then the number will be the square root of this number here. The square root of 1 is 1, so that goes in both brackets. In a similar way for this one, this is a square number, so is this. So we've got x minus something and x plus something. The something is the square root of 49, which is 7. This one looks more difficult, but 4y squared is still a square number because 4 is a square number in itself. So we have two brackets. We need the square root of 4y squared, so that's the square root of 4, which is 2, and the square root of y squared, which is y. One's a plus and one's a minus, and the square root of 9 is 3. Again, in a very similar way, we have two brackets. The square root of 25 is 5, and the square root of h squared is h, so we have 5h. A plus and a minus, and then the square root of 16. We use this technique to factorise an expression when we spot that that expression is a difference of two square numbers. Remember, when you get your two brackets, they will be pretty much the same, but one will be a plus and one will be a minus, and it doesn't matter which way round these are. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. I'm now being asked to solve this equation. Immediately I spot that I've got a difference of two squares here, so I'm going to factorise it. I've got x plus 5 and x minus 5, and that's equal to 0. Now I know that one of these two brackets must be equal to 0 to make the whole expression 0. If this one is equal to 0, then x equals minus 5, and if this one is equal to 0, then x equals 5. So I get two answers, minus 5 and 5. Out of interest, you might have realised that you could approach this in a different way. If you add 25 to both sides, you get x squared equals 25. Now to solve this, I need to square root both sides, so I get x equals the square root of 25. Now the danger here is that you need to remember that when you square root 25, you will get a positive answer and a negative answer. So your two answers for x are 5 and minus 5. Because some people forget the minus 5, you might prefer to do it this way, where you'll definitely get both answers. Now here's one for you to try. My advice is to do it using this approach. You'll find that if you try to use this way, it's much more difficult. Press pause and have a go. When you're ready, press play. So for this one, you should have spotted that you've got a difference of two squares and you should have factorised it. So we get 2x plus 9 and 2x minus 9, and that's equal to 0. Now you know that either of these two brackets is equal to 0, so we've either got 2x plus 9 equals 0, or we've got 2x minus 9 equals 0. I get my x values by solving these two equations. So I've got here 2x equals minus 9, and then x equals minus 9 over 2. And here I've got 2x equals 9, and then x equals 9 over 2. These are my two solutions. Here are some more questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I want to find the equation of this red line. The key to doing this is to know that the equation of any straight line will have a form like this. M and C are just two numbers. This one is straightforward to get. It's where the line cuts across the y-axis. That is definitely at the number 1. So we just need to find the gradient. So I choose a point, which I'm going to choose here. Go across any amount you like. I've chosen to go across 1. And then go up till we hit our line. And I've gone up now 2. Notice this is a positive gradient. The line's going up. So the gradient is the vertical distance 2 divided by the horizontal distance 1, and that gives me 2. So the answer is that the equation is y equals 2x plus 1. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. So for this line, the point where it cuts the y-axis is 2, and the gradient, I'm going to choose this point here, go across, I've gone across 1, and go up, I've gone up 3, so the gradient is 3 divided by 1, which is 3. So your final answer is y equals 3x plus 2. Here's another one for you to try. Press pause and have a go. When you're ready, press play. For this one, the point where it crosses the y-axis is here at -1. And now all I need to do is work out the gradient. I'm going to choose this point here, and I'm going to go across. Now I'm not going to go across 1, because I end up going up an amount that I don't know for certain. So I'm going to go across to here, and then go up to here. So I've gone across by 2, and I've gone up by 1. So the gradient is 1 divided by 2, and I can just leave it like that because it's a half. So the answer is y equals a half x minus 1. Obviously, you could also write this as y equals 0.5x minus 1. Both of these two answers are correct. Here's another one for you. Press pause and have a go. When you're ready for the answer, press play. Here's the answer for that one. Here's another for you. Press pause and have a go. When you're ready, press play. Here's the answer. You can write this one like this or like this. Here's another one. Press pause and have a go. When you're ready, press play. Here's the answer. Notice that even though the gradient was minus 1, I haven't written minus 1 in front of the x. Instead, you should write it as minus x. Here's another one for you to try. Don't let the fact that this one is on graph paper put you off. It's exactly the same as the others. Press pause and have a go. When you're ready, press play. Here's the answer for this one. This answer would also be correct. Now this is a difficult exam-style question. It looks really confusing, but actually when it's asking you for a formula for c in terms of n, it really just wants you to find the equation of this line. The main difference is that this axis here, which is usually the x-axis, they've called n, and this one, which is usually the y-axis, they've called c. So, we usually have y equals mx plus c. We're now going to change the y to the c, and this is m, and we're going to change the x to the n, and we've got a little c on the end. I can now do this in the exact same way as before. So I look where it crosses the y-axis, and that's here at 5. So this is 5. Now I need to work out the gradient. So I'm going to start here. I thought about going across to 100, but when I go up, that's not a number that I'm absolutely sure of. So instead, I'm going to go across to 200, and then I can go up, and I land here exactly at the 20. So I've gone across 200, and I've gone up from 5 to 20. So I must have gone up 15. So my gradient is 15 divided by 200. Now, because 5 goes into both of these numbers, I'm going to simplify this fraction to 3 over 40. So my answer is that C, the cost of the gas, is 3 over 40 times n plus 5. Here's one of those types of questions for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. You could write it like this or like this. Here's your final question. This is a different type of question for you. This time you have to use your knowledge of gradients and where lines cross the y-axis to match the correct equation to each of the 3 pictures. Press pause and have a go. When you're ready, press play. If we look at the first picture, we can see that it crosses at a negative number. So I'm looking for a negative number on the end, and that's going to be this one here or this one here. Looking at the gradient, I can see it's positive, so I want a positive value in front of x. That narrows it down to this one here, because this has a negative value in front of x. So this is the equation of the first one. I can see that this one crosses at a positive number, so it could be this one, or this one. It's a straight line, So that rules out the one with the squared in it, and it's got a negative gradient. So it's not this one, it's going to be this one here. So we've got y equals minus 3x plus 5. For this last one, it crosses the y-axis at a positive number. So it could be this one. I've already used that, so it's not that. Or it could be this one. It's a straight line, so that rules out the one with the squared. So this is the only one left. And I'm just going to check the gradient here is a half, and this is a positive gradient, and it could be a half. So the answer is y equals a half x plus 5. Here are the graphs of 3 straight lines and their associated equations. You can see that all of these equations fit with our idea that the equation of a straight line is of the form y equals mx plus c. Remember, in this, m is the gradient. If we look at all of these, we can see that they all have the same gradient, which is 2. Now, if we actually look at the lines, we can see that they're all parallel, and that's because they all have the same gradient. Here's a quick question for you to try now. Which of these 2 lines are parallel? Press pause and have a go. When you're ready, press play. Here's the answer. Lines 2 and 3 are parallel because they both have a gradient of 3. Now in this question, I'm being asked to work out the equation of the line that passes through this point and that's parallel to this line here. Remember, the equation of a line is always y equals mx plus c. Now because it's going to be parallel to this line, I know the gradient is going to be 2. So I can now write y equals 2x plus c. Now to find y and x, I can look here. I've got an x-coordinate of 2 and a y-coordinate of 5, so I can put those into this equation. So remember, the y-coordinate was 5, the x-coordinate was 2, and I still don't know what c is, but now I can solve this to find c. I've got 5 equals 2 times 2, which is 4, plus c. So looking at this now, I can see that c must be 1. So the equation is y equals 2x plus that c, which is 1. So we've got y equals 2x plus 1. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. So remember, the equation of a straight line is y equals mx plus c. It's going to be parallel to this, so m is 3, so we've got y equals 3x plus c. Now y is minus 3, and x is 1. We can solve this to find c. So we've got minus 3 equals 3 plus c, so c must be minus 6. So we have y equals 3x minus 6. This question looks a little different. I want to find the equation of the line which passes through the point B here and that is parallel to the line AC. I know it's going to be y equals mx plus c. Now I need a gradient, so I'm going to have to look at the gradient of this line. To do that, I find the point where it crosses the y-axis, go 1 to the right, and then go up until I meet my line. I've gone up by 4, so the gradient must be 4. So I've got y equals 4x plus c. Now the coordinates of point B are 2, 1. So y is 1 and x is 2. So I've now got 1 equals 8 plus c, and I can work out from this line that c is minus 7. So the equation is going to be y equals 4x minus 7. Here's one of those for you to try now. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you to try. Take care when you're finding the gradient of the line this time. Press pause and have a go. When you're ready, press play. Here's the answer. This question looks slightly different. I'm being asked to find the equation of the line which passes through points A and B. Before I start trying to find this equation, I'm just going to draw the line on. I know that the equation of the line will be in the form y equals mx plus c. Just like before, once I know the gradient of the line, I can put it in here and then use either one of my 2 points to help me find c. The only difficult bit is finding the gradient of the line, because I haven't got a grid here to help me do that. So how do I find the gradient of this line here? We know that the gradient of a line is given by a vertical distance divided by a horizontal distance. Up until now, I've always used a horizontal distance of 1, but because I don't have a grid this time, it's more difficult to do that. So what I'm going to do is use any 2 points. I want to find the vertical distance here. Now this vertical distance will be the difference between the y coordinates. So it will be this one here, which I'm calling y2, minus this one here, which I'm calling y1, and that will be the vertical distance. The horizontal distance works in the same way, but with the x coordinates. So this will be x2 minus x1. So now we have a new formula for our gradient. It's the vertical distance, that's y2 minus y1, divided by the horizontal distance, that's x2 minus x1. This is a really important formula which you'll be using a lot because it allows you to work out the gradient of any line if you know 2 points on that line. So back to our question now, armed with our new formula. Let's say that this one is x1, y1, and this one is x2, y2. Now to find the gradient, I've got y2 minus y1, so that's 1 minus minus 4, divided by x2 minus x1, so that's 6 minus minus 4. So that's 1 plus 4, which is 5, over 6 plus 4, which is 10. And 5 over 10 is actually a half. So I know now that the gradient of this line is a half. So I can put that into here. I've got y equals a half x plus c. Now to find the c, I just need to put in either one of these 2 points into this equation. I'm going to use point B because I don't really want to work with negatives. So on point B, I can see that x is 6 and y is 1. So y is 1, x is 6, and I've still got plus c. But now I can use this to find c. I've got 1 equals 3 plus c. So c must be minus 2. Combining this with this, I've now got the equation of this line. It's y equals a half x minus 2. Here's one for you to try now. Press pause and have a go. When you're ready, press play. So we want to find the equation of the line joining A and B. Let's start by drawing that line. Now we want to find the gradient of it. So remember, the gradient is y2 minus y1 over x2 minus x1. So I'm going to say that this is x1, y1, and this is x2, y2. So y2 is 9, minus y1 is minus 6. x2 is 2, minus x1, which is minus 1. So I have 9 plus 6, which is 15, divided by 2 plus 1, which is 3. so that's 5. So I know now that the gradient is 5. So my equation will be y equals mx plus c, but I know that m is 5. To find c, I can use either of these 2 points, but I'm going to go for this one to avoid the negatives again. So y is 9, x is 2, and we've got plus c. So 9 equals 10 plus c, so c must be minus 1. Now I have the equation, it's y equals 5x minus 1. Just out of interest, one of the most common questions that people ask is which one's x1, y1 and which one's x2, y2. The answer is it doesn't actually matter. If I'd have said that this one was x1, y1 and this was x2, y2, watch what happens with the gradient. I know that it's y2, that's minus 6, minus y1, that's 9, over x2, that's minus 1, minus x1, that's 2. Now minus 6 minus 9 is minus 15, and minus 1 minus 2 is minus 3. It looks like it's coming out different to this, but minus 15 divided by minus 3 is still 5, so we still have the same gradient. So it doesn't matter which one is x1, y1 and which one is x2, y2. Here are 2 more questions for you to try. The only difference this time is that there's no diagram to help you. If you feel that you need one, you can always sketch one yourself. Press pause and have a go. When you're ready, press play. Here are the answers. In this clip, we're going to be looking at roots and turning points of quadratics. Before we do this, we need to remember what a quadratic function or equation actually looks like. These are all examples of quadratic equations or functions. The highest power of x in any of them is x squared. Even in this one, because if we multiply out the brackets, x times x gives us an x squared, so we know that this one is a quadratic as well. Whenever we have a quadratic, we know that it's going to be a curve like this or like this. And in this question, I'm being asked to draw the correct curve under each of these equations or functions. When I've got a positive x squared, like this one here, I know it's going to be this way up. We can think of this as a smile. When we've got a negative x squared, like this one here, it's going to be this way up. And we can think of this one as a frown. So looking at this one here, I can ignore all this bit. The only thing I care about is the x squared. It's positive, so I know it's going to be a smile. Here, I can ignore all of this part and just concentrate on the x squared. It's got a minus in front of it, so I know it's a frown. For this one, it might be tempting to multiply out the bracket completely, but we don't need to do that. We just need to say that x times x is x squared. That's a positive x squared, so this one is a smile as well. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I'm now going to look at an accurately drawn quadratic. So here's an equation, and here's the graph of it drawn accurately. You'll notice from the equation we have a positive x squared, so we were expecting a smile, and that's exactly what we've got here. This point here is really important, and it's got a special name. It's called the turning point of the curve, and that's because you can see at this point the curve changes direction. These 2 points here, where the graph crosses the x-axis, are also important. They're called the roots of this equation, where y equals 0. This is because on the x-axis, y is always equal to 0. Whenever you solve a quadratic equation and find values for x, you're actually finding the roots of the equation. There's one more important point on the curve, and that's here, where the graph cuts across the y-axis, and that's also where x is equal to 0. This is called the y-intercept of the curve, and we can find it by putting x equals 0 into the original equation. So I have 0 squared minus 2 times 0 minus 3. That's 0 as well, so the value of it is just minus 3. And you'll notice that this definitely crosses the y-axis at minus 3. There is a faster way of finding the value of the y-intercept. Obviously, we know that when x is 0, these are going to disappear. So the value of the y-intercept is just going to be the value of the constant here. Now here's a question for you to try. You're being asked to write down the coordinates of the different points. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is a cubic equation because it's got x to the power of 3, which we sometimes call x cubed, in it. The graph of this equation looks like this. You'll notice it goes from bottom left to top right with a wiggle in the middle. Here's another cubic equation. It's a cubic equation because the highest power of x is x cubed. Again, notice the graph goes from bottom left to top right with a wiggle in the middle, but this time the wiggle is more pronounced. We call this point here and this point here a turning point because it's where the graph turns and changes direction. Here's another cubic. You'll notice this time that the graph goes from top left to bottom right, and that's because this one is minus x cubed, whereas before we had x cubed. So with a positive cubic, it goes bottom left to top right, and with a negative cubic, it goes top left to bottom right. And here's another one. Again, notice that the cubed x is negative. So this is a negative cubic going from top left to bottom right with the wiggle in the middle. Again, we've got a turning point here and a turning point here. Now here's an exam-style question where I'm being asked to plot a cubic curve. I need to complete the table for this cubic here. I've already got the values for minus 2, minus 1 and 3, so I just need to fill in these ones. I like to make things easy for myself, so I start with the 0. So I substitute 0 in here. So that's 0 cubed minus 4 times 0, and that will give me 0. Then I do the 1. So that's 1 cubed minus 4 times 1. 1 cubed is 1, 4 times 1 is 4, so that's 1 minus 4, which is minus 3. So that's that value. Then the 2. 2 cubed minus 4 times 2. Now 2 cubed is 8, 4 times 2 is 8, and 8 minus 8 is 0, so that one's 0. Now I've just got the minus 3 to do. This is a bit more difficult, so I put the minus 3 in brackets. So I've got minus 3 cubed minus 4 times minus 3. First of all, I need to work out minus 3 cubed. So that's minus 3 times minus 3 times minus 3. Now minus 3 times minus 3 is 9, times another minus 3 is minus 27. So I've got minus 27 here, and then I've got minus 4 times minus 3, which is plus 12. So minus 27 plus 12 is minus 15. So that's this value here. You'll notice that I worked all of these answers out without using a calculator. But this type of question could be on the calculator paper. If it is, you just need to type this in exactly as it appears here in order to be able to get these answers. Now I'm ready to plot the points on the graph. And that looks like this. To complete the graph, I need to join the points together with a smooth curve. So this is my finished cubic graph. In part C, I'm asked to estimate the x-coordinates of the turning points of the graph. I can see that one of the turning points is here and the other one is here. The x-coordinate of this turning point is -1 and the x-coordinate of this one is 1. Just out of interest, you might be wondering why it says estimate here when it looks very clear from this graph that these are the turning points. Well, the reason for this is because if you drew this graph very accurately, using a computer package, for example, it would actually look like this. And you can see that the turning points are actually here and here. So we get answers of -1.2 and 1.2. Don't worry, in the exam you get lots of leeway on this type of question. So our previous answer would have been perfectly acceptable. Here's one for you to try now. You'll need to get some graph paper and copy the axes onto them. Then the table needs copying out as well. Press pause and have a go. When you're ready, press play. Here's the answer. Again, because of the nature of the hand-drawn graph, this is just one example of an acceptable answer. Drawing your graph a little more accurately gives you this answer here. Both are accepted in the exam and you have lots of leeway. Here's another one for you to try. Again, you'll need to copy out the table and copy the axes onto graph paper. Notice we've got -x cubed this time, so the graph is going to go from top left to bottom right. Press pause and have a go. When you're ready, press play. Here's the answer. Again, this is one version of an acceptable answer. With the graph drawn a little bit more accurately, you get this. Remember, there's plenty of leeway in the exam. Now here's a very strange looking graph. This is called a reciprocal graph and it's the graph of y equals 1 divided by x. One special feature of this graph is that the x-axis and the y-axis are both asymptotes to the curve. What this means is that the curve will get closer and closer to them but never actually touch them. Also notice that the graph is in two sections. To understand what's going on with this graph, let's look at some points. If I choose the point x equals 1, then y equals 1 divided by 1, which is also 1, and you can see that here. Now, if I choose x equals 10, so that would be somewhere along here, y is equal to 1 divided by 10. That's 1/10 or 0.1. So you can see that that's starting to get small. Let's say x is equal to 1,000,000, then y is equal to 1 divided by 1,000,000 or 1/1,000,000th. So that's going to be really small. So you can see that this will get closer and closer to the x-axis as it goes along. Let's look what happens now when x is less than 1. So let's take a value of 1/2. So x equals 1/2. So y is equal to 1 divided by 1/2. And 1 divided by 1/2 is 2. So you can see here we've got the point 2. Let's try an even smaller point. Let's say x is equal to 100th. Then y is equal to 1 divided by 100th, which is 100. So you can see that as we get closer to the y-axis, it's increasing. We can't put x is equal to 0, of course, because there's no answer for 1 divided by 0, and that's why the y-axis is an asymptote. In exactly the same way, if I put negative values of x in, then I get negative values of y that produce this part of the curve. Here's a question for you to try. You can use a calculator for this. You'll need to copy out the table, and you'll need to copy the axes onto some graph paper. Press pause and have a go. When you're ready, press play. Here's the answer. Simultaneous equations questions are very commonplace on exams, and they tend to look something like this, or like this. This particular one is still a simultaneous equations question, but it's given to you in a real-life context. Features to notice are that each time we've got two equations, here and here, or here and here, and we have two unknowns. In the top one we've got x and y, and in the bottom one we've got apples and bananas. We're asked to solve the simultaneous equations. This means we have to find a value for x and a value for y that work in both of these equations. Or, in the second example, a value for the apples and a value for the bananas that works in both equations. What we actually mean by this is if we drew these two lines on a graph, one would look like this and one would look like this, and we're looking for the point where the lines cross over. In this clip, we're going to look how we find this crossover point algebraically. Before we learn how to solve the simultaneous equations, there are three principles that we need to understand. The first principle is that if we add two equations, we'll get an equation that still holds true. Let's have a look with these two number equations. So I'm going to add them together. So I've got 7 plus 2, that's 9. 4 plus 1, that's 5. And 11 plus 3, that's 14. Now I can check it. 9 plus 5 is definitely 14. So you can see that this is still true. In a similar way, we can also subtract two equations and get an equation that still holds true. So here, I get 7 minus 2, that's 5. 4 minus 1, that's 3. And 11 minus 3, that's 8. And I check it. 5 plus 3 is definitely 8, so this is still true. The third principle says that I can multiply the equations by anything I want, and then either add or subtract them, and still get an equation that holds true. So I'm going to multiply the top equation by 2, and I'm going to multiply the bottom equation by 3. So 7 times 2 is 14, 4 times 2 is 8, and 11 times 2 is 22. For this one, I have 2 times 3, that's 6. 1 times 3, that's 3. And 3 times 3, that's 9. Now I'm going to choose to subtract these new equations. So I've got 14 minus 6, that's 8. 8 minus 3, that's 5. And 22 minus 9, that's 13. Now if I check it, 8 plus 5 does give me 13. Now in this particular example, I chose to multiply this one by 2 and this one by 3, but these could be any numbers at all, or I could just multiply one of the equations instead of both of them. Also, I can subtract or add. I chose to subtract here, but I could equally have added them together. So to summarise, we can add equations, we can subtract equations, or we can multiply equations and then either add or subtract. Throughout the rest of this clip, we'll be using these techniques to solve simultaneous equations. So let's have a look at how we apply our principles to this real-life context to find the cost of an apple and the cost of a banana. First of all, I need to set up two simultaneous equations. The first line says 5 apples and 2 bananas cost £16. So I'm going to choose letters to represent the apples and the bananas. I'm going to use A for apples and B for bananas. So I've got 5 apples and 2 bananas, and that costs £16. So there's my first equation. In the same way here, I've got 3 apples and 2 bananas, and that costs £12. So now I've got 2 equations. As soon as I've got my 2 equations set up, I draw a line underneath them, and any working out I'm going to do will go below that line. Now to solve 2 simultaneous equations, what I want to do is eliminate one of the variables. So I either want to get rid of the a's or get rid of the b's. If I look carefully at these, I can see I've got plus 2b here, and the same thing, plus 2b, here as well. So I'm going to use my second principle, subtracting them. First of all, if I do this, the plus 2b minus the plus 2b will disappear. Let me show you. So we've got 5a minus 3a, that's 2a, Plus 2b minus plus 2b is nothing, so I'm going to leave a blank space here. And 16 minus 12 is 4. Now you can see I've reduced my two simultaneous equations to an equation that's really straightforward to solve. If 2a is equal to 4, then I can divide both sides by 2 and get that a is equal to 2. So I now know that an apple is £2. Now I'm going to use the price of the apple to help me calculate the price of the banana. I can do that using either of my two original equations. I'm going to use this bottom one because it looks a little bit easier as it's got smaller numbers in it. So I've got 3 apples plus 2 bananas, and that's equal to £12. But remember, I know that the apples are £2 each, so 3 apples must be £6, so I'm going to put that in. Plus 2 bananas, that's £12. Now I can subtract 6 from both sides to give me 2 bananas equals £6, and I'm nearly there now. I can divide both sides by 2 to get that a banana is £3. So that's the other half of my answer. A banana is £3. I always like to check my two answers by putting them into the equation I didn't use. So that's this one here. That was 5a plus 2b equals 16. So I've got 5 times 2, that's 10, plus 2 times 3, that's 6. And let me check, that does equal 16. So I know that my answers are correct. Here are 2 questions for you to try now. Press pause and have a go. When you're ready, press play. So for the first one, I hope you realise that because we've got plus 3y here and here, we can subtract these equations. I can now solve this to find the value of x. Now I can substitute my value of x into either of these two equations. I'm going to use this one because the numbers are smaller. So I've got 2x, that's 2 4s, so that's 8, plus 3y equals 14. I can now solve this equation to find the value of y. I get y equals 2, so my final answer is x equals 4 and y equals 2. Remember, you can always substitute these two values into this equation to check your answer. You should have done question B in a very similar way. The only real difficulty with this one is that you should have found that x is equal to 2.5, but as long as you're careful with your substitution, y is then 1.5 and everything works out. Now at first glance, this question might look different, but actually when you look more carefully, you realise we've got the same thing here as we have here, minus 3y in both of them. Because these two bits are the same, we can still do this by subtracting the two equations. So I'd like you to have a go at this one now. Press pause and try it. When you're ready, press play. So you should have started by subtracting your equations. 4x minus 2x is 2x. Because these are the same, we get nothing. And then 7 take away 2 is 5. We can now solve this in the normal way to get x equals 2.5. And then use either of these two equations to help us find the value of y. So because x is 2.5, the 2x is 5, so I've got 5 minus 3y equals 2. Now we can solve this to find the value of y. This looks like a really complicated equation to solve, but we can use a bit of common sense to help us. We've got 5 minus something is 2, so the something must be 3. That tells us that 3y is 3. Now we can divide both sides by 3 to get y equals 1. So we have x equals 2.5 and y equals 1. Here's another one of those for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Up till now, when I've looked at my two simultaneous equations, I've seen that I've got the same thing here and here, so I've been able to subtract. This time, however, these two things aren't the same, so subtracting straight away won't get me anywhere. However, Principle 3 said that I could multiply either of the two equations by something and then subtract. So what I'm going to do is multiply this second equation here by 3. That will give me 3y, and then I can subtract. So my first equation is going to stay the same, 5x plus 3y equals 29, and my second equation is going to be multiplied by 3, so that gives me 3x plus 3y equals 7 times 3, which is 21. Now I have the same thing here as I do here, so I can subtract them. 5x minus 3x is 2x. These go, and then 29 minus 21 is 8. I can solve this to give me x equals 4. Now, in my normal way, I can substitute this into either of these two equations to find y. I'm going to choose the bottom one because it looks much easier. So I've got x plus y equals 7. X is 4, so I've got 4 plus y equals 7, and I can solve this to get the value of y, which is 3. So my answers are x equals 4, y equals 3. Now this question takes us to the final stage of difficulty that you'll come across with simultaneous equations. When I look at these two equations, I can see that these aren't the same. I also can't see any whole numbers that I could multiply either this or this by to make these things the same. So what I'm going to have to do is multiply both of them. Now the number 5 and 2 both go into 10, so I'm going to make them, say, 10y. So I'm going to multiply this by 2, and I'm going to multiply this by 5. You might notice that I've actually just swapped the numbers over here. So I get 16x minus 10y equals 42 when I multiply this one by 2, and I get 15x minus 10y equals 40 when I multiply this line by 5. Now I can see I've got minus 10y here and minus 10y here, so I can continue in the normal way. I get x equals 2, and I can now use this to help me find y. I get to here, and now I've got 6 minus something equals 8. Now that seems impossible, but if we think about it, if we take away a negative, that has the same effect as adding, so 2y must be a negative number. And it must be minus 2, because 6 minus minus 2 gives me 8. So, now I can divide both sides by 2 to get y equals minus 1. So the answers are x equals 2 and y equals minus 1. Here are some of those for you to try now. Press pause and have a go. When you're ready, press play. Here are the answers. So far, all the questions that we've done have had either plus plus or minus minus. In other words, the signs have been the same. And to solve them, eventually, we've always subtracted the two equations. So you can remember, same signs, subtract. Now, what do you think we do when we've got different signs? Well, what we actually do is add. We still have to make the numbers here the same though. So I'm going to multiply this one by 3. So the top one stays as it is, 2x plus 3y equals 53. But the bottom one gets multiplied by 3. So I've got 9x minus 3y equals 57. Now I've got a plus 3y and a minus 3y, so I can happily add these equations together and this part will disappear. So I've got 2x plus 9x, that's 11x. This disappears, and then 53 plus 57 is 110. Now I can divide by 11 to get x equals 10. Now I can use either of these two to help me find y. I'm going to use the bottom one. So I've got 3x minus y equals 19. Remember, x is 10, so that's 30 minus y equals 19. So y must be 11 because 30 minus 11 is 19. So my answer is x equals 10, y equals 11. Now here's one for you to try. You've got a plus and a minus, so you know that you're going to have to add them eventually. First of all, though, you need to make these numbers the same by multiplying both equations by something. Press pause and have a go. When you're ready, press play. Here are the answers that you should have got for that one. Here are 2 more of those for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. We're now coming to the end of simultaneous equations, and you should now know 2 rules that you've been using. When you've got different signs or alternate signs, we add. When we've got the same signs, we subtract. So can you now please try these 2 questions? Press pause and have a go. When you're ready, press play. Here are the answers. Now we've just seen how to get the answers for this question, and the techniques that we've looked at so far in this clip work beautifully for this. But being really accomplished at maths is about being really flexible. Sometimes there's a faster way to get to the answer. We can do this by slightly adapting the techniques that we've been looking at. So let's look at the question again. Right at the beginning of the clip, I said we needed to either eliminate x or y, and so far we've always eliminated y. But if we look at the numbers in front of x, we can see that we could get these 2 numbers here the same if we just multiply the top equation by 2. So I'm going to do this. So I'm going to multiply this by 2. So we have 2x times 2, that's 4x, plus 5y times 2, that's plus 10y, equals 16 times 2, that's 32. And this one is staying the same, so that's 4x plus 3y equals 11. So now I've got these the same, I can subtract. So these go this time. I've got 10y minus 3y, that's 7y, and I've got 32 minus 11, that's 21. Dividing by 7 gives me y equals 3. Now I can use this y to find x. I'm going to do it with this one here. So I've got 4x plus 3y equals 11. That's 4x plus 3y, but y is 3, so that's 9, equals 11. So 4x is equal to 2. Dividing by 4 gives me that x is equal to 0.5. So my answers are that x equals 0.5 and y equals 3. And you can see that the answers we got this time matched the answers from before. Now, the reason I've shown you this is because you need to understand that you've always got a choice. You can either get rid of the x's or the y's, and you need to decide which one is easier for you to do. Here's one for you to try now. In this one, I'd like you to try to eliminate the x's this time rather than the y's. Press pause and have a go. When you're ready, press play. Here's the answer. Now here's a question in a real-life context for you. These questions are good because the answers tend to be positive. Remember, you'll need to form your 2 simultaneous equations yourself. Press pause and have a go. When you're ready, press play. Here are the answers for that one. This is an example of a geometric progression. It's called a geometric progression because we can't add the same thing every time to get the next number. Instead, we've got to multiply. And on this particular one, we need to multiply by 2 each time to get the next number in the pattern. 3 is the first term of our geometric progression here, and that's often called a. So the first term, a, equals 3. We call the number that we multiply by each time the common ratio, and in this example, the common ratio is 2. Remember, we had to multiply by 2 to get the next number each time. The common ratio is often called r, so we have that r equals 2. Now I'm going to write the sequence in terms of a and r. So the first term here was just a. To get to the next term, I multiplied by 2, so I multiplied a by r. So the second term is ar. To get to the next term, I multiplied by another 2, so that's another r. So I've got a times r again, and that's r squared. Then to get to the next term, I multiply by another r, so I've got ar cubed, and so on. Now if I want to find the nth term of this, let's have a look what happens. We can see that in each term we've got an a, so in the nth term there's definitely going to be an a. Then in this fourth term here, we've got r to the power of 3. In the third term, we've got r to the power of 2. So the power of r is always 1 less than the term. So in this nth term, it's going to be r to the power of n minus 1. So the nth term of a geometric progression is given by ar to the power of n minus 1, where a is the first term of the progression and r is the common ratio. Here's a typical exam question on geometric progressions. I'm told that the first term is 4 and the common ratio is 5, and I want to write down the first 4 terms of the progression. Now I've got the first one here, that's 4. To find the next one, I multiply by the common ratio, which is 5, so 4 times 5 is 20. Then to get the next one, I multiply by 5 again, that's 100. And to get the fourth one, I multiply by 5 again, and that's 500. So these are the first 4 terms. Now I'm being asked to find the 10th term. I could just keep multiplying by 5, but it's probably faster to use the nth term. Remember, the nth term is ar to the power of n minus 1. Now a is the first term, and I know that's 4. R is the common ratio, I know that's 5. And n is 10, so n minus 1 is 9. Now I can use a calculator to get this answer, and I get 7812500. So this is the 10th term. Here's one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one for you to try. Be really careful with part A this time. You need to make sure you read the question carefully. Press pause and have a go. When you're ready, press play. Here are the answers. In this first question, I was told that the first term was 3 and the third term was 12, so I've got a term missing in the middle. I tried multiplying by 2 to see if this would work, and it did work straight away, so the common ratio is 2. If 2 hadn't worked, I'd have tried 3 and then 4 and so on. Here's a slightly different looking question. I'm told the fourth and the fifth terms of a geometric sequence, and I'm being asked to find the first term of the sequence. Now the first thing I want to do is work out the common ratio. Because the fourth term and the fifth term are next to each other in the sequence, to get the common ratio, I can divide the fifth term by the fourth term. I'm going to use a calculator to do this, and I get 6. Now remember, I want the first term of the sequence. I've got the fourth and the fifth. The fourth is 1728, and the fifth is 10368. And remember, we're multiplying by 6 each time. So to get this one here, I can divide this by 6. So using a calculator, 1728 divided by 6 gives me 288. That's the third term. I can divide this by 6 to get the second term, and that gives me 48. And to get this one, I just do 48 divided by 6 again, and that's 8. So the first term of the sequence is 8. Here's one for you to try. Remember, you can use a calculator to help you. Press pause and have a go. When you're ready, press play. Here's the answer. The main difference in this question is that the numbers are going down as the progression goes on. I'm being asked for the common ratio. I still find it in the same way. I'm going to get this term here, that's 448, and divide it by the term before it, that's 1792. I can use a calculator for this, and I get 0.25. So my common ratio is 0.25. Because it's between 0 and 1, that explains why this is going down. I now want to find the fifth term. The fourth one is here, that's 28. So to get the fifth one, I multiply that by 0.25, and that gives me 7. To get the eighth term, I'm going to use my nth term rule. That's AR to the power of n minus 1. Remember, A is the first term, that's 1792. R is the common ratio, that's 0.25. And n is the number of the term I'm looking for, that's 8, so n minus 1 is 7. Typing this into a calculator gives me 0.109375, and this is the eighth term of the progression. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. I want to work out the answer to this question in my head. Now to do this, I could do 5 times 63 and then times that by 2, but that's quite difficult, and I know that when I'm multiplying, the order I do it in doesn't matter. So what I'm going to do is 5 times 2, that's 10, and then multiply that by 63 to get 630. Doing this makes the question much quicker. Here are 2 for you to try now. Remember to do these in your head without using a calculator or pen or paper. Try and find the quickest way. Press pause and have a go. When you're ready for the answers, press play. For A, we'd do 5 times 2, which is 10, and then multiply that by 27 to get 270. For this one, I'd start with 5 times 5, which is 25, then times that by 4 to get 100. Now I just need to times by 7, and that's 700. We're going to be using this idea that you can do multiplication in any order to help us with the rest of this clip. Now this clip is called Product of 3 Binomials. My 3 binomials are here, here, and here. And product means multiply. You can see that I want to multiply these together. So what I'm really doing is expanding and simplifying this. Remember, we can do it in any order, and we want to try to make it easy for ourselves. If I scan this, I can see that I've got an x minus 5 and an x plus 5. If I multiply these two together, it will give me the difference of 2 squares. So I'm just going to write this in a nicer order. I've got x minus 5, then the x plus 5, and then the 3x plus 2. Now I can multiply here. Remember, this is the difference of 2 squares. So I've got x squared minus 25. And I want to multiply this by the final part, which is 3x plus 2. I do this in the usual way. I get this as my final answer. Now remember, I could have multiplied this bracket by this bracket and then multiplied by x plus 5, and I would have got the same thing. But it makes it much more quick if you can look for something like a difference of 2 squares to speed things up. Looking at this question here, I know that I can multiply these 2 brackets together in the normal way. To get this, which now needs to be multiplied by x. Before I do this, I'm going to simplify this part in the brackets. So I've got x squared plus 7x plus 12, and this needs to be multiplied by x. Now this gives me x cubed plus 7x squared plus 12x. And this is the answer for this one. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For part B, there's no fast way to do it. You might have done it in a different order to me, but you should still end up with the same final answer. Throughout this clip, we're going to be using a calculator, and you're going to need to be able to cube numbers. You'll need to use the cube button on your calculator. Press pause and see if you can find it and answer this question. When you're ready, press play. The answer you should have got is 19.683. Now this is a very common type of exam question. You'll recognise it by the words trial and improvement method. Your final answer will look something like this. You need to do these questions in a certain way because you get most of the marks for the actual working out. I'm going to take you through this now, step by step. So the first thing I do is write out the equation that I've been given. It's x cubed minus 4x equals 23. And I look for any invisible time signs. There's one here in between the 4 and the x, so I pop it in here. Now, reading the question, I'm told that the solution is between 3 and 4. So these will be my first two guesses. So I'm going to start with x equals 3. What I do is replace the x in this part of the equation with a 3. So I've got 3 cubed minus 4 times 3. I type this into my calculator exactly as it appears here, and I get the answer 15. Now I'm looking for 23, so 15 is too small. Now I know that in the rest of my working, I'm going to have lots of guesses, lots of working, and lots of too smalls and too bigs. So what I'm going to do is just put some lines down here to keep everything neat and tidy. So my next guess is 4. I replace the x's with 4's, so I've got 4 cubed minus 4 times 4. I get 48. I'm looking for 23, so 48 is too big. Because this answer was too small and this one was too big, I know that I've now trapped the value of x between two consecutive whole numbers. What I want to do next is trap the value of x between two consecutive decimal numbers, like 3.1 and 3.2, or 3.7 and 3.8. To do this, I want my next guess to be a really good one. I look at these two numbers here. I can see that 15 is closer to 23 than 48 is. So I want a value of x that's closer to 3 than it is to 4 for my next guess. The better your guess, the less working out you end up having to do. I'm going to go for 3.2. So I have 3.2 cubed minus 4 times 3.2. And this gives me 19.968. I'm looking for 23, remember, so this is too small. Now it's always best to just change by 0.1 at a time. So the next number I'm going to try is 3.3. So I have 3.3 cubed minus 4 times 3.3. Typing this into the calculator gives me 22.737. This is still too small. I'm going to try x equals 3.4 now then. So 3.4 cubed minus 4 times 3.4 gives me 25.704. This is too big. So this one was too small and this one was too big. So I've trapped it in between two consecutive decimal numbers. Now the question is only asking me to give my answer correct to one decimal place. So my answer is either going to be 3.3 or 3.4. I need to check which one it's going to be. I do this by trying the number exactly in the middle of these two. So that's 3.35. 3.35 cubed minus 4 times 3.35 gives me 24.195375. And this is too big. Now I'm going to use these last three answers and a number line to help me decide on my final solution. So I tried 3.3 and it gave me an answer that was too small. I tried 3.4 and it gave me an answer that was too big. So then I tried exactly in the middle of those two, 3.35, and that also gave me an answer that was too big. So I know that the answer must be somewhere in this section of the number line. In other words, it's closer to 3.3 than it is to 3.4. So my final answer is that x equals 3.3 to 1 decimal place. So to summarise, we trap it between two consecutive whole numbers. These are usually given to you in the question. We then trap it between two consecutive decimal numbers. We try the middle number between the two consecutive decimals, and then we find our final answer, and you can use a number line to help you if you want to. Here's one for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's my answer. You might have more lines of working out than this, because my first guess was very good, so I trapped it in between two consecutive decimals quite quickly. It doesn't matter if you've got extra lines. On an exam, these questions are worth 4 marks. You get 1 mark for your answer as long as you've shown some working. You get 1 mark for this line here, so it's really important to not forget it. And you get the other 2 marks for these lines of working up here. The number line is optional and just helps you find your final answer. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Your working out might look slightly different to this. Notice that my first guess was too big, so I've had to go down by 0.1 each time in order to trap it between two consecutive decimals. Remember, you get marks for this line here, so don't forget it, and for writing your conclusion, so please don't forget that either. Here's another one for you to try. This time the question doesn't help you to trap it between two consecutive whole numbers, so you need to do this bit yourself. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Notice that I started with x equals 4, which was far too small, so I simply went up in consecutive whole numbers until I trapped it. Then I carried on as normal. Here's your final question to try. Press pause and have a go. When you're ready, press play. Here's the answer. Some of you might have actually tackled this question in a slightly different way. You might have rearranged the equation first so that it's equal to 100. Your working out will look like this, but you still get exactly the same answer. In this clip, we're going to be looking at iterative processes. An iterative method is one where the previous answer is fed back into the formula to produce the next result. It sounds a bit complicated, but let me show you what it means. You might be given something like this: un plus 1 equals un plus 5. I can use this to generate a number sequence. All this means is that to find the next term, I get the term before it and add 5 to it. When you're given a question like this, you'll be given U1 usually. Let's say that's 3 for this one. So to get the next one, which would be U2, I put 3 into here, so I've got 3 plus 5, and that's 8. To get the next one, which would be U3, I put 8 into here, so I've got 8 plus 5, which is 13, and so on. Questions in the exam will be a lot more difficult than this, but you'll be expected to use a calculator to help you with them. The right kind of calculator is really important. You need to make sure that you've got one with a button that says Ants on it. This is the Answer button, and you'll be using it all the way through this clip. So here's a typical exam question now, and you can see what I mean about it being a bit harder. We're going to do it in the same way though. I'm told that U1 is equal to 4. I've got to find U2, U3 and U4. So for U2, that's the next one. I put the 4 into here. So I've got 4 squared minus 5 times 4 plus 2. I can use a calculator to work this out, and I get minus 2. Now the next one is U3. I do exactly the same thing, but with minus 2. So I've got minus 2 squared minus 5 times minus 2 plus 2. Again, using a calculator, I get 16. And for U4, I do the same thing, but with 16. So I've got 16 squared minus 5 times 16 plus 2. And this time, I get 178. Here's one for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now, you might be thinking that at the start of this clip, I told you about the answer button on your calculator, and you haven't actually used it yet. Well, I've got a bit of a treat for you now. We're going to do this question again, but in a much faster way, using that answer button on our calculator. Now, to do this quickly, the first thing we need to do is set up in our calculator that U1 is equal to 2. To do this, what you do is type in 2 and then press equals. That stores 2 as the answer on your calculator. From this point onwards, you're going to use the answer button. So now for U2, we have the answer squared minus 7 times the answer, and you don't even need the times sign, plus 4. If you type this into your calculator using the answer button, and then press equals, you'll get negative 6. Now here's the good bit. For U3, instead of typing everything again, just press equals again, and you'll find that you get 82. And for U4, don't type everything, just press equals again, and you'll get 6,154. So whenever you have a question like this, yes, of course you can do it this way, but if you've got an answer button on your calculator and you know how to use it, you can do it much faster. Here are 2 for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I hope you spotted that on B, you were asked for U100. Now, you're not expected to keep doing this 100 times. You should notice that it goes 2, 5, 2, 5, 2. Whenever this is an even number, it's 5, so U100 is going to be 5. Here's another question for you. Be careful on this one. When you type it into your calculator, you need to put brackets here and here. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now this looks like a really difficult question. I've got to solve this to 1 decimal place. But this setup up here tells me that I'm going to use an iterative process to do this. And if I use my clever method using the answer button on my calculator, I can get the answer quite quickly. So first of all, I've got to set up that x1 is equal to 1. Remember, to do this, I press 1 equals on my calculator. Now I'm going to find x2. That's 5 plus 2 over the answer to the previous bit, so that's the answer button, squared. When I press equals, I get 7. To find x3, all I need to do is press the equals button again. This time I get this. Now what I'm looking for is for the answer to come out as the same number over and over again to 1 decimal place. These two numbers don't match yet, so I'm going to go for x4, and I press equals again. I get this. This looks more promising. These two are quite similar, but if I round them to 1 decimal place, this top one is 5.0 and this one is 5.1, so I'm going to go again. This time I get this. If I check these two now to 1 decimal place, they're both 5.1, so that's going to be my answer. So x equals 5.1. Here's one of those for you to try now. Press pause and have a go. When you're ready, press play. Here's the answer. In this clip, we're going to be looking at rearranging difficult formulae. In both of these questions here, I'm being asked to make x the subject, and we can see that x appears just once in each of the formulae. This means that I could rearrange them using a flowchart if I wanted to. But in this clip, we're going to be looking at some really difficult ones where a flowchart won't work. So I'm going to introduce to you another way of doing it, and I'm going to show you that using these two here. So I want to make x the subject of this formula here. I can see that I want to get the x on its own, and at the moment it's part of this x over r. So the first thing I want to get rid of is this plus 2y. To do that, I'm going to subtract 2y from both sides. I get w minus 2y equals x over r. Now to get the x on its own, I want to multiply by r, and I do this to both sides. To multiply this by r, I put it all in brackets and put the r in front of it. Multiplying this by r just gives me x, and x is now the subject of the formula. Now I would get full marks in the exam for this, but it's nicer to write it as x equals r w minus 2y and put the thing that you're making the subject at the start. Now for this one here, one way to do it is to notice that the x is trapped inside this bracket. So the first thing we're going to do is multiply out the bracket, and we're going to multiply it by 3. So we get w equals 3x plus 6y minus 5. Now I want to get the x on its own, so I'm going to move the plus 6y and the minus 5. I'm going to subtract 6y from both sides and add 5 to both sides. So I get w minus 6y, add 5, equals 3x. Now there's one more thing to do to get the x on its own, and that's to divide by 3. I want to divide all of this by 3, and I do that by writing all of it over 3. This gives me x. Again, I prefer to write this the other way round. X equals w minus 6y plus 5 over 3. Here are two for you to try. Press pause and have a go at them. When you're ready for the answers, press play. here are the answers. Just out of interest, if for part B you had this answer instead, it's actually still correct. I hope you can see that this is equivalent to this. They've both got a y, a plus t, and a minus 4 divided by 8. This will be the same case throughout this clip. There will often be slight variations in the answers. Now for the rest of this clip, we're going to be looking at much more difficult questions, where the letter that you're trying to make the subject, in this case x, appears more than once. Here you can see it appears twice, and here it actually appears 3 times. Because it appears multiple times, we're not able to use a flowchart to solve these, even if we wanted to. This is one common type of question on exam papers, and it looks like this, where it's all in a straight line. This is the other common type that will often appear on exam papers, where we have something divided by something. Let's have a look at this type of question first of all. So in this question, I want to make x the subject, and x actually appears twice. First of all, I spot that x on this side is trapped within a bracket, so the first thing I'm going to do is multiply this bracket out. I get 2y plus 2x equals 5x plus 7. Now it's x that I'm trying to get on its own, so I'm going to get all the terms with x in on one side of the equal sign and all the other terms on the other side. Which side do I choose to put my x's on? Well, looking here, I can see I've got 5 x's over here and only 2 x's here, so I'm going to put the x's on this side where there's more of them. So what I'm going to do now is subtract 2x from both sides. So I have 2y equals 5x plus 7 minus 2x. Now remember, I was trying to get all the terms with x on one side, which I have done, but all the other terms on the other side, and I've still got this plus 7 over here. So I'm going to now take away 7 from both sides. So I get 2y minus 7 equals 5x minus 2x. When you get more practiced at this type of equation, you can miss out this middle step here and just go straight from this to this. Now I can simplify this line. I've got 2y minus 7 equals 5x minus 2x, which is 3x. Now you can see I've almost got x the subject of the formula. The only thing I need to do now is divide both sides by 3. So I've got 2y minus 7 over 3 equals x, and as normal I prefer to write this as x equals 2y minus 7 over 3. Now let's look at a second example. I want to make x the subject of this formula. I can see on this side that the x is trapped in a bracket, so the first thing I want to do is multiply this bracket out. So I get ax minus ab equals xa squared plus bx. Now I want to get all the terms with x in on one side of the equal sign and all the terms that don't have x in on the other side. I can see that I've already got 2 terms with x in on this side, so I'm going to get all the x's over here. To do that, I subtract ax from both sides. So I've got minus ab equals xa squared plus bx minus ax. Now I'm at the same stage as I was here. I've got all the x's on one side of the equal sign. In this question, the next step was straightforward. Because I had 5x minus 2x, I could simplify it to 3x. It's not so straightforward over here because I don't actually have any numbers, so I can't simplify it. Instead, what I'm going to do is factorize this, and I'm going to take out a factor of x. So to do that, this will stay as it is, minus ab. And then on this side, I'm going to take out a factor of x. So I have a squared plus b minus a. Now to get the x on its own, all I need to do now is divide by this bracket. So I've got minus ab over a squared plus b minus a, and you'll see now I haven't bothered to put it in the bracket, and that's equal to x. To finish off, I always like to write it x equals, and we've got minus ab over a squared plus b minus a. Just out of interest, to avoid getting this minus ab at this stage here, a lot of mathematicians would have chosen to take all the terms with x in to the left rather than to the right. If you do that, then the answer you get is x equals ab over a minus a squared minus b. Again, these two answers are actually equivalent. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Now this question looks really different, but there's actually only one extra step. First of all, I can see that this has been divided by 2 plus x. So I'm going to multiply both sides by 2 plus x. To do that, I have p and then brackets 2 plus x equals 5 minus 3x. Once you get to this stage, it's exactly the same as the questions that we've just been doing. Examiners say that students have real difficulty doing these questions, and it's all down to lack of practice. So what I'd like you to do now is to carry on rearranging this to make x the subject of the formula. Press pause and have a go. When you're ready, press play. Here's the answer. Here are some more for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. This is a typical exam-style question where I want to solve this quadratic equation. You can do this using routine algebra. The interesting thing about this kind of question, though, is that when examiners come to mark it, they often find that it's quite poorly done. In this clip, I'm going to show you a step-by-step approach to this kind of question, which will make it more accessible. This is what the question would look like on an exam paper. It's a quadratic equation, so we know that we're going to get two answers. Because it says give your answer to 2 decimal places, that tells us that we're not going to be able to factorize this. Instead, we're going to have to use the quadratic equation formula, which looks like this. In the formula, you'll notice that along with our x, we've got the letters A, B, and C. I'm going to show you what these stand for first of all. A appears twice, and it's the number in front of x squared in the equation. We call it the coefficient of x squared. In this particular one, A is 6. B appears twice as well, and B is the number in front of the x. Be careful to include the sign as well. So in this case, B is positive 5. C only appears once, and C is this number here. We often call it the constant. Again, remember to include the sign, so in this case, C is negative 2. In our formula, the key to the whole question is this part here. This bit is so important that it's even got its own name. It's called the discriminant. And if you go on to study A-level maths, you'll look into this in much more detail. Because this bit is absolutely crucial, it's going to be the first part that I do in my working. So now we're back to our question as it would appear on the exam. The first step to solving it is to write down what A, B and C are. So A is 6, B is 5, and in this case it's positive 5, so I can just write 5. And C is negative 2, so I've got to make sure I write minus 2, and I put this in brackets. Now I'm ready to work out the really important part of the equation. That's b squared minus 4ac. Now I need to substitute in the values for a, b and c. So I start with b, that's 5, and it's squared. So we've got 5 squared, minus 4 times a, which is 6, times c, which is minus 2. I can work this out using a calculator, and I get 73. So I now know that this part here is 73. I'm going to substitute b and a into the rest of the equation now. So I've got x equals minus b, that's going to be minus 5, plus or minus the square root of this, which is 73, divided by 2 lots of a. A is 6, so that will be 12. Now, as you know, we're looking for 2 answers for our quadratic, and we get them from this bit here. We need to do this once with a plus and once with a minus. So my first answer is given by x equals minus 5 plus the square root of 73 divided by 12. And my second answer is given by x equals minus 5 minus the square root of 73 divided by 12. We can get the answers by typing this and this into our calculator. When you type this in, you need to put brackets here and here. Typing this in gives me 0.30 rounded to 2 decimal places, and typing this in gives me minus 1.13 rounded to 2 decimal places. These are my 2 answers to my quadratic equation. So to summarise, we use 4 steps when answering this type of question. Step 1 is to write out what a, b and c are. Step 2 is to work out the value of b squared minus 4ac using substitution. In step 3, we can now write this in a nicer way using our answer from step 2, like this. In step 4, we get our 2 answers using the plus part here and the minus part here and typing them into a calculator. Here's a question for you to try now, but we're going to break it down into the 4 steps. So first of all, I'd like you to do step 1. That's writing down what A, B and C are. Press pause and have a go. When you're ready to carry on, press play. So you should have got that A is equal to 3, B is equal to, now here we've got plus x, that must be plus 1x, so B is equal to 1, and C is equal to minus 7. Remember, when you've got a negative number, put it in brackets. Now I'd like you to do step 2. That's to work out the value of b squared minus 4ac. Press pause and have a go. When you're ready, press play. So you should have written b squared minus 4ac. Substituted in the value for b, that's 1, so 1 squared, minus 4 times a, that's 3, times c, that's minus 7. Now you can use your calculator to get the answer for this part, which is 85. Make sure when you do this step you do actually write this out and show you're working. This is all part of the question and it will get you marks. Now I'm going to ask you to do step 3. Remember, step 3 is rewriting this using this number to help you. Press pause and have a go. When you're ready, press play. So you should have that x equals minus b, which is minus 1, plus or minus the square root of this part here, which is 85, divided by 2a, so that's 6. Finally, I'm going to ask you to do step 4. This is to split this up, once with a plus and once with a minus, to get 2 answers, and use your calculator to work them out. Press pause and have a go. When you're ready, press play. So you should have written this once just using the plus, -1 plus root 85 over 6, and remember to put the top in brackets, and then you should have written it again using the minus. You should have then put this into the calculator, and you get 1.37 to 3 significant figures, and -1.70 to 3 significant figures. If you've got these two answers, then you've correctly answered this question. Here's another one for you to try without me taking you through all the steps this time. Press pause and have a go. When you've got your final answers, press play. Here are the answers. Now this question has got one slight little complication in it, but the steps are still the same. So in step 1, we write down A, B and C. I get these values, and you can see that B is a negative. This is the complication. I'll show you what I mean as I go through. Then I do step 2, which is to work out B squared minus 4AC. The answer for this is 89. To get this right, you need to type this into your calculator exactly as it appears here. Notice that the -5 is in brackets and that the squared is outside of the bracket. In step 3, I need to use this to rewrite this in a nicer way. So I've got x equals minus b. That's minus this, so I've got -5. Plus or minus the square root of 89 divided by 2 lots of a, that will be 4. Now here's another complication. We've got -5, but we take this in our stride. We know that that's actually plus, so we've got 5 plus or minus the square root of 89 divided by 4. I complete step 4 in my usual way by writing this out once with a plus, once with a minus, and then using a calculator to get the answers. These are the 2 final answers for the question. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now, the bad news is that in a real exam situation, you won't be given this formula. You've got to memorise this yourself. When you do a question, that means you've got a new first step, which is to actually write down the formula before you begin and then proceed in the usual way. In the next few questions, this formula won't appear on screen. So here are 2 more questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Practice makes perfect, so here are another 2 for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. This clip is about factorising difficult quadratics. By difficult, what I mean is that the coefficient of x squared is greater than 1. The first step is to get the coefficient of x squared and multiply it by the constant. So we've got 6 times 20, and that gives us 120. We want to find 2 numbers that multiply to make this. The 2 numbers have also got to add up to make -23, so I'm going to put that over here as well. So to make 120, I could have 1 times 120, but that definitely won't make -23. I could have 2 times 60, that won't work either. 3 times 40, that won't work. 4 times 30, that won't work. 5 times 24, that won't work, but you can see that we're getting closer. 6 times 20, that won't work. 8 times 15, that will work. I can get 23 from those 2 numbers if they're both negative. So now I'm going to split this -23x up into minus 8x and minus 15x. I've still got the plus 20 on the end, and I've still got the 6x squared at the start. Now I need to factorise these two terms and factorise these two terms. So looking here, I can see that I can take out a factor of 2x. That leaves me with 3x minus 4. Looking here, I can see that I can take out a factor of minus 5, and that leaves me with 3x minus 4. Notice that I get the same bracket here as I get here. This is actually the first bracket of my factorisation of this quadratic, so that's 3x minus 4. The second bracket contains this and this, so we've got 2x minus 5. So this quadratic factorised is this. So to review this step-by-step method, the first step is to multiply this and this together and put that here, and then to also put this number here as well. Now we're looking for two numbers that multiply to make 120 and add or subtract to make minus 23. The second step is to start listing my pairs of numbers. I always start with 1 and something and then work my way down, eliminating as I go until I find a pair that with any combination of adds and minuses will make this number here. Minus 8 and minus 15 will make minus 23. The third step is to split this up into those two numbers. What we've done here is rewritten this as something with 4 terms so that we can factorise these two and factorise these two, and we then get this line. The next thing to do is to check that this bracket actually matches this one here. That's a good step to tell you that you're in the right direction. Once you've got this, this is your first bracket of your fully factorised form, and then this part and this part go together to make the second bracket. Once you've done this, you've completed your factorisation. Once you've got your factorisation, you can check it by expanding these two brackets, and you should get back to here. I'm now going to do this question with you to remind you of the steps. So we start with 8 times minus 3, and that's minus 24. I want to find two numbers that multiply to give this. I also want those two numbers to make minus 5. So I'm trying to make minus 24 by multiplying. I'm just going to focus on the 24 for now. So I could have 1 and 24, but that definitely won't give me minus 5. 2 and 12 won't give me minus 5 either. 3 and 8 could give me minus 5 if this was a plus 3 and this was a minus 8. Let me just check. Plus 3 times minus 8 does give me minus 24, so this is the pair I'm going to use. So I split this minus 5x into plus 3x and minus 8x. The minus 3 goes on the end, and the 8x squared still goes at the front. Then I want to factorise these two terms and these two terms. Looking at this one, I can see that the only thing I can take out of these two terms is an x. So I take out the x and get 8x plus 3. Looking at this one, it's more difficult, but I can see that they're both minus, so I must be able to take out a factor of minus something. Because this is an 8 and a 3, and only 1 goes into both those numbers, the number I'm going to take out must be minus 1. I then get 8x, and I get a plus 3, because minus 1 times plus 3 makes minus 3. A nice way to check is that this matches this, and that always tells you that you're on the right track. So this is the first bracket that I'm going to write down for my factorisation, 8x plus 3. And the second bracket is x minus 1. This is the finished factorisation of this quadratic. Here's one for you to try now. Press pause and have a go at it. When you're ready, press play. Here's the answer. Here are some more questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Just out of interest, when you're dealing with large numbers like this, you can get a lot of these pairs for free. Once you've got 2 and 84, you can double the 2 and halve the 84. That gives you the line for 4. Once you've got 3 and 56, you can double the 3 and halve the 56 to give you the 6 and the 28. Similarly, once I'd got the 4 and the 42, I could get this line by doubling the 4 and halving the 42. We're now going to look at solving quadratic equations using a method of factorization. So to start with, we factorize this in our usual way. Once I've factorized it, I then know that either this bracket is equal to 0 or this bracket is equal to 0, because when they're multiplied together, they equal 0. So I've got 7x minus 2 equals 0, or 3x plus 1 equals 0. I can now solve these two linear equations to find my two values of x. So adding 2 to both sides here gives me 7x equals 2, and then dividing by 7 gives me x equals 2/7. Here, subtracting 1 from both sides gives me 3x equals minus 1, and then dividing by 3 gives me x equals minus 1 over 3. These are my two values for x that are the solutions of this quadratic equation. Here's one of those for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more questions for you to try now. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. I'm being asked to show that the sum of two odd numbers is always an even number. Now it's quite tempting to pick two odd numbers, for example, let's say 3 and 5, and show that they add up to make an even number, 8. But this only shows that it's true for these two particular odd numbers. I want to show that this is always true, so I'm going to do this algebraically. We can write any number as n. To make this an even number, it must be a multiple of 2, so it will be 2n. So this is now an even number. To make it an odd number, we would add 1 onto it. So any odd number is 2n add 1. Now I want the sum of two different odd numbers, so I'm going to do the same thing but with a different letter. So m is any number, 2m is an even number, 2m add 1 is now an odd number. I want to show that the sum of these is even, so let's add them up and see what happens. I get 2n plus 2m plus 1 plus another 1. So that's 2n plus 2m plus 2. Now I want to show that this number here is definitely even. And the way I do that is by taking out a factor of 2. So if I take a factor of 2, I'm left with n plus m plus 1. Now because this number here is a multiple of 2, then it must be even. So I've shown that the sum of two odd numbers, here and here, is definitely even. So I write my concluding statement, 2n plus m plus 1 is a multiple of 2, therefore it is always even. This working out and this statement is my final answer. Here's one for you to try now. Press pause and have a go. When you're ready, press play. So to answer this, my first even number is going to be 2n, and my second even number is 2m. I want the sum of these, so I add them together. That gives me 2n plus m if I factorise. Now I know that this is always even because it's a multiple of 2, so I write that as my final statement. So this whole thing is the final answer. Now in this question, I'm asked to show that the difference of the squares of two odd numbers is always even. So I need my two odd numbers again. So my first odd number was 2n plus 1, and my second odd number was 2m plus 1. Now I need the difference, that means take away, of the squares. So each of these needs to be squared. And I want to prove that this is always even. So first of all, I'm going to multiply out this bracket. So I've got 2n plus 1 squared means I need to multiply it by itself. So that gives me 4n squared plus 4n plus 1. I also need to multiply out this bracket. So that's 2m plus 1 squared, so that's multiplied by itself. And that gives me 4m squared plus 4m plus 1. So I now have all of this. That's 4n squared plus 4n plus 1. Take away all of this. That's 4m squared plus 4m plus 1. So I've got 4n squared plus 4n plus 1, and everything inside this bracket gets multiplied by minus 1. So I've got minus 4m squared minus 4m minus 1. Now simplifying this gives me 4n squared plus 4n minus 4m squared minus 4m, because plus 1 and minus 1 goes. Now I want to prove that this is always even. To do that, I factorise and I take out a factor of 2. So if I take out a factor of 2, I get 2n squared plus 2n minus 2m squared minus 2m. This must be even because it's a multiple of 2. So this is my concluding statement. All of this makes up my final proof. Here's one for you to try now. Press pause and have a go. When you're ready, press play. Here's the algebraic proof for that one. I'm now being asked to show that the sum of two consecutive odd numbers is always a multiple of 4. Before we do this, we need to understand what consecutive means. So to give you an example, 23, 24, 25, 26 and 27 are consecutive numbers. It means numbers that come one after the other. Consecutive odd numbers would be 23, 25 and 27. You can see that to get from one odd number to the next odd number, we add on 2, and these two odd numbers are consecutive. So I'm going to start with an odd number. Remember, that's 2n plus 1. To get the next odd number, I add on 2, so that's 2n plus 1 plus 2, which is plus 3. I want the sum of these, so I'm going to add them together. So adding and simplifying, I get 2n plus 2n, so that's 4n, plus 1 plus 3, so that's plus 4. I want to show that this is a multiple of 4, and I can do that by taking out a factor of 4. So if I factorise, I get 4n plus 1. Now this number must be a multiple of 4, so I've proved what I've been asked to show. So this is my concluding statement, and I've now finished my proof. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's what the finished proof looks like. Here's another one for you to try. Press pause and have a go. When you're ready, press play. This is what your proof should look like. I've squared this bracket here and squared this one here. I've then subtracted those, which gives me this, which simplifies to 24n. Now the important step is that you can take a factor of 8 out to give you 8 times 3n. And because you can take out a factor of 8, we know that this is a multiple of 8. Here's another question for you to try. This time you're trying to prove that the sum of the squares of any two consecutive odd numbers cannot be a multiple of 4. Press pause and have a go. When you're ready, press play. So here's the beginning of the proof. I've got my two consecutive odd numbers, I've squared them, and I've found the sum by adding them. I get this, which simplifies to this. Now, if this is a multiple of 4, then I can take out a factor of 4. It works with the 8 and it works with the 16, but 4 isn't a factor of 10. So this number cannot be a multiple of 4. I write a concluding statement to explain this, and this completes my proof. In this clip, we're going to be looking at exponential functions. You might hear the word exponential or exponentially used in everyday life. Here are 3 examples of sentences using the word exponentially. It actually means getting bigger increasingly quickly, and this is what people mean when they use it in real life. Here are 3 examples of mathematical exponential functions and their associated graphs. You'll notice that in each one, the variable x is the power or the index, and the graphs all look similar. They get bigger increasingly quickly. Let's have a look at this graph now and look at this point here. This is the point where x is equal to 0. If I put that into the equation, I get y equals 2 to the power of 0. Now, any number to the power of 0 is 1. So that tells me that it must cross the y-axis at the number 1. Let's look at this one in the same way. Again, x is equal to 0. So I've got y equals 5 to the power of 0, and that's going to be 1 as well. So this crosses the y-axis at 1. In the same way, this one will cross the y-axis at 1 as well. This is a really important feature of this type of exponential graph. Just out of interest, if this number here is less than 1, then the graphs will look like this. Once again, on these graphs, the value here will be 1. So to summarise exponential functions, they generally look something like this, where the variable is in the power. The graph of an exponential function will look something like this, where it cuts the y-axis at 1. Another characteristic of these types of graphs is that they get bigger increasingly quickly, like this. Finally, as long as the function looks like this, the graph will never go below the x-axis. It will get closer and closer to it, like you can see here, but it will never actually meet or cross the x-axis. We say that the x-axis is an asymptote. This means that the curve will get closer and closer to it, but will never touch it or cross it. Here's a question for you to try. Press pause and have a go. When you're ready for the answers, press play. I'm hoping that you decided that graphs B and F were the graphs of exponential functions. Here's another question for you to try. If you find part B difficult, don't worry too much because I'm going to go through that with you afterwards. Press pause and have a go. When you're ready, press play. For part A, we want to find the coordinates of the point where the graph intersects the y-axis. That's here. Now we know that this is going to be 1 and it's at an x value of 0. So the point is 0, 1. Now for part B, I want to find the value of a. Remember, the function is y equals a to the power of x. Now, if I can find nice values for y and x, I'll be able to work out what a is. Where on earth can I get nice values for y and x from? Well, I can get them from the graph. I'm going to use this point here. X is 1, which is a nice value, and I can see that y here is 3. So I've got 3 equals a to the power of 1. This tells me that a must be 3. Now I can check this by using another point on the graph. Let's use the point where x is 2. So x is 2 and y is 9. So I've got 9 equals, I think 3, remember, to the power of 2. Does this work? Yes, it does. So we're correct. The value of A is 3. In this more difficult question, I'm given the equation of a graph and I'm also given the graph. And I'm being asked to find what P and Q are. The first thing I notice when I look at my graph is that it's not crossing the y-axis at the number 1, because that would be here. And that's because the equation is not q to the power of x, it's p times q to the power of x. Let's look at this in a numerical context. So I've got y equals p q to the power of x. At this point here, x is 0. So that's p times q to the power of 0. Now I know that q to the power of 0 is 1, so that's p times 1, which is just p. Now from the graph, I can see that at this point here, y is actually a half. So I can replace the y with a half, and I get that p is equal to a half. Now I need to work out what q is. To find q, I'm going to use this point on the graph to help me. So I've got y equals p, which I already know, that's a half, times q to the power of x. At this point, x is 1, so I've got y equals a half times q to the power of 1. Now q to the power of 1 is just q, so I've got a half of q. If I can work out what y is, I'll be able to work out what q is, and I can find y from the graph. Looking across, I can see that y is 2. So 2 is a half of q. That tells me that q must be 4. I've now got the values of p and q, but before I finish, I want to check them. And I'm going to check them using one more point on the graph, this one here. Now, using the two values I found for p and q, I think that the equation of the graph is y equals a half for the p times 4 for the q to the power of x. At this point here, x is 2 and y is 8. So I'm going to substitute these into here and see if it works. So I've got 8 equals a half times 4 to the power of 2. Now 4 squared is 16 and a half times 16 is definitely 8. So this is correct. So my value of p is a half and my value of q is 4. Here's one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now this is a typical exam question where they haven't given me a graph. I'm told the size of an animal population on an island increases exponentially. I'm also told the rate of increase, that's 25% per year. I'm told that at the start of 2015, the population was 4,500, and I want to find out the size of the population at the start of 2010. To help me with this, I'm going to draw a timeline. So I want to know the population at the start of 2010. I know the population at the start of 2015 is 4,500. I'm going to call the population that I'm looking for P. Now I know that it increases by 25% per year. So from 2010 to 2011, the population will multiply by 1.25. The same thing will happen here and for every year. Using this, I can now create an equation. I have P times 1.25 to the power of 1, 2, 3, 4, 5 equals 4,500. This is where the exponential part comes in. You can see we've got a power here. I want to find P. So to do that, I'm going to do 4,500 divided by 1.25 to the power of 5. I can use a calculator for this, and I get an answer of 1,475 rounded to the nearest whole number. So the size of the population at the start of 2010 was 1,475 animals. Here's a similar question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. The key to getting this one correct is to realise that because the price of the car is falling by 35% every year, we need to multiply by 0.65. This is because if we start with a price of 100% and take away 35%, we've got 65% of our original price left. This clip is about sketching the graphs of sine, cosine and tangent. We already know from basic trigonometry that sine x is given by the opposite over the hypotenuse. So in this triangle here, that will be this height, which is opposite the angle, divided by this, which is the hypotenuse. You'll notice that I've drawn this circle with a radius of 1, so that when I do my opposite divided by my hypotenuse, I've actually got O divided by 1. And anything divided by 1 is just the number itself. So for this particular triangle here, sine x will just be the length of the opposite side. In a similar way, from basic trigonometry, we know that cos x is A, that's this side here, divided by the hypotenuse h. Again, remember that's 1. So, for this particular triangle, A divided by h is just going to be A, the length of this side here. So to help us understand how to draw the graphs of sine and cosine, we're going to be using the idea of drawing triangles within this circle with a radius of 1, which we call the unit circle. When creating my angles, I always start from this line here and work in an anti-clockwise direction. So if I create an angle here, like this, and I call that angle x, then sin x is equal to this distance here. And in the same way, cos x is equal to this distance here. So we have sin x and cos x. To draw the graphs of sin x and cos x, we're going to look at what happens to these distances as we increase x from 0 degrees through to 360 degrees within this circle. So here's my circle, and at the moment my angle of x is 0 degrees. So the height here, which is sin x, is also 0, and you can see that here. Now let's increase that angle. I've now increased x to 30 degrees, and you can see that sin x is this height here, which is actually 0.5, and I've plotted that on the graph at 30 degrees. Now x has increased to 60 degrees. In the same way, we get the height here, which is actually 0.866, and we plot it on the graph at 60 degrees. When x is 90, we can see that sin x is this distance here, which reaches the edge of the circle. Remember, the circle's got a radius of 1, so that makes it 1. And again, we plot this on the graph. Now, what's going to happen to the height as I take the angle past 90, let's say into 120, and how will this affect the graph? So if we set that angle to 120, we can see that the height actually goes down to this height here. So the maximum height it will ever be is the radius of the circle 1. So this here is the maximum of the graph. Now this height here, you will actually notice, is the same as this height here. This is what we had for 60. So the value of sin x for 120 is the same as it is for 60, and it gives us symmetry in our graph. When we go to 150 degrees, the height gets even smaller again. It's the same as it is over here, which was the value we had for 30, so the symmetry continues. And when we get to 180 degrees, we're completely flat again, so there's no height, and we're on 0. Now, if we look at our unit circle, we know that the maximum value at the top here is 1. What's the minimum value at the bottom here? Well, that will be -1 because it's below the x-axis. So what do you think is going to happen when we take our angle past 180 degrees? What happens is that we start to get negative values for sin x, and we plot them like this. We can continue round the circle. We get to -1 here. Remember, that's the minimum value of sin x, and that happens at 270 degrees. And then we can carry on around the circle, bringing ourselves back to another value of 0 at 360 degrees. If we now join these dots together with a smooth curve, we'll get all the intermediary values of sin x as well. I'm also going to put on my y-axis. So this is a sketch of the graph of y equals sin x, and you need to know the shape of this and some of the important values off by heart. The first three important values are these ones, where sin x is 0, and that's here, here, and here. There are two other important values that provide the maximum and the minimum of the graph. Sin 90 is 1, and sin 270 is -1. Again, make sure that you know the shape of this graph and the important values off by heart. Now, we've just looked at the height, which gives us sin x. If we were to do exactly the same thing for cos x, we would be looking at this distance here. The resulting graph will look like this. Again, notice that the maximum value is 1 and the minimum value is -1. You need to know what this graph looks like off by heart. Remembering these important points will help you to do that. Now, one of the main problems is remembering which graph is actually which. I'm now going to show you a nice way that one of my students actually came up with that really helped her remember which one was which. She remembered that if she wanted to draw y equals cos x, cos begins with a c. So the graph, if you tilt your head onto the side, is kind of C-shaped. Once you've got the basic C shape, all you need to do is remember that that's 1 and that's -1. This here will be 360, making the halfway point 180, this 90, and this 270. So we have zeros here and here, 1 here and here, and -1 here. She also remembered that if she wanted to draw y equals sin x, that sin begins with an S. So again, if you tilt your head, the graph is kind of S-shaped. Admittedly, it's backwards, but it's certainly more of an S than this one is. The only thing left is to remember that this is 1 and this is -1. This must be 360, making the middle 180. This point here where it hits 1 is 90, and this point here where it hits -1 is 270. You need to be able to reproduce sketches like these in an exam situation. This is a typical exam question, and I'm asked to find the value of x for which sin x is 0.9397. So I know that sin x is 0.9397. Now this question would appear on a calculator paper. So to find the value of x, I can do inverse sine 0.9397 using my calculator. Remember, to do this, you press Shift sign and then type in the number. I get 70 degrees to the nearest degree. So this is my value for x. But if I look in the question, it says find the values and give your answers. So that's a pretty clear indication that I need more than one value. I've got to find all the values that this occurs for between 0 and 360 degrees. So to do this, I'm going to draw a sketch of sin x to help me. I can now use my sketch to help me find the other values of x. I already know that 70 degrees is one value, and that's about here, and it's giving me the sign, which is 0.9397. Now I can see from the symmetry of the graph that if I carry on, I'll get another value here for the same value of sin. Now remember, this was 70 degrees, so it's 20 degrees to the left of 90. So if I go 20 degrees to the right of 90, that's 110 degrees. So one of my values is 70 degrees, and another value is 110 degrees. If I just check, I can see that nowhere else on the graph will give me this same value, so these are my two answers. Just out of interest, another way of getting the value of 110 is to realise that our one value is here at 70. So using the symmetry of the graph, we can take that 70 away from 180 to give us 110. Here's one of those for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one for you to try. Be careful because this time it's cos x, not sin x. Press pause and have a go. When you're ready, press play. Using your calculator, you should have got an answer of 132. To get the other answer, you need to use your sketch. We can see that 132 is here. The other value will be here. So to find this value, I'm going to use the symmetry of the curve. It's symmetrical about the 180 degrees. So from here to 132 is a gap of 132. So to get this value, I can subtract 132 from 360, and I get 228 degrees. So my other answer is 228 degrees. So the answers you should have got are 132 degrees and 228 degrees. Now this question would appear on a non-calculator paper. I want to find the exact value of cos 330 without using a calculator. Now to start with, I don't have a clue what this is, so I'm going to draw a sketch of the graph of cos. Now 330 is here, so the value of cos 330 is this. And I can see that it's the same as the value of cos whatever this is. Now this is 30 degrees away from the 360, so this must be 30 degrees away from 0. So the value of cos 330 is the same as the value of cos 30. So if we know the value of cos 30, then that will be the same as the value of cos 330, which is what we're looking for. Some of you might have memorised this and be able to just write it down straight away. Some of you might prefer to use the little trick that we looked at in grade 5. So remember, to find cos 30, we want the number of fingers on the right, which is 3. We want the square root of that, so that's root 3, and divide by 2, so that's divided by 2. So the value of cos 30 is root 3 over 2, and this is also the value of cos 330. So this is the answer to the question. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. We're now going to look at the graph of tan x. Now the first thing I do is draw a tangent to my unit circle. Now we're going to make our angle here. So this is angle x. We're interested in what happens when we project this onto this tangent line. Now we know that tan is opposite over adjacent. So this is opposite and this is adjacent. Because the adjacent goes to the edge of the circle, remember that's 1. So the value of tan will be this height here divided by 1, which is actually just this height here. If I change to a larger angle now, that would be the angle and I would project all the way up here to the tangent line, and the value of tan would be this height here. And I can carry on doing this all the way from 0 to 360 around the unit circle to plot the graph of tan x. So we start here with an angle of 0 degrees, and you can see that the height projected onto the tangent is 0, so we plot that here. With an angle of 30, the height projected onto the tangent is this, and that's here, which we plot at 30 degrees. With an angle of 60, you'll see that the height projected onto the tangent starts to increase quite rapidly, and we plot that here. And I keep going to 70 degrees, 80 degrees, and at 90, you'll see that our line is vertical, so nothing is being projected onto the tangent. The height is therefore infinite. So what's actually happening is that as we get closer and closer to 90, the value of tan x is increasing more and more and more rapidly. And actually, when we get to 90, the value of tan x is infinity. We can't plot that on the graph. Instead, we say that at 90, we have a line that the graph will never ever meet. We call this an asymptote, and actually it continues underneath the graph as well. Now, what do you think is going to happen if we make this angle larger than 90 degrees? So let's do that now with an angle of 110 degrees. You can see that this line here, if I extend it, won't actually ever meet my tangent. But if I look at the other end of the line, it will, and I get a negative value for tan x, so I plot that on the graph here. I can continue in the same way until I reach 180 degrees, where the value of tan x is 0. So notice now that we're back to this point again, and the graph is going to continue upwards. What do you think is going to happen when I hit 270 degrees? Again, the line is now vertical and will not meet the tangent, so we get another infinity value and another asymptote on the graph. We've now completed a full rotation, and tan x is back to 0 at 360 degrees. Let's tidy this graph up now. So this is the graph of y equals tan x, and we have two asymptotes at 90 degrees and 270 degrees. You're expected to memorize the shape of this graph. Personally, I find it really helps to memorize the asymptotes as well, because this helps me produce this graph. Now, the nice thing about the graph of tan x is that it repeats every 180 degrees. So let's say I want to find the value of tan 30. Well, 30 degrees is here, so the value of tan 30 will be here. Now I know that exactly 180 degrees on from that 30, so that's here at 210, I will get exactly the same value for tan as I did for 30. Now in this exam question, I'm being asked to find the values of x for which tan x is 1.1918. So I can get the first one using inverse tan. Remember, that's shift tan on your calculator. And you'll get 50 degrees. Now at this point, I sort of want to draw a sketch, but remember what we just said. The nice thing about tan is that it repeats every 180 degrees. So to get the other value, I can just do 50 plus 180 and get 230 degrees. So x is equal to 50 degrees and 230 degrees. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now here's a tricky little question for you. Before you start writing your answers down for this one, you need to remember that your values of x can only be between 0 and 360. Press pause and have a go. When you're ready for the answers, press play. So, using inverse tan, you should have found a value of x as minus 70 degrees. This isn't in our interval, so this isn't one of the answers we're allowed to write down. But remember, tan repeats itself every 180. So we can go minus 70 plus 180, and that will give us 110 degrees, and that is in our interval, so that's allowed. And then we can get that 110 and add on another 180 to get 290 degrees, which is also in our interval. If we add another 180, we'll go above 360, so these are the two answers. So x equals 110 degrees and 290 degrees. In this clip, we're going to be looking at transformation of functions. All the way through my explanation, I'm going to be using just one function, and that's this equation here, which produces this graph. There are 4 different transformations that we're going to be looking at. The first one is translating the graph up and down. The second one is translating the graph right and left. The third one is reflecting the graph in the y-axis. And the fourth one is reflecting the graph in the x-axis. Let's begin our journey into transformation of functions by looking at what happens when we add something onto the end of our function. For example, let's add something onto the end of this function. Let's just use 1 to start with. So here's my equation, and I've added on 1. What effect do you think this will have on the graph? It moves up by 1, and that's because all of the y values have increased by 1. If we add 2 onto the function, the graph moves up by 2. Adding 3 moves the graph up by 3. Now what would happen if a is negative? In other words, we take something away from the function. If we subtract 1, you'll notice that the graph goes down by 1. If we subtract 2, it moves down by 2. And if we subtract 3, it moves down by 3. So when we add a onto a function, we can say that we have a translation by the vector 0a. A can be either positive or negative. And remember that when we have a vector like this, the top number tells us how far we move left and right, and the bottom number tells us how far we move up and down. Here's a question for you to try. Press pause and have a go. When you're ready for the answers, press play. To start question A, I found a convenient point on the original graph. I'm going to choose this point here. I can see that on the red graph, it's here, and it's gone up by 3. So 3 must have been added on to the equation, and you can see that here. Now the question doesn't ask for the equation in its simplest form, so this would actually be accepted. But I always like to tidy things up a bit. I can see I've got plus 1 plus 3, so that's actually plus 4. So this is a neater version of my final answer. We've already said that the graph goes up by 3, so it's a translation by the vector 0, 3. The next thing that we're going to look at is adding something onto the value of x and then performing the function on it. Let's look at what happens to this equation when we add 1 onto the value of x each time. So you can see everywhere I've got an x here, I've got x plus 1. So I've got x plus 1 cubed, that's that bit. X has turned into x plus 1 here. I've got 3 of those squared, and I've still got the plus 4 on the end. What effect do you think this will have on the graph? Now, 99.9% of all known people automatically think that this graph will move 1 to the right. But It actually moves 1 to the left. Let me try to explain to you why this happens. Let's take a value for x. Let's choose 1 for the first one. So we would have 1 here and 1 here. Now, because we've got 1 plus 1 here and 1 plus 1 here, this equation will actually return the value for 2, because we'll have 2 cubed minus 3 times 2 squared plus 4. So when I'm at 1, I will actually get the value for 2. If I now take another value for x, I'm going to choose minus 1 this time. Watch what happens. I've got minus 1 plus 1, so I'm actually going to get 0 cubed minus 3 times 0 squared plus 4. So minus 1 is going to return the value for 0. So the minus 1 here will return this part of the graph here. So as you can see, every value is moving 1 to the left. And the graph should look something like this. Now, what do you think will happen if instead of adding 1 to x, I add 2? It will move 2 to the left. Now, what will happen if a is negative? In other words, we subtract something from x before performing the function on it. If we subtract 1, the graph moves 1 to the right. Subtracting 2 moves the graph 2 to the right. And subtracting 3 moves the graph 3 to the right. So to summarise, if I add something to x, then the graph moves to the left. And if I subtract something from x, then the graph moves to the right. It's important to remember that this one goes the opposite way to the way you think it's going to move. We can say it's a translation by the vector minus a, 0. Remember, this tells you left or right, and this tells you up or down. Here's a question for you to try. Press pause and have a go at it. When you're ready for the answers, press play. Here are the answers. To get my answer, I looked at the graph here and chose 2 convenient points. I then looked where they'd moved to on the red graph, and I could see that they've both gone 4 to the right. Remembering that it's the opposite to what you always think, this means we must have minus 4. Notice that here I haven't expanded the brackets at all. This is a perfectly acceptable answer, and you should leave your answer in this form. When we write the transformation as a description, it's a translation, and it's gone right 4, and then it hasn't moved up or down, so this is our vector. Here's another question for you. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For part A, if the graph of x squared has been transformed by 0 to 2, then that means it will have gone up 2. So we add 2 onto the end of the equation and get x squared plus 2. For part B, adding 1 onto the x before performing the function on it means that the graph will move 1 to the left. This is just a sketch, so we move the graph to the left and then mark that the bottom will be minus 1. Here's another question for you. If you look carefully at the graph, you'll notice that it's moved horizontally and vertically this time. Press pause and have a go. When you're ready, press play. Here are the answers. This time, if we choose points on the black graph, we can see that they've moved 3 to the left and then 2 up. Again here, 3 to the left and then 2 up. So the movement of 3 to the left means that we must have added 3 onto the x, and the movement of 2 up means that we must have added 2 onto the end of the whole equation. If you've left your answer like this, it's perfectly acceptable, but I've done a slightly tidier version here. This movement, 3 to the left and 2 up, can be represented by this translation vector, minus 3 for 3 to the left and 2 for 2 up. Here's another question for you to try. When it asks you to show clearly the coordinates of the vertex of the graph, it's talking about the turning point. So the vertex of this graph is this point here. Press pause and have a go. When you're ready, press play. Here's the answer. We're now going to look at reflecting a graph. So let's look at what happens if we put a negative sign in front of the function for x. In this instance, we get this. What effect do you think this will have on the graph? It reflects the graph in the x-axis, and this is because all the values of y change sign. So if they were positive, they become negative, and if they were negative, they become positive. If we're asked to describe the effects of this, we can just say it's a reflection in the x-axis. Here's a question for you. Press pause and have a go. When you're ready, press play. Here's the answer. We can see that the graph has been reflected in the x-axis, so it must have a negative in front of the function. So this is our answer. Now we're going to look at what happens if we put a negative sign in front of x before performing the function on it. So for this equation, we get this. What effect is this going to have on the graph? It reflects it in the y-axis. If we're asked to describe this effect, we simply write reflection in the y-axis. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. This is telling me that the graph is reflected in the y-axis. I've done a sketch of that here to help me visualize where the minimum point will be. But you don't have to do a sketch, you might find that you're able to do it without one. So here's a summary of the 4 transformations that we've looked at in this clip. If we add something onto the end of the function, then the graph moves up or down. If we do something to the x, then it moves left or right. It's the opposite to what you think, so if we add something it moves left, and if we subtract something it moves right. This is the one where more mistakes are made than any of the others. If we put a negative sign in front of the whole function, then the graph reflects in the x-axis. If we put a negative sign in front of the x before performing the function on it, then the graph reflects in the y-axis. Here's a set of questions which uses everything that we've learnt in this clip. Press pause and have a go. When you're ready, press play. Here are the answers. For this one, the graph moves 5 to the right, so I've added 5 onto the x-coordinate. For this one, the graph moves 6 up, so I've added 6 onto the y-coordinate. For this one, the graph reflects in the x-axis, so I've made the y-coordinate the negative of what it originally was. And for this one, the graph reflects in the y-axis, so I've made the x-coordinate the negative of what it originally was. To finish, here's a challenging question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, I noticed that first of all, this graph needs to be reflected in the x-axis to turn it the right way up for this one, and then it needs to be moved up by 3. So the reflection in the x-axis means that I put a minus in front of the function, and then to move it up by 3, I add 3 onto the end. This is a summary of the 4 transformations of graphs that we looked at in Part A. In this clip, we're going to be looking at transforming trigonometric functions, but the principles are exactly the same. So here's your first question. Press pause and have a go at it. When you're ready, press play. Here's the answer. Because 45 has been subtracted from the x, we've moved the graph 45 to the right. Here's another one for you. Press pause and have a go. When you're ready, press play. Here's the answer. Because 1 has been added onto the function, it's going to move up by 1. So this is the new graph. Here's another question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Just out of interest, in general, people find this kind of question really challenging. So if you did manage to get this answer, well done. I'm going to find the equation of this circle here. To do this, I draw any radius on the circle, so I've drawn this one. I'm going to call the point where the radius meets the circle x, y. Now I know that if I drop a line straight down here, that distance will be y, and if I draw a straight line across here, that distance will be x. Now I've created a right-angled triangle, so I can use Pythagoras' theorem to find the equation of the circle. I know that this radius is 5. So Pythagoras' theorem tells me that x squared plus y squared equals the hypotenuse squared, which is 5 squared. So I get x squared plus y squared equals 25. This equation will be true for whichever point I choose on the radius of the circle, because the point will always be xy and the radius of the circle will always be 5. Therefore, this is the equation of the circle, with centre the origin and radius 5. I'm now going to take this one step further and find the equation of any circle with centre the origin. I don't know how big this radius actually is, so I'm going to call it r. The point here on the circumference of the circle is xy. So this distance here is y, this distance here is x, and we've created a right-angled triangle. Using Pythagoras' theorem, we get that x squared plus y squared must equal r squared, and this is the general equation of any circle as long as the centre is the origin. We can now use this general equation to help us answer some exam-style questions. I'm asked that if a circle has its centre at the origin and a radius of 4, what is its equation? Well, I'm going to use this. It's x squared plus y squared equals the radius squared, so that's 4 squared. So I have x squared plus y squared equals 16, and this is the equation of that circle. In this second part, I'm given the equation and asked for the length of the radius. So remember, it's x squared plus y squared equals r squared, and we've got 49, so r squared is 49. That tells me that the radius must be the square root of 49, which is 7. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. You'll need some graph paper for this one, and you'll need to draw this set of axes. When you come to answer part B, I hope you realise that what you're actually looking for is the places where the line intersects the curve. Press pause and have a go. When you're ready, press play. This should be your answer for part A. From this equation here, you know that the radius squared is 9, so the radius of the circle must be 3. For part B, you should have started by drawing the line x plus y equals 1. That's this line here. You might have used a table to help you get some values. It doesn't have to look exactly like this. This is just an example. You then need to find the coordinates of the points where the line intersects with the circle. So that's here and here. So if I look at this one, I have an x value of minus 1.6 and an associated y value of 2.6. And if I look at this one, I have an x value of 2.6 and an associated y value of minus 1.6. So these are the solutions. I'm being asked to draw lines to show the region satisfied by these three inequalities. So the lines I need to draw are as follows. For x is greater than or equal to minus 2, I'm actually going to draw x is equal to minus 2. For y is greater than x, I'm going to draw y equals x. And for x plus y is less than 2, I'm going to draw x plus y equals 2. Now, some of the lines will be dotted and some will be solid. You need to remember that when you've got a greater than or equal to or a less than or equal to, it will be a solid line. If you've just got greater than or less than, your line will be dotted. Now the line x equals minus 2 crosses through the x-axis at the number minus 2, and it's a vertical line. So this is my first line. Now I've got to draw the line y equals x. I know that that's the line that goes diagonally through 0, 0, 1, 1, 2, 2, etc. And I need to draw this as a dotted line. So the line looks like this. Now I want to draw the line x plus y equals 2. I'm going to give myself a little table for this one. I'm going to take values of x as 0, 1 and 2. And I know that when I add y to it, I've got to get 2. So 0 add 2 would give me 2, 1 add 1 would give me 2, and 2 add 0 would give me 2. So my line has to go through 0, 2, 1, 1, and 2, 0, and it needs to be a dotted line. So my line looks like this. Now I need to label the region that's satisfied by the three inequalities with the letter R. To find that region, I need to find the area that's defined by the three lines I've drawn. That's this area here, so this is R. Just to show how this makes perfect sense, the region x is greater than or equal to minus 2 is here, and that eliminates this part of the graph here. Now we want to satisfy y is greater than x, so that's going to be above the line y equals x. And that eliminates this section here. We then also want to satisfy x plus y is less than 2. So that's below the x plus y equals 2 line. And that eliminates this section here, leaving us with the region that we've labelled R. Here's one for you to try. You'll need to copy the axes onto some squared paper. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. You'll need to copy the axes onto some graph paper this time. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. You'll need to copy the axes out onto some graph paper this time. You're told that x and y are integers. That means whole numbers. You'll find that there's only one pair of coordinates that satisfies this within the region. This part looks really complicated, but you're going to find your region in the usual way. Press pause and have a go. When you're ready, press play. Here's the answer. Now in this question, I want to use inequalities to describe the shaded area on the grid. So first of all, I need to identify the equations of all of the straight lines. Let's do the horizontal one first. It goes through the y-axis at the number 2, and it's a horizontal line, so we know it's y equals 2. Now for the vertical one, that goes through the x-axis at the number 1, and it's a vertical line, so we know that that's x equals 1. Looking at the two diagonal lines, I'm going to do this one first because I recognise this one as being y equals x. Because for every x coordinate on the line, the y coordinate is the same. We've got 1, 1, 2, 2, 3, 3, and so on. Now I've only got this one left to find. Let's have a look at some of the coordinates on this line. We've got 0, 5, 1, 4, 2, 3, and so on. You'll notice that each time the pair of coordinates adds up to 5, so this must be x plus y equals 5. Now I've just done most of the work. Identifying the lines is the hardest part of the question. Now I've just got to turn them into the correct inequalities. So if I look at the y equals 2, I can see the shaded region is above that. So it must be y is greater than 2. And because the line is solid, it's actually greater than or equal to. For the x equals 1 line, I can see that the shaded region is to the right of it. So again, that must be greater. So its x is greater than 1, and the line is solid, so it's greater than or equal to 1. For the y equals x line, again, I can see that the shaded region is above it. So y must be greater than x, and again, it's a solid line, so it's greater than or equal to. For the x plus y equals 5 line, I can see the shaded region is below it. So x plus y must be less than 5. This time we've got a dotted line, so we leave the inequality symbol like this. So these are the 4 inequalities that describe the shaded region on the grid. Here's one for you to try now. Press pause and have a go. When you're ready, press play. Here's the answer. Now we already know that lines with gradients m1 and m2 are parallel if the gradients are the same. What we're going to look at in this clip is what condition is needed for the lines to be perpendicular. Perpendicular, of course, means that the lines will be at right angles to one another. Here are 2 perpendicular lines, and here are some questions about them for you. Once you've done part C, you should have a good idea of what happens when 2 lines are perpendicular. Press pause and have a go at these questions. When you're ready, press play. You should have found that the gradient of the line AB is 2, and the gradient of the line CD is minus a half. Now if I multiply these 2 gradients together, that's 2 times minus a half, and that gives me minus 1. Let's quickly look at another pair of perpendicular lines. So the gradient of the purple line is 3, and the gradient of the black line is minus a third. If I multiply these together, I get minus 1 again. So lines with gradients m1 and m2 are perpendicular if, when you multiply the 2 gradients together, you get minus 1. Now using that fact, we can quickly work out the perpendicular gradients to these gradients here. So for 5, I find the reciprocal of 5, which is 1/5, and change the sign. This one's positive, so this will be negative. Let's check this works. 5 times minus 1/5 is definitely minus 1. So we find the reciprocal of minus 6, which is minus 1/6, and we change the sign. This is minus, so we want to change this to a positive. So the answer actually looks like this. So here I find the reciprocal, that's 9/4, and I change the sign, so this will be negative. And for this one, I find the reciprocal, that's minus 3/2, and I change the sign. So you can think of this as turning it upside down and then changing the sign. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another question for you now. Press pause and have a go. When you're ready, press play. To prove that the 2 lines are perpendicular, we multiply the gradients together, so that's minus 2 multiplied by a half. If it comes out to be minus 1, they're perpendicular, and it does. And we finish with a statement saying that the gradients multiply to give -1, so the lines are perpendicular. Here's a much more difficult question for you to try. Press pause and have a go. When you're ready, press play. For this question, you needed to find the coordinates of M. You do this by adding the x coordinates of A and B and halving, you get 4, and the y coordinates of A and B and halving, you get 7. So the coordinates of M are 4, 7. You also needed to find the gradient of AB, and I've done that using this formula here, and the gradient of AB is -1/3. You also needed to find the gradient of MC. Again, I've used this formula here, and the coordinates I found for M. I get this answer, the gradient is 2. To finish off, I multiply the two gradients together, so that's -1/3 times 2. Now I don't actually have to work this out, I can see straight away that it's not going to equal -1, so the lines are not perpendicular. So this is my final answer. You'll notice that the question says you must justify your answer, and all of this working out is my justification. This question has two parts. In the first part, I'm asked to find the equation of the line which passes through points A and B. So I start by drawing that line. Now the equation will have the form y equals mx plus c. I need to find the gradient, and I know the gradient is y2 minus y1 over x2 minus x1. So I'm going to call this x1, y1, and this x2, y2. So for the gradient, I get 9 minus -6 over 2 minus -1. So that's 15 over 3, and that's a gradient of 5. So my equation will be y equals 5x plus c. Now to find c, I need to use either of these two pairs of coordinates. I'm going to use this one because I don't like the negatives. So here, y is 9 and x is 2. So I get 9 equals 10 plus c. That tells me that c is -1, so my equation is y equals 5x minus 1. And this is the answer to part A. Now in part B, I'm asked to find the equation of the line which passes through point C and is perpendicular to AB. So the gradient will be perpendicular to 5. That tells me that the gradient will be -1/5. So it's going to be -1/5 x plus c. Now to find c, I'm going to use the only point I've got, which is this one here. Y is 5. So I've got 5 equals -1/5. X is -5, so that's times -5, plus c. So 5 equals -1/5 times -5 is 1, plus c, so c must be 4. So the equation is y equals -1/5 x plus 4. And this is the answer to part B. Here's a question for you. Press pause and have a go. When you're ready, press play. Here are the answers. We're now going to look at a particular type of question that you can be asked. We want to find an equation of the tangent to a circle at a specific point. The first thing we need to remember is that if we draw the radius here, the tangent is going to be perpendicular to this radius. So what I'm going to do is find the gradient of the radius and use this to find the gradient of the tangent. So to find the gradient of the radius, which is OP, I'm going to use y2 minus y1 over x2 minus x1. This, the origin, is x1, y1, and this point is x2, y2. So I have 12 minus 0, because it's the origin, over 5 minus 0 again, because it's the origin. So we've got that the gradient of the radius is 12 over 5. Now, because the tangent is perpendicular to the radius, the gradient of the tangent is going to be minus 5 over 12. Now I can use the gradient and the point on the tangent to find the equation of the tangent using y equals mx plus c. First of all, we know that m is minus 5 over 12, so we've got y equals minus 5 over 12 x plus c. Now I can substitute in values of y and x, which are here. So y is 12, that's equal to minus 5 over 12 times x, which is 5, plus c. So I've got 12 equals minus 5 over 12 times 5, which is minus 25 over 12, plus c. I can use this to work out what c is. C is going to be 12 plus 25 over 12. 12 is 144 over 12, plus 25 over 12. So c is 169 over 12. So now, using y equals mx plus c, I've got y is equal to m, which is minus 5 over 12, times x plus c, which is 169 over 12. And this is an equation of the tangent. Here's one of those for you to try now. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. In this clip, we're going to be looking at something called completing the square. This is a typical exam-style question on it, and I'm being asked to write this expression here in this form. This is called the completed square form. The reason we do this is because it makes it easier to solve quadratic equations and sketch graphs. Let me show you how to write this in this form using a step-by-step approach. The first thing I do is write my set of brackets for this part here. I've got to have an x in it and half of this number here. So that's plus 4, so I'm going to put plus 2. I'll show you why we're doing this in a moment, and this needs squaring because that's this part here. Now, if I actually expand this, I get this. Now you can see I've got the x squared and I've got the plus 4x, but I've also got a plus 4 as well, which has come from squaring the 2. I don't want this, so the first thing I'm going to do is write minus 4 here to get rid of it. So what I've got here now is exactly equivalent to this. The only other thing I need is a minus 3, and that goes on the end. All that's left to do now is simplify this part here. So I've got x plus 2 squared, and then here I've got minus 7. This is the completed square form of this. A is 2, and B is 7. Here's one for you to try now. Press pause and have a go. When you're ready for the answer, press play. So I hope you started by writing a set of brackets with an x in it. Half of this 10 gives me 5, so that's plus 5, and we're squaring that. Now 5 squared is 25, and we need to take that away, and we need a plus 15 on the end. So simplifying gives us x plus 5 squared minus 25 plus 15 is minus 10. So this is the completed square form of this. Here's another one for you to try. Press pause and have a go. When you're ready for the answer, press play. So for this one, we start with our brackets and we put an x and half of this, so that's going to be minus 3, and that gets squared. Now remember, when you square minus 3, you still get plus 9, and we need to take that away. We also need a plus 2. Simplifying this now gives us x minus 3 squared minus 9 plus 2 is minus 7. If we check up here, we wanted minus a, and we've got that, it's minus 3, so a is 3, and minus b, we've got that, b is 7. Here's another one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Now this question looks like it's going to be exactly the same, but there's a slight difficulty in it which you'll see as I go through it with you now. We start in the same way with our brackets and our x. We then want half of this number here. Now don't be tempted to write 2.5. Leave it as a fraction, so we're going to have 5 over 2. This gets squared. I now need to square 5 over 2 and take it away. I get minus 25 over 4. On the end, I need the minus 6. Now I've got to simplify this. I'm going to leave this bit as it is, so that's x plus 5 over 2 squared. I'm going to leave this for the moment as minus 25 over 4. But to be able to simplify this, I want this number here as a fraction over 4. So that's going to be minus 24 over 4, because 24 over 4 is 6. Now I can simplify. So I've got x plus 5 over 2 squared, minus 25 over 4, minus 24 over 4. So that's minus 49 over 4. This is the final answer in completed square form. Just out of interest, I used the fraction here, 5 over 2. You can use the decimal if you want to, but that then means that you've got to square 2.5 by doing 25 times 25 and then putting the decimal point in the right place. Once you've done all this extra working, you can then finish your answer. So I find it more straightforward and faster to use the fractions. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Now it really helps to practice at these questions, so here's 4 more for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now this is a much more difficult type of question. The difficulty here is that we've got a coefficient of x squared, which is 2, and we can't square anything to get 2. The way I'm going to deal with this is by factorising this part here. So I'm going to take out a factor of 2, and that leaves me with x squared plus 2x. The plus 1 was not included in the factorisation, so this just goes on the end. Now I'm going to do my completing the square just on this part here inside these square brackets. So I've got 2 on the outside, then the square bracket. Now complete the square in here. I get x plus half of this 2 is 1. Square it. If I square 1, I get 1, and I need to take that away. I've still got this plus 1 outside the square bracket. Now what I want to do is get rid of this extra set of brackets, and I do that by multiplying by 2. So I've got 2 lots of x plus 1 squared, and 2 lots of minus 1, so that's minus 2. And I've still got the plus 1 on the end. Now I can simplify. So I've got 2 lots of x plus 1 squared, minus 2 plus 1 is minus 1. This is the finished completed square form of this question here. So whenever you get a question like this, where the coefficient of x squared isn't 1, the trick is to factorise taking out that coefficient of x squared. Now here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here are two more questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I'm being asked to solve this quadratic equation here using a completing the square method. So to do this, I complete the square in my usual way. And I get x minus 2 squared minus 16 is equal to 0. Now I want to solve this. The first thing I'm going to do is add 16 to both sides. So I get x minus 2 squared equals 16. Now I want to square root both sides. Square rooting x minus 2 squared gives me x minus 2. And square rooting 16 gives me plus or minus the square root of 16. I'll explain about this in a moment. So I have x minus 2 equals plus or minus the square root of 16, which is 4. Now let's just look at this plus and minus for a moment. If I square plus 4, I get 16. If I square minus 4, I also get 16, and that's why we have to make sure to write this, because we're actually getting two answers here, one positive and one negative. Now to finish solving, I'm going to add 2 to both sides, so I get x equals 2 plus or minus 4. This tells me that x is 2 plus 4, which is 6, or 2 minus 4, which is minus 2. Notice that because I was solving a quadratic, I was expecting two answers, and I got two answers. Remember, we get the two answers because of the plus and the minus at this stage here, so don't miss this part out. Here's one for you to try. Press pause and have a go. When you're ready for the answers, press play. You should have started like this. Now I need to square root both sides. I get x minus 6 on this side, and on this side, don't forget, it's plus or minus the square root of 9. So I've got x minus 6 equals plus or minus the square root of 9, which is 3. Now I get x equals 6 plus or minus 3, and this gives me my two answers, 6 plus 3, which is 9, and 6 minus 3, which is 3. Now this question asks me to give my answers correct to two decimal places. I'd be allowed a calculator for this question, and actually it's not any more difficult. I start by completing the square on this equation. Completing the square gets me to this point. I now need to add 19 to both sides, so I get x plus 3 squared equals 19. Now I want to square root both sides. This gives me x plus 3 equals plus or minus the square root of 19. Now the square root of 19 is not something I know, so I'm going to use my calculator for this bit when I get to it. First of all though, I've got to take 3 away from both sides. So I get x equals minus 3 plus or minus the square root of 19. I can now use my calculator to get the two answers. To get the first answer, I type in minus 3 plus root 19, and to two decimal places I get 1.36. And for the second answer, I type in minus 3 minus root 19, and I get minus 7.36 to two decimal places. These are my two final answers. Here's one of those for you to try. Remember, you can use a calculator for this. Press pause and have a go. When you're ready, press play. Here are the answers. Now in this question, I'm being asked to leave my answers in exact form. This would be on a non-calculator paper. Believe it or not, it's actually slightly easier than with a calculator. We start in our normal way by completing the square. I then add 6 to both sides to get x plus 1 squared equals 6, and then square root both sides to get x plus 1 equals plus or minus root 6. At this stage now, I need to take away 1 from both sides, so I get x equals minus 1 plus or minus root 6. And I actually stop here, because I have my two answers in exact form here, minus 1 plus root 6 and minus 1 minus root 6. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here's what you should have got for this one. Now this is the hardest question of this type that you can get. The difficulty here is that you've got a coefficient of x squared that isn't 1, so remember you need to complete the square very carefully with this coefficient in mind. Press pause and have a go. When you're ready, press play. The completing the square step for this one looks like this. From this point here, I then need to add 5 to both sides, so I get 2x minus 1 squared equals 5. Now I need to divide both sides by 2, so I get x minus 1 squared equals 5 over 2. Now I want to square root both sides. This gives me x minus 1 equals plus or minus the square root of 5 over 2. Now I want to add 1 to both sides, so I get x equals 1 plus or minus the square root of 5 over 2. This is my answer in exact form, so I stop here. Here's another one of those for you to try. This time you can use a calculator and give your answers correct to 2 decimal places. Press pause and have a go. When you're ready, press play. Here are the answers that you should have got for this one. I'm being asked to sketch the graph of this equation here. So the first thing I'm going to need is a set of axes. If I leave the equation in this form here, I can only actually tell 2 things about the curve. The first is because it's an x squared, a quadratic, I know it's going to be this sort of shape. However, I don't know where this belongs on this set of axes. If I put in x equals 0, then I get 26, and this tells me where the curve crosses the y-axis, so it's going to cross at 26. The problem is, I don't know whether the curve goes here, 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 or indeed in any other place where it crosses the y-axis at 26. The crucial thing I need to find out is where this, the turning point of the curve, actually is. I can find the turning point of the curve by completing the square on this equation. So I've got y equals x squared plus 10x plus 26, and I want to complete the square in the usual way. I get this. Now remember what I already know. I know the shape of my curve, and I know that it's going to cross the y-axis at 26. Now remember, what I'm looking for is the turning point, and that's going to be the minimum value of y. So I need to find the minimum value that this equation will take. Now, because this part here is squared, the minimum that this can be is 0, because any squared number is 0 or above. When this is 0, y will be equal to 1, so the minimum value of y is 1. I want to find out where exactly this minimum value occurs. In other words, for what value of x is it? Well, this we said was going to be 0, and this will be 0 when x is minus 5, because minus 5 plus 5 is 0. So the minimum point must be at minus 5, 1, which is here. I already know the general shape of the graph, and I know that it crosses the y-axis at 26, so now I can draw it onto my axes. This is my sketch of this graph. So, to summarise, once we've done our completing the square step, we can then find the minimum point. This value here will be the minimum value of y, and make this bracket 0 to find the value of x for which this minimum value occurs. In our example here, the turning point was at -5, 1. Now, here are two equations in completed square form for you. What I'd like you to do is write down the coordinates of the turning point of each of these two graphs. Press pause and have a go. When you're ready, press play. So for this one, the x-coordinate will be -10 and the y-coordinate will be 5. And for this one, the x-coordinate will be 7 and the y-coordinate will be 12. Now here's a sketching question for you to try. Press pause and have a go. When you're ready, press play. Your finished sketch should look something like this. You should have marked that the y-intercept occurs at 11 and that the coordinates of the turning point are 3, 2. Here's another question for you to try. Press pause and have a go at it. When you're ready for the answer, press play. Here's the answer. Now this is a more difficult type of question. In this question, I actually need to work backwards. I'm given the turning point, and I want to find out what the original equation was. Now remember, from the turning point, we can get to completed square form. The completed square form will be something like y equals x plus, let's call it p, squared, and then plus q. These might be minuses, I don't know yet. I'm going to look at this now to tell me. So I know that the minimum value of y occurs when x is -2. I'm going to use that to find out what p is. So if x is -2, and I know that this is going to be 0, p must be +2. Now the minimum value is 3, so I know that q must be 3. From this step now, I can actually get to this equation by multiplying out the bracket. So I get x squared plus 4x plus 4, that's from this, and then I've still got the plus 3. Simplifying now gives me x squared plus 4x plus 4 plus 3, which is plus 7. This is the equation. The value of a is the coefficient of x, and that's 4. And the value of b is the constant, and that's 7. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this clip, we're going to be looking at simplifying algebraic fractions. There are 3 different types. This type of question, where we just have to do straightforward cancelling. This type of question, where we need to factorise before we cancel. And this type of question, where we've got to add or subtract some fractions. You'll find that at least one of these types of questions is on almost every single exam paper. Let's start by looking at how we do the questions that just involve straightforward cancelling. I'm going to show you 2 different ways of doing this question. The first way looks like this. I start with 6 divided by 2, and 6 divided by 2 is 3, so I write that down. Then I've got n squared divided by n to the power of 6. To do this, I subtract the powers. 2 take away 6 is -4, so I've got n to the power of -4. Then I've got n to the power of 6 divided by m to the power of 2. I subtract the powers again. 6 take away 2 is 4, so I've got m to the power of 4. And this would be my answer. The second way is where I cancel, and it looks like this. What goes into 6 and 2? Well, 2 goes into both of those, so if I divide this by 2 I get 3, and if I divide this by 2 I get 1. What goes into n squared and n to the power of 6? N squared does. If I divide this by n squared I get 1, and if I divide this by n squared I get n to the power of 4. What goes into m to the power of 6 and m to the power of 2? M to the power of 2 does. If I divide this by m to the power of 2, I get m to the power of 4, and if I divide this by m to the power of 2, I get 1. Now I can tidy up my answer. I've got 3 times 1 times m to the power of 4, so that's 3m to the power of 4, and on the bottom I've got 1 times n to the power of 4 times 1, so that's just n to the power of 4. Both of these answers are correct, they're equivalent to each other, and they're both completely acceptable in the exam. For this question here, I start with 8 divided by 2, and 8 divided by 2 is 4. I've then got x plus 3 squared divided by x plus 3. Remember that x plus 3 is actually just x plus 3 to the power of 1. So I can subtract the powers, 2 take away 1 is 1, and that leaves me with x plus 3. It's really to the power of 1, but I don't need to write that. So this is the answer. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now in this question, I've got an algebraic fraction that's made up of a quadratic and another quadratic here. To simplify this, I first of all need to factorise each of these. So factorising the top gives me x minus 5, x plus 3. And factorising the bottom gives me x minus 7, x plus 3. Now you can see that I've got x plus 3 on the top and on the bottom. So these will cancel out and I get x minus 5 on the top and x minus 7 on the bottom. This is my fully simplified fraction. For this question here, I'm going to start in a similar way by factorising the top and the bottom. So on the top here, I can see that I can take out a factor of 3x. That leaves me with 3x minus 2. On the bottom, I can take out a factor of 2, and that leaves me with 9x squared minus 4. Now, 9x squared minus 4 is a difference of 2 squares, so I can factorise this again. So on the top, I've still got 3x and then 3x minus 2. And on the bottom, I've still got the 2. But then, with a difference of 2 squares, I have 3x plus 2 and 3x minus 2. Now I can cancel the 3x minus 2 on the top with the 3x minus 2 on the bottom, and that leaves me with 3x on the top and 2 brackets 3x plus 2 on the bottom. This is my fully simplified answer. Now the absolute key to getting this answer was spotting here that I've got a difference of 2 squares. This comes up quite a lot on the exams, so you need to get really good at spotting them. We've got 2 square numbers here and a minus in between, and that tells us we can factorise it in this special way. If I didn't spot this, I wouldn't have been able to finish the question. Another key point for this type of question is noticing that you're definitely on the right track when you get a matching bracket on the top and on the bottom, like we did here and here. If you don't get this matching bracket when you're trying to do one of these questions, then you may have made an error somewhere. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now we're going to look at the third type of problem, where we're asked to either subtract or add two algebraic fractions. Now, when we're subtracting or adding normal fractions, we look for a common denominator, and we're going to do the same thing here. So for this first question, I say to myself, what will 2 and 3 both go into? And that's going to be 6. So I'm going to write two new fractions, both over 6. How many times does 2 go into 6? Well, it goes in 3 times. So on the top here, I need to multiply by 3. I've got 3x plus 2. In the same way, this side needs to be multiplied by 2. So I've got 2x minus 1. Now I can rewrite this as one single fraction. I've got 3x plus 2 minus 2x minus 1, and that's all over 6. Now I'm going to multiply out the brackets on the top. So I've got 3x plus 6 minus 2x minus 2 times minus 1 is plus 2, and that's over 6. Now I'm going to simplify the top. So I've got 3x minus 2x, which is x, plus 6 plus 2, which is plus 8, and that's over 6. I can't do anything else to this, so this is my answer. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Now let's make it a little bit more difficult. This time, in the denominators, I've got letters instead of numbers. So when I'm looking for my common denominator, it's actually going to be this multiplied by this. So the common denominator is going to be y x minus y. So I'm going to write two fractions with this as the denominator. Now to get this to this, I've multiplied by x minus y. So I multiply 3 by x minus y. To get this to this, I've multiplied by y. So I multiply 2 by y. Now I can write this as one single fraction over y x minus y. So I've got 3 brackets x minus y plus 2y, and that's over the common denominator of y x minus y. Now I'm going to expand the bracket on the top here. So I've got 3x minus 3y plus 2y over this y x minus y. And now I can simplify the top. So I've got 3x minus 3y plus 2y is minus y, and that's over y x minus y. Just out of interest, at this point here, I expanded this bracket but not this bracket, and that's because I saw that the 3 and the y would combine and simplify with this plus 2y, but that I wasn't going to get any further simplification from the bottom. And this is the simplest form of my fraction. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. Press pause and have a go at it. When you're ready, press play. Now, if you're really good at algebra, then you will have got to this stage here. And you've certainly written it as a single fraction, so you will get some marks on the exam. But believe it or not, it's not in its simplest form. There's actually a factor that will go into this cubic on the top and that will cancel out with the bottom to make it in a simpler form than this. The problem is, if you've tried to do it this way, finding that factor is incredibly difficult. So I'm now going to show you a slightly different way of doing this type of question where we've got a quadratic in one of the denominators. So the first thing to do when you've got a question like this with a quadratic in the denominator is to try to factorise that quadratic if you can. So I'm going to do a bit of side working first. I'm going to write out my quadratic, that's x squared minus 1 in this case, and I'm going to see if I can factorise it. Well, I definitely can because this is the difference of two squares. So it factorises as x plus 1 and x minus 1. So I can now rewrite the question as 2x over x minus 1 minus 7x minus 3 over x plus 1, x minus 1. I now want to find a common denominator, and the nice thing about these questions is that it's going to be this one here, the quadratic that you factorised. So I rewrite this as two fractions, both with x plus 1, x minus 1 as the denominator. Now what have I multiplied this by to get this denominator? Well, I've multiplied it by x plus 1. So I've got 2x and x plus 1 on the top. This one hasn't changed, so I've got 7x minus 3 on the top. I'm now going to write this as a single fraction with x plus 1, x minus 1 as the denominator. So I'm going to put the denominator first, and then for the numerator, I have 2x, x plus 1, minus all of this. So that's minus 7x, but it's minus 3, so that's plus 3. You need to be really careful here. I'm now going to expand this bracket on the top. So I've got 2x squared plus 2x minus 7x plus 3, and that's over x plus 1, x minus 1. Simplifying gives me 2x squared minus 5x plus 3, and that's over x plus 1, x minus 1. Now you might be tempted to stop here, but it's a good rule that whenever you've got a quadratic, you should try to factorise it, because you might then find a common factor that you can cancel with the bottom. So I'm going to factorise this quadratic, and I'm going to do that as a bit of side working. So I've got 2x squared minus 5x plus 3, and I want to factorise this. I get 2x minus 3, x minus 1. So now I can rewrite this as 2x minus 3, x minus 1, over x plus 1, x minus 1. And we can see that we've got x minus 1 in the numerator and the denominator, so these will now cancel out to give me my final answer, which is 2x minus 3 over x plus 1. Finally, here's one more question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Now we're going to look at solving this equation that involves algebraic fractions. By now, you should be able to write this side of the equation as one single fraction, and that's how we're going to start. So I'm looking for a common denominator. From 5 and 2, I can see it's going to be 10. So I'm going to write them as two fractions, both over 10. So I'm going to multiply this by 2, and I get 2, 4x minus 3 over 10. And I'm going to multiply this by 5. So I get 5 x minus 2 over 10. This remains unchanged. Now I'm going to write this as a single fraction. So I've got 2 brackets 4x minus 3 minus 5 brackets x minus 2, and that's over 10. And that's equal to 2 still. Now I'm going to expand the top. So I've got 8x minus 6 minus 5x plus 10. That's over 10, and that's still equal to 2. Now I'm going to simplify the top. I've got 8x minus 5x, so that's 3x, minus 6 plus 10, so that's plus 4. That's still over 10, and it's still equal to 2. Now at this stage, I want to multiply both sides by 10. So I've got 3x plus 4 equals 20. And now I can solve this linear equation in my usual way. So I have 3x equals 16 and x equals 16 over 3. This is the answer to the question. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. For this question, I tackle it in the same way. I want a single denominator over here, so that's going to be x plus 1, x minus 2. So I'm going to multiply this by x minus 2. So I've got 1x minus 2 over x plus 1, x minus 2. And I'm going to multiply this by x plus 1. So I've got 5x, x plus 1, over x plus 1, x minus 2. This remains unchanged. I now write this as a single fraction. So I've got 1x minus 2 plus 5x, x plus 1, over x plus 1, x minus 2. Again, this remains unchanged. Now I'm going to multiply out the brackets on the top. So that's x minus 2 plus 5x squared plus 5x. That's over x plus 1, x minus 2. And this still remains unchanged. Now I'm going to simplify this. So I've got 5x squared plus 5x plus another x, so that's plus 6x and minus 2. And that's over x plus 1, x minus 2. And that's still equal to 3. Now I'm going to multiply both sides by x plus 1, x minus 2. That gives me 5x squared plus 6x minus 2 equal to 3 x plus 1, x minus 2. Now I need to multiply out this. To make sure I get this right, I like to multiply these two brackets together with a bit of side working first and then multiply by 3. So I've got x plus 1 multiplied by x minus 2. So I've got x times x, that's x squared, x times minus 2 is minus 2x, plus 1 times x is plus 1x, and plus 1 times minus 2 is minus 2. So that's x squared minus x minus 2. So now on this side, I still have 5x squared plus 6x minus 2. But on this side, I've got 3 of this. So that's 3x squared minus 3x minus 6. Now I've got a quadratic on both sides here. What I'm going to do is get everything onto one side so that it's equal to 0, because then I'll be able to solve the quadratic. So I'm going to subtract 3x squared from both sides. That will give me 2x squared. I'm going to add 3x to both sides. That will give me plus 9x. And I'm going to add 6 to both sides. That will give me plus 4. That's now equal to 0. I can now factorise this quadratic, and I get 2x plus 1, x plus 4, equal to 0. So from this, I now know that either 2x plus 1 equals 0, or x plus 4 equals 0. I can solve these two linear equations to get my two values for x. So I get 2x is equal to minus 1, which tells me that x is equal to minus 1 over 2. And I get x is equal to minus 4. These are my two answers. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. If you got these, very well done, because this was an incredibly difficult question. In this clip, we're going to be looking at a really difficult topic. This is as close to A-level maths as you can get within the GCSE curriculum. We want to solve these two simultaneous equations. You can see that one of them is a quadratic, and that's what makes this so difficult. Solving means that I want to find values for x and y, and I do this by combining my two equations into one single equation with only one unknown. So we can see that this linear equation here tells me what y is. Y is 3x plus 1. So what I'm going to do is substitute this as y in here. So I've got 3x plus 1, and you can see that here y is squared, so I need to square it. And that's equal to this, 4x squared minus x plus 7. I've now made one single equation, and I've only got one unknown, which is x, in it. What I'm going to do now is solve this equation. To do that, I need to start by multiplying out this bracket. So I get 9x squared plus 6x plus 1, and that's still equal to this. Some people get caught out by the expansion of this bracket here. It should look like this. And you can always do it as a piece of side working on your paper if you want to be absolutely sure you're getting everything correct. Now from this stage, I need to create a quadratic that's equal to 0, because then I can solve it. So I'm going to rearrange this. So I get 5x squared by taking the 4x squared away from both sides, plus 7x by adding x to both sides, minus 6 by subtracting 7 from both sides, and that's now equal to 0. Now, in the question, I've not been asked to give my answer to any particular number of decimal places or significant figures. So that means I can assume that now I can factorise this. So that's what I'm going to do next. I factorise in my usual way, and I get this answer here. From this, I can now find two values for x. So these are my two values for x. Now we mustn't stop here. We've got values for x, but we also need to get values for y, and we do this using the linear equation here. So the linear equation tells us that y is equal to 3x plus 1. I can now get my first value of y by substituting in the first value of x, which is 3/5, to here. So I have y equals 3 times x, which was 3/5, plus 1. So this gives me that y equals 9/5 from this bit here, plus 1. Now I know that 1 is 5/5, so I've got 9/5 plus 5/5, and that makes y 14/5. So this is my first value of y, and that's associated with this value of x. So I now know that when x equals 3/5, y equals 14/5. Now I move on to x equals minus 2, and I substitute that into this equation. So I've got y equals 3 times minus 2 plus 1. So y equals minus 6 plus 1, so that makes y minus 5, and that's associated with this value of x. So I have y equals minus 5. This is my other pair of values. So in summary, I was asked to solve these simultaneous equations, and I got two pairs of answers. Just out of interest, if we were to draw the graphs of y equals 3x plus 1 and y squared equals 4x squared minus x plus 7, it would look like this. This is our linear graph, this one, and these represent this. What we found is the coordinates of this point here where the graphs cross, and the coordinates of this point here where the graphs cross. So solving the simultaneous equations finds the points of intersection of the two graphs. Here's a question for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I hope when you got to this stage here, you realised that this was a simple factorisation and that you could take out a factor of 5x, leaving this bracket. You can then get one x value from the bracket, and this tells you that the other x value is 0. Here's another question for you to try. In this one, Part A just involves doing what we've been doing all the way through this clip. The answer to Part A will help you answer Part B. Press pause and have a go. When you're ready, press play. Here are the answers. You should have found that there's only one value of x and one corresponding value of y, so the two graphs only meet at one point. This tells you that the line is a tangent to the curve, and this is the answer for Part B. Now this question looks slightly different to the ones we've seen before, and the reason it looks different is because we're asked to give our answers to 2 decimal places. This alerts me to the fact that when I get my quadratic equation equal to 0, I won't be able to factorise it, and instead I'll need to use the quadratic equation formula to find the solutions. So I start this in the usual way by replacing the y here with x plus 5. I now want to rearrange this to get a quadratic that's equal to 0. Now you might notice at this stage that because all of these numbers here are multiples of 2, I could divide everything by 2 to make the numbers simpler. This is only really of value though if we're going to factorise this, and we know we're not doing that because we're asked to give our answers to 2 decimal places, meaning that we need to use the quadratic equation formula. So I'm just going to leave it as it is and use the formula. Solving this using the formula gives me these 2 values for x here. Once I've got these, I need to find the 2 corresponding values of y, and I do that using this equation. I substitute in the first value of x here to get the first value of y, and the second value of x to get the second value of y. These are then my 2 pairs of answers. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Before we look at solving quadratic inequalities, let me just remind you about how we would solve this quadratic equation. We would do this by factorising, and we would get x minus 4 and x plus 3, and that would be equal to 0. This bracket tells us that x is equal to 4, and this bracket gives us that x is equal to negative 3. So these are my 2 answers to this quadratic equation. Now, if I was asked to sketch the graph of this equation here, I would start with a set of axes. I know the shape of the graph because it's a positive x squared, and I know that it's going to cross the x-axis at 4 and at minus 3. So it's going to look something like this. I'm now going to use these 2 skills to show you how to solve quadratic inequalities. This is a typical question asking me to solve a quadratic inequality. I can't find a single value for this. Instead, I'm finding a range of values. I'm going to show you how to do this using a 3-step process. My first step is to factorise to get the critical values. I'll tell you what this actually means in a moment. For factorising, I put this equal to 0. So I've got x squared minus x minus 12 equals 0. Now I factorise this in the usual way, and I get x minus 4 and x plus 3, and that's equal to 0. From this bracket, I have x equals 4, and from this bracket, I have x equals minus 3. These are the 2 critical values. For step 2, I sketch the curve. So I want a set of axes. I know the shape of the curve because it's a positive quadratic, and I know that it's going to cross the x-axis at 4 and at negative 3. So it's going to look something like this. The final step is to use the sketch to get the answer. Remember, we're looking for where this is less than or equal to 0, so that's where the graph dips below the x-axis. So this is the part of the graph that I'm interested in, and it takes place between the x values of -3 and 4. So x is anywhere between the critical values of -3 and 4. X is greater than or equal to -3, and it's less than or equal to 4. This is my final answer. So to review the whole process, first of all, I write this equal to 0 and then factorize it to find the two critical values. I then need to sketch the curve of y is equal to this, so that's x squared minus x minus 12 in this case. I make sure that I mark the two critical values onto the sketch. I then look at this symbol to see whether I want the portion of the graph that's below the x-axis or above the x-axis. For this particular one, I wanted the part below the x-axis. I then use this to write down my final answer. I'm now going to change this question and see how it affects the outcome. So I flipped the inequality symbol around, and I'm now looking for the range of values for which x squared minus x minus 12 is greater than or equal to 0. Step 1 remains the same. I still factorise and get the two critical values. Step 2 is the same as well. I still want to sketch this curve, and it still looks like this. It's at step 3 where things start to change. I now want the portion of the graph that's greater than or equal to 0. So that's the parts that are above the x-axis. So that's here and here. The values of x will be this section here and this section here. Now when I write my final answer, I need to be a little bit more careful. I can see that x is less than or equal to -3 or greater than or equal to 4. Notice how this time, because I'm interested in two parts of the graph that aren't joined, I get two separate answers. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. This time it's greater than. Take extra care with this one because people seem to find these more difficult. Press pause and have a go. When you're ready, press play. Here are the answers. Now here are some more practice questions for you. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. If I want to find out the nth term of this number pattern, I simply look for the gaps between the numbers. So from 2 to 7 is 5, 7 to 12 is 5, 12 to 17 is 5, and so on. This tells me that it's going to be 5n plus or minus something, and I can easily work out that it's 5n minus 3. Every time the first differences are the same, the nth term will look something like this. Now this question tells me that I've got a quadratic sequence. That tells me that when I find the first differences, they're not going to be the same. Here I've got 3, then 7, and then 11. But when I find the second differences, they will be the same. I've got 4 and 4. Whenever I have this situation, I have a quadratic sequence, and the nth term will always look something like this. an squared plus bn plus c. All that I have to do now is find out what a, b and c are. To do this, I'm going to say that for the first term, n equals 1. I'm going to work out what that would be in terms of a, b and c. So I've got 1 squared times a, that's 1a, so that's a. 1 times b, that's 1b, so that's b. And c on its own. Now I'm going to find the second term. So when n is 2, I've got 2 squared, that's 4 times a. 2 times b, so that's 2b. And again, I've just got c. And I'm going to find the third term as well. So when n is 3, I've got 3 squared, that's 9 times a. Plus 3 times b, so that's plus 3b. And again, I've got plus c on the end. Now I can find the first differences between these. So from this to this, I can see that I've increased by 3a and by 1b. From this to this, I can see I've increased by 5a and 1b. Now I can find the second difference. From this to this, I can see that there's been an increase of 2a. I can now look at and compare the two diagonals highlighted here. Starting at the bottom, I can see that 2a must be equal to 4, so that tells me that a is 2. For the middle one, I know that 3a plus b must be equal to 3. I already know that a is 2, so 3a is 6, so I've got 6 plus b equals 3, and that tells me that b is negative 3. Finally, I've got a plus b plus c, and that must equal 0. I know a is 2. I know that b is minus 3. I don't know what c is yet, but I do know it equals 0. 2 minus 3 is minus 1, so c must be 1 to make 0. Substituting these three values into this gives me 2n squared minus 3n plus 1, and this is the nth term of my quadratic sequence. It's always nice to double-check your answer. What I'm going to do is check the third term of the sequence. So remember here, n equals 3. So I've got 2 times 3 squared minus 3 times 3 plus 1, and I'm hoping that this is going to give me 10. 2 times 3 squared is 2 times 9, so that's 18. Minus 3 times 3 is 9, plus 1. Now 18 minus 9 plus 1 does give me 10, so I know that my quadratic sequence has this as its nth term. Now, because this seems quite complicated when you're first starting out, we're going to work through this question together a bit at a time. The first thing I'd like you to do is find the differences and then the differences of the differences. Press pause and do this. When you're ready, press play. This is what you should have so far. Now remember, the nth term will be in the form an squared plus bn plus c. Now we want to find the first three terms algebraically. To do this, I want you to replace n with 1, then with 2, and then with 3, and write down your 3 answers. Press pause and have a go at this. When you're ready, press play. And you should have got this. Now I'd like you to find the first and second differences. Remember, you're doing this algebraically. Press pause and have a go. When you're ready, press play. You should have this. We're now going to compare the two diagonals, starting from the bottom. So we have 2a equals 6, 3a plus b equals 11, and a plus b plus c equals 5. I'd now like you to solve these three equations to find the values of a, b and c. Press pause and have a go. When you're ready, press play. You should have that a equals 3, b equals 2 and c equals 0. To finish off, I'd like you to substitute these three values into this equation here to get the nth term for the quadratic sequence. Press pause and do this. When you're ready, press play. And voila! You've now found the nth term of the quadratic sequence. Here's one for you to try on your own. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you. Press pause and have a go. When you're ready, press play. Here's the answer. Now, sometimes you get this sort of question in a context like this, and it makes it look much more difficult. The trick is to notice that they're only asking for the number of cubes in the bottom layer of each tower. Be really careful when you're working out the number for Tower 3 and Tower 4. You'll then be able to do Part B using the techniques that we've looked at in this clip. Press pause and have a go. When you're ready, press play. Here are the answers. To help me get these two numbers, I've drawn out the bottom layer of each tower as a 2D representation. I've had to flip the tower round a bit, but it helps you see the pattern. Before we look at inverse functions, let's look at reversing things. What's the reverse of yes? Well, hopefully we all know that that's no. What's the reverse of forwards? That's going to be backwards. What's the reverse of multiply by 3? Well, the reverse of multiply is divide, so it will be divide by 3. Let's check that this one works by using a number. I'm going to put 7 in, so 7 multiplied by 3 is 21. If I now put the 21 here and divide it by 3, I get back to the original 7. In the same way, the reverse of add 4 is take away 4. Again, let's check this. 7 add 4 is 11. If I put the 11 in here and take away 4, I get back to the original 7. Now, these are quite trivial examples. This one, though, is a bit more difficult than it looks. I want to know what the reverse of subtract from 20 is. Now, believe it or not, it's actually the same. It's still subtract from 20. Let's prove this again using our number. If we put 7 into this, we've got to subtract 7 from 20, and that gives us 13. Now, if we put 13 into this, we've got to subtract 13 from 20, and that takes us back to the original 7. So the reverse of subtract from is still subtract from. Try to make sure you remember this because you'll be using it later on in this clip. Now, I've been talking about finding the reverse of something. Another word for this is inverse, and in this clip we're going to be looking at inverse functions. Now, this is a typical exam question on inverse functions. So this is my function of x, and it's telling me that whatever number x is, I've got to put it in here, times it by 2, and add 5. This is asking me to find a function that reverses f of x. And we call this the inverse of f of x, and it's shown using this little -1 here. So I'm now going to show you how to find the inverse of f of x. We're going to do it using a flowchart. So to start, I'm going to show my function of x diagrammatically. So the first thing that happens is x is multiplied by 2. Then we add 5 to it. So if we put x in, we times it by 2 and get 2x. Then we add 5 and get 2x add 5. Now we're going to reverse the operations and reverse the flow. So instead of add 5, we've got subtract 5. Instead of times 2, we've got divide by 2. Now if we put x in here, we've got x minus 5, and then divide by 2, so we've got x minus 5 over 2. This is the inverse function. So our inverse function is x minus 5 over 2. And we've just made quite a difficult looking question straightforward by using flow diagrams. Now, I always like to check my answers wherever possible. To do this, I'm going to work out f of x for a number. I'm going to choose 4. So f of 4 is 2 times 4, which is 8, plus 5, which is 13. Now I'm going to put this number into the inverse function, and I should get 4. So I've got 13. 13 minus 5 is 8, divided by 2 does give me 4. So this is definitely the correct inverse function for this. Here's a question for you to try. For the first part, you need to find the inverse function of this using a flow diagram like I've just shown you. For the second part, you need to put 17 into your inverse function to get the answer. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another one for you to try. This one's a little more tricky because it's got an x cubed in it. What you need to remember is that the inverse of cubing is cube rooting. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's a very difficult exam-style question for you to try now. For this function here, notice that we've got x, we multiply it by 2, and then we have to subtract from 1. When you're doing this, remember what the inverse of subtract from is. Press pause and have a go. When you're ready for the answers, press play. Here's the answer for part A. For part B, we need to use this part here and this part here. I'm going to take you through this now. To prove that these two things added together equals 0, I need to add this to this. So I've got the inverse function of fx plus the inverse function of gx. That's 1 minus x over 2 from here, plus x minus 1 over 2. Now, because they're both over 2, I've got 1 minus x plus x minus 1 all over 2. And 1 minus 1 is 0, and minus x plus x is 0, so that's 0 over 2, which is 0. So I've proved that this equals 0. You should already be comfortable with finding the inverse of this type of function where x only appears once. To do this, you're probably using a flow diagram. However, in this clip, we're going to be looking at harder questions where x appears more than once. You can't use a flow diagram to do these. You need to follow these 4 steps. Let me show you. So step 1, I rewrite as y equals f of x. So y is equal to this. That's step 1 done. For step 2, I now want to make x the subject of this. I start by multiplying both sides by x plus 2. So I've got y multiplied by x plus 2 equals x. Now I multiply out the bracket to get xy plus 2y equals x. Now I'm going to move this term with the x in it over to this side. So I've got 2y equals x minus xy. Now I factorise for x. So I've got 2y equals x brackets 1 minus y. To finish off, I divide both sides by 1 minus y. So I've got 2y over 1 minus y, and that's equal to x. X is now the subject. For step 3, I need to swap x and y. So what that means is get this part here, and wherever it says y, put x, so that's 2x over 1 minus x, and wherever it says x, put y. That's step 3 done. The final step tells me that the expression I've just found is equal to the inverse function. So I've got the inverse function, and that is 2x over 1 minus x. This is a more difficult question when x appears more than once, but as long as you follow the 4 steps and of course get the algebra right as well, you will be able to get the inverse function. Here's one for you to try. Remember to follow the 4 steps carefully. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. So to summarise inverse functions, if x appears once in the function, then you can do it with a flow diagram if you want to, or you can use the new technique that we've just learned. If x appears more than once in the function, then you've got to use the new technique. Now try these 2 questions. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Before we look at composite functions, let's look at how functions work. These are both functions of x. This means that whatever I put into the function, I've got to square it and then add 5. This one tells me that whatever I've got for x, I take 2 away from it. So I'm being asked to find f of 3. That means I'm going to use this function here and replace the x with a 3. So f of 3 is going to be 3 squared plus 5. Now 3 squared is 9, so that's 9 plus 5, and that gives me 14. Now I want f of minus 2. So I've got minus 2 squared plus 5. Now minus 2 squared is 4 plus 5, and that gives me 9. Now I want to find g of 5, so I'm going to be using this function. I've got to replace the x with a 5. So g of 5 is going to be 5 minus 2, and that's 3. And finally for this one, I want g of 0, so I replace the x with a 0. That gives me 0 minus 2, and that's minus 2. Here are some questions for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now we're going to look at composite functions. A composite function is a function made up of 2 or more functions. So for example, this one here is asking me for f of g of 4. Now that sounds really complicated, so I'm going to write it in a slightly nicer way. So I want f of g of 4. So to be able to do this, the first thing I really want to do is find g of 4. So g of 4 means I've got to replace the x here with 4, so I get 4 minus 2. Now 4 minus 2 is 2, so really when I'm being asked for f of g of 4, I'm actually being asked for f of 2. Now f is this function here, so I replace this x with 2, and I get 2 squared plus 5. Now 2 squared is 4, I want to add 5 to that, and I get 9. So f of g of 4 is 9. Now I'm being asked for g of f of 4, and you might think that this turns out to be the same thing, but let's see what happens. So I've got g of f of 4. That means I want g of, and then I replace the x here with 4. So I've got 4 squared plus 5. Now 4 squared is 16, so that's 16 plus 5. So that's 21. So really, I'm being asked for g of 21. So looking at g now, I can see I need to replace this x with 21. So I get 21 minus 2, and that's 19. So g of f of 4 is 19, and you can see that it's not the same as f of g of 4. So to summarise, a composite function is made up of more than one function. And some people like to remember that when you're working them out, you need to work backwards. So for example, on this one here, the 4 goes into g first, and we get the answer, and then that goes into f, and we get the answer to that. For this one, the 4 goes into f first, get the answer, and put that into g. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is a slightly different type of question. I'm being asked to show that f of gx is equal to this. Whenever you're being asked to show something, remember the strategy is that you work out the left-hand side, completely ignoring this, and then hope that it works out to be this when you've finished all your working out. So I'm being asked to do f of g of x. So I don't have a number to put into my function this time. So I'm looking for f of g of x, and g of x is this. So what I now need to do is replace x in this function with x minus 2. So I've got x minus 2 squared, and then I've got plus 2 lots of x minus 2. Notice that I've kept the x minus 2 in brackets here and here. That's really important to make sure that your working out is correct. Now I'm going to simplify this. I start by multiplying out this bracket here, which gives me x squared minus 4x plus 4, and multiplying out this bracket as well, which gives me plus 2x minus 4. For this part, you might want to use some side working, which would look like this. I now want to continue simplifying this. So I've got x squared minus 4x plus 2x is minus 2x, and then plus 4 minus 4 is 0. So I've got x squared minus 2x. If I check the question, that's exactly what I was looking for. So I've shown that f of g of x is x squared minus 2x. Here's one for you to try now. This time you want to show that g of f of x is equal to this. Remember, ignore this, work out g of f of x, and it should simplify to this automatically. Press pause and have a go. When you're ready, press play. So you should have started by writing you want g of f of x. So that's g of, and then f of x is x squared plus 2x. Remember, you want to substitute this into g. So that's x squared plus 2x minus 2. Now simplifying this gives you x squared plus 2x minus 2, which is exactly what you were looking for. Here are some more for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another type of question. This time I'm asked to solve f of g of x equal to g of f of x. So the first thing I need to do is work out what f of g of x is. Tell you what, why don't you try this yourself? Press pause and have a go just at this bit. When you're ready, press play. You should have got this. Now we want g of f of x. And you can try to do this part yourself as well. Press pause and have a go. When you're ready, press play. You should have got this. Now, if we look back at the question, we want this equal to this. So what we're going to do now is put this part equal to this part. Now I want to solve this. I can see I've got x squared on both sides. So if I take x squared away from both sides, they'll disappear and leave me with this. Now, if I take 3 away from both sides, I get minus 2 is equal to 4x, and dividing by 4 gives me that x is equal to minus 0.5. This is the solution to the question. Now here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. This is a velocity time graph. We've got velocity at the side here, and you can think of that as being speed, and we've got the time along the bottom here. From any velocity time graph, there are two things that you can immediately work out: the acceleration at any given time and the total distance travelled at any given time. The gradient gives the acceleration, and the area under the graph gives the distance travelled. Let's look at finding the acceleration now. On this particular graph, we've got 3 different accelerations. This part here, then this, and then this part here where it's actually slowing down. Acceleration is measured in meters per second per second. We prefer to write this as meters per second squared. Let's find the acceleration for this section of the graph here. We know that the acceleration is given by the gradient, and we know that the gradient of a line is given by the change in y divided by the change in x. Now the change in y for this section here is positive. It goes from 0 to 12, so the change in y is positive 12. The change in x is also positive. It goes from 0 to 6, so the change in x is 6. So the acceleration is given by 12 divided by 6. This is 2 meters per second squared. If we look at this section of the graph now, we can see that it's horizontal. That means it has no gradient, so the acceleration is 0 meters per second squared. That means that here, the thing is travelling at a constant speed. In this section, the object is slowing down. We can see that this time, the change in y is negative. It's minus 12. And the change in x is still positive. It goes from 16 to 24, so that's 8. So the acceleration here is minus 12 over 8. That's minus 1.5 meters per second squared. We're now going to look at calculating the total distance travelled. This is done by calculating the area under the graph. Now I can find the area here in 2 ways. I could see that I've got a right-angled triangle here, another right-angled triangle here, and then a rectangle in the middle. I could find the 3 separate areas and add them together. However, it's much quicker to notice that this is parallel to this, so we've got a trapezium, and we know the formula for finding the area of a trapezium. So the area is given by a half a plus b multiplied by h. So we've got a half times a, which is this distance here, and that's 10, plus b, which is this distance here, and that's 24, times h, which is the height, and that's 12. So I've got a half times 34 times 12. So that's 17 times 12, and that's 204. Now, because the velocity was given in meters per second, we know that the distance travelled is 204 meters. Here's a question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For part A, you should have worked out the area under the graph and got 228, so the distance travelled is 228 metres. For part B, you just needed to find the gradient of this part of the graph here, and that's 3, so the acceleration is 3 metres per second squared. Now this is a harder type of question because we've got non-constant acceleration. What I mean by that is that in this section here where we've got a straight line, we have constant acceleration. However, here, where we've got a curve, the acceleration is changing all the time. We're being asked to find an estimate for the acceleration at 2 seconds. So that is at this point here. So what I really want to do is find the gradient of the graph at this point. To do this, I need to draw a tangent to the curve. Like this. If you draw the tangent accurately, you can see that it gives you the gradient of the curve at this point here. Remember, to find the gradient of this line, we need a change in y divided by a change in x. So what we need to do is draw a right-angled triangle using this line or part of it as the hypotenuse. For example, we could use this, or indeed any other right-angled triangle. I'm going to use this one here. The key to finding this gradient correctly is working out what each little square is on the scale. I can see that this scale is the same as this scale, and that we go from 0 to 2 in 5 little squares, so each little square must be 0.4. I'm going to use this now. So I want to find the change in y. I can see that I'm going from 6 to 12, so that's 6, and then approximately one more little square, which we know is 0.4. So that's going to be 6.4. Now for the change in x, I'm going from 2 to 6, so that's 4. So the acceleration is 6.4 divided by 4. And this gives us 1.6 metres per second squared. You should get approximately the same answer even if you use a larger or smaller triangle. Here's one for you to try now. I want you to find an estimate for the acceleration at 6 seconds. To help you do this, I'm going to draw the tangent for you. That's here. And to help you even further, I'm going to give you the triangle to use as well. That's here. Remember, you need to find the gradient of the tangent. Press pause and have a go. When you're ready, press play. You should have an answer of 0.6 metres per second squared. Now, we know how to find the acceleration at any point in the journey, and we know how to find the total distance travelled. But this question is asking me for the average speed. How am I going to work this out? Well, I know that speed is the distance divided by the time. I know that the time taken is 24 seconds because that's here. I can work out the distance travelled by calculating the area under the graph. The only problem is that we've got a curvy part to the graph, so this makes calculating the area under it a little bit more difficult. Now, fortunately, they've only asked me for an estimate of the average speed, so this means I can have an estimate of the distance. So I'm not going to count every single little square. Instead, I'm going to try to cut up the area here into manageable pieces. My first manageable piece will be the area under the straight section. So that's here, and we can see that we've got a trapezium. Now, for the curved section, I could do a triangle. But if I find the area of this triangle, I'm missing out quite a large bit on this particular graph. So instead, I could go for another trapezium here, and then a triangle. This would be fine and I'd get all the marks for this. But because I'm a perfectionist, I can see that I could do yet another trapezium here and then a small triangle on the end. This gives me 4 sections, 3 trapeziums and a right-angled triangle, and I can find the areas of each of these sections. So I'm going to start by finding the area of this trapezium here. Now I want to find the area of this trapezium here. It's a little bit more awkward than the last one because the parallel sides are here and here. So this time I still have the same formula. I still have a half times, but this time A is this distance here, that's 10, and B is this distance here, that's 12, and H is actually this distance here, that's 8. So I've got a half times 22 times 8, that's 11 times 8, which is 88. Now I do this trapezium in a similar way to this one. I get 32 for this area. The last thing I need to do is calculate the area of this right-angled triangle here. I get 6 for this area here. So remember, I'm trying to find the total distance travelled, and that's the total area. To do this, I add all of these together. I get 222. To find the speed, I need to divide this by the time. The time is 24. Using a calculator, I get the answer 9.25, and the units for this will be meters per second. Just out of interest, the tricky part of this question was finding the area under the curved section of the graph. I've done it in 3 sections. The more sections you use, the more accurate your answer will be, but you could get away with just doing 2 sections. As long as your final answer is reasonable, you'll still get all the marks for the question. Here's a question for you to try now. Most people would split up the curved section in this way. Press pause now and have a go. When you're ready, press play. Here's the answer. Now this is a much more difficult looking question because we don't have a graph. However, if we can work out how to draw our own graph, then that will make it into something that we can do. I'm going to use a line-by-line approach to drawing the graph. The first line tells me that a car has an initial speed of u meters per second. This tells me that it's going to be a velocity time graph. So I'm going to have velocity here and time here. And the initial speed of the car is u, so let's say that's about here. It accelerates to a speed of 1.5 u in 8 seconds. So 1.5 u is about here, and the car's going to accelerate to that speed in 8 seconds. The car then travels at a constant speed of 1.5 u for 16 seconds. So it's going to travel along like this for a further 16 seconds, which will take it to 24 seconds. The next line says, assuming that the acceleration is constant, which I have because I used a straight line here and here, show that the total distance in meters travelled by the car is 34 u. Now I know that the total distance travelled is the area under the graph. So what I've got to do is calculate the area under the graph and hope that it comes out to be 34 u. I can see that the area under the graph is already split into 2 convenient sections. So I'm going to do this part first. This is just a rectangle. So this distance here is from 8 to 24, so that's 16. And this height here is 1.5 u. So the area is 1.5 u times 16. 1.5 times 16 is 24, so that's 24 u. Now for this area here, I've got a trapezium. I've got 2 parallel sides here. This one has a height of u, and this one has a height of 1.5 u. So the area of this section here is given by a half a plus b h. So that's going to be a half times u plus 1.5u times h, which is 8. So that's a half times 2.5u times 8. Now, to make this more straightforward, I can do the half times 8 first, which is 4, and then times that by 2.5u, which gives me 10u. So the total area under the graph is 10u plus 24u. And that's 34u, which is what I was looking for in the question. Remember, when doing a question like this, where you're asked to show the answer, you must make sure that you show all of your workings, because it's this that gets you the marks. Here's one of those for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. We're now going to look at rates of change in a variety of contexts. For this question, we're looking for the rate of the decrease of depth at 1.5 seconds. We can think of this as the instantaneous rate of decrease. In other words, the rate of decrease at an instant in time, and that instant is 1.5 seconds. So what we're going to do is draw a tangent to the curve at the 1.5 seconds point. So here's my tangent to the curve at 1.5 seconds. Now we just need to find the gradient of this tangent, and this will give us the rate of the decrease of depth. To calculate the gradient of the tangent, we need to get the change in y and divide it by the change in x. To do this, we need to draw a right-angled triangle. Now it can be any right-angled triangle that you can draw on this tangent. So for example, here's one, and here's a different one. I could use any right-angled triangle and I still get the same answer. For this question, I'm going to use this right-angled triangle. Remember, the gradient is the change in y divided by the change in x. So first of all, I need to work out what the change in y is. So I need to look at this scale really carefully. I can see that we go from 0 to 1 in 5 little squares. So each little square here is worth 0.2. So my change in y is 1, 2, 3, 4, 5, 6, 7, 8, 9 little squares. So that's 1.8. Now for the change in x, I need to look at this scale here. I can see that we go from 0 to 1 in 10 little squares. So each little square here is 0.1. This time I've got 5, 10, 15, 20, 25, 27 little squares. So this is 2.7. So the gradient is the change in y, that's 1.8, divided by the change in x, that's 2.7. And this is 0.7. The units are centimetres per second. This is the rate of decrease of depth at 1.5 seconds. You'll notice that the question asks for an estimate. This is because everybody might draw a slightly different tangent. It's really important to leave all of this in because this is your working for your question and backs up where you get your answer from. Here's a question for you to try now. To help you with this, I'm going to draw the tangent for you, and I'm even going to help you by drawing the triangle as well. Now press pause and have a go at it. When you're ready, press play. Here's the answer. Remember, when you're given a distance time graph or a velocity time graph, the question might not mention rates of change. Instead, the rate of change on a distance time graph is called the speed or the velocity, and it's measured in meters per second. The rate of change on a velocity time graph is called the acceleration, and this is measured in meters per second squared. So here's a question on a distance time graph for you to try. Again, to help you, I'm going to draw the tangent for you, and the triangle that you should be using. Press pause and have a go at this one now. When you're ready for the answer, press play. Here's the answer. Please remember when you do this kind of question in an exam that the tangent is your working and you absolutely must show it on the graph. Here's a question on a velocity time graph. Notice that it's asking for the acceleration. Remember, this is just the rate of change for this particular graph. To help you, I'm going to draw the tangent and the triangle. Now press pause and have a go. When you're ready, press play. Here's the answer for that one.